So Will, when I hear the recording has started, this is when I start, right?
Correct.
Okay.
Just about a little less than a minute.
Mm-hmm. Good morning, everyone. My name is Ala Kamel, and I am serving as the designated federal official to the U.S. EPA Science Advisory Committee on Chemicals, SACC. For this meeting and in my role, I will be opening the second day of the public meeting on the Science Advisory Committee peer review of the draft risk evaluations for 134678 hexahydro, 466788 hexamethyl cyclopenta gamma 2 benzopyran, which is known as HHCB, and phthalic anhydrides, and the draft hazard assessments for orthodichlorobenzene and paradichlorobenzene. I'd like to repeat that SACC meetings are subject to all requirements of the Federal Advisory Committee Act, FACA, and these include open meetings, timely public notice of meetings, and documents availability to the public. All documents are available to the public in the docket at regulations.gov with the docket number listed on the agenda. And as a reminder, this meeting is being webcasted, transcribed, and recorded. And a live stream of today's meeting is available on YouTube, and you may access the link through the SACC peer review webpage listed in the agenda. I'd like to thank Dr. George Cobb for facilitating the sessions yesterday and the EPA team for presenting the draft risk evaluations and draft hazard assessments under peer review. And I would like to thank the SACC for their questions and discussions with the EPA team. Today, we will continue the last part of EPA's presentations on the draft risk evaluations of HHCB, and we will follow that with the public comments, and then we will start discussing the charge to the SACC. And now I will hand it over to Dr. George Cobb to start today's discussion. Dr. Cobb.
Thank you, Dr. Kamel, and welcome everyone to our second day of meetings. Yesterday we had a robust discussion and some very nice presentations from EPA. Today we will continue with that and also hear from some public commenters before getting into the actual charge questions. But before we start, I simply need to do a roll call. Dr. Apti.
I'm here.
Dr. Fong.
Yes, I'm here. Good morning.
Dr. Baker.
I'm here.
Dr. Chason.
I'm here. Good morning.
Dr. Fox.
Good morning. Here.
Dr. Gentry.
Here.
And Dr. Gentry is going to be leading some of our discussions, maybe today, but more likely tomorrow. Dr. Graham.
Good morning, I'm here.
Dr. Graham, I did not skip you today.
I noticed that.
We'll see if I can get all the way through this. Dr. Jenkins.
Good morning.
Dr. Lee.
I'm here. Good morning.
Dr. Michette Nieves.
Good morning.
Dr. Ottinger.
Good morning.
Dr. Prisbilla.
Good morning, present.
Dr. Rubin.
Good morning.
Dr. Samuel.
Good morning. I'm here.
Mr. Wright.
Good morning.
Dr. Gadia.
Good morning. Here.
Dr. Islas Robles.
Good morning. I'm here.
Dr. Carmaus.
Good morning. I'm here.
Dr. LaRocca.
Good morning.
And Dr. Lovato,
I'm here. Good morning.
Dr. Pandiri,
Good morning. I'm present.
Dr. Rager,
I'm here.
Dr. Slink,
Good morning.
Dr. Shao,
I'm here.
Dr. Strickland,
Here, thank you.
and Dr. Wolf.
I'm here.
Okay, looks like everyone's here. So thanks everybody for joining. And we've got more presentations today, but I understand EPA has some clarifications from some of our questions or answers to some of our questions that we had yesterday. So if EPA is prepared to provide those responses, we can do that now.
Hi, Dr. Cobb. Thank you. Ashley Pepperell, EPA. EPA would like to provide clarifications from the day one meeting yesterday. So EPA would like to provide clarifications for the SACC from day one, June 8th, 2026 for the record.
Yes, that's great. Please provide those as you have them.
Okay. So we have some for DCBs, for phthalic anhydride, and then HHCB. For DCBs, the EPA would like to provide clarification to the questions regarding the association between p-DCB exposure and cancer and epidemiological studies, which were asked by the SACC panelists. EPA's response: EPA refers the SACC to section 2411 in the draft Human Health and Environmental Hazard Assessment for p-dichlorobenzene, US EPA 2026. Epidemiological studies investigated the association between p-DCB exposure and multiple cancer studies. Only one cross-sectional study, Prigden et al. 2023, found a potential correlation between p-dichlorobenzene exposure specifically and any cancer in the form of endocrine-related female cancer. However, this was a cross-sectional study that did not demonstrate causality. No epidemiological studies investigated any type of liver cancer, the target for CAR-mediated carcinogenesis in mice. There is no direct evidence showing that p-DCB exposure can cause any cancer, especially for liver tumors. Moving on to phthalic anhydride. EPA has clarifications regarding occupational exposure to the phthalic anhydride discussed yesterday. First clarification: what is the particle size of phthalic anhydride? EPA did not identify any particle size distributions for phthalic anhydride. However, the material may exist as a flaked solid, crystalline form, or powdered form. Each of these types of solid phthalic anhydride have different shapes, sizes, and particle distributions. Therefore, it is expected that a wide range of potential particle sizes for phthalic anhydride in solid form. The second clarification is the duration of the bag handling task. As noted in section 3142 of the draft environmental release and occupational exposure assessment for phthalic anhydride by Nielsen et al., 1988 conducted a study in plants producing alkyled and unsaturated polyester resins, and the study reported that workers may handle bags for up to 30 minutes, 2 times per day. Further, the sample durations for inhalation exposure measurements of bag handling activities reported by Reitz et al. 1985 were 1 to 2 hours, and it is expected that worker will not handle bags of phthalic anhydride for longer than 2 hours per work shift. Additional clarifications related to the phthalic anhydride assessment are further provided. Additional clarification related to dermal surface area relative to the sensitization hazard, as well as a virtual facility tour from a manufacturer, ExxonMobil, is provided on the chemical-specific docket for phthalic anhydride. Docket number is EPA HQ OPPT 2018-0459. EPA refers the SACC to the following materials posted on that docket for additional information related to these discussion topics. And so clarification of the relevance of the surface area on the dermal hazard for dermal sensitization provided for the record from Dr. Frank Gerberek, GF3 Consultancy LLC, is hyperlinked in the document that I'll provide. And the second point, the ExxonMobil virtual tour to EPA of the chemical manufacturing plant in Baton Rouge, Louisiana, where phthalic anhydride is used as a reactant for plasticizer manufacturing. The tour was intended to provide EPA with more information related to worker exposure scenarios. And the hyperlink to that is provided. For HHCB, EPA is providing clarifications related to the HHCB surface water assessment. First, how representative are the wastewater treatment levels referenced in the document? EPA's response: according to the Clean Watershed Needs Survey, over 99% of participating POTWs report secondary or advanced treatment, indicating high solids removal and aligning with greater than 90% HHCB removal efficiencies as cited in section 246 of the draft physical chemistry, fate and transport, environmental release and environmental exposure assessment, or HHCB. In section 246, the wastewater removal discussion references common POTW treatment categories rather than naming each specific unit process. The 92% value is intended to characterize systems with at least secondary treatment. Systems with only primary treatment are more appropriately represented by the 50% removal assumption as noted in section 246. The second clarification question is, why does the modeled surface water distribution exceed the monitored surface water distribution by so much? EPA's response: because the monitoring and model distributions represent different scenarios, they are not directly comparable. The resulting modeled estimates greater than monitoring concentrations are due to compounded conservative assumptions. These conservative assumptions were selected because HHCB water assessment was conducted using a tiered approach for risk analysis, for which refinement was not warranted. Section 1427 of the draft risk evaluation for HHCB discusses conservatism specifically with the consumer down the drain release values. The third clarification question: there was a request for a summary of the surface water monitoring data. EPA's response: please see section 43111 of the draft physical chemistry, fate and transport, environmental release and environmental exposure assessment for HHCB. The complete water quality portal dataset for HHCB is included as supplemental file 31. Clarifications related to HHCB bioaccumulation. The question is, what did EPA use for the metabolism rate for the OECD reference study by Van Dyck 1999 as input into KBAM, which is or KOW-based aquatic bioaccumulation model? EPA's response: Van Dyck 1999 used carbon-14 radiolabeled HHCB to measure uptake, bioaccumulation, and depuration in fish. Depuration is measured after transferring fish to clean water to track the decline in carbon-14 labeled HHCB, was used to estimate the overall elimination rate constant, or KD. To calculate KM, the metabolic rate constant, in Appendix D, EPA used KT equals to 0.748 for total bluegill elimination rate constant estimated from the Van Dyck 1996 study. K2 equals 0.261 bluegill elimination rate of HHCB through respiration from Van Dyck 1996. And the remaining parameters were obtained from KBAM model calculations. This approach follows Arnott et al. 2008, equation H4, as described in Appendix H2 of User Guide and Technical Documentation KBAM version 1, 2009. Second question: does ADME-B have a bioavailability component beyond KOW? EPA's response: ADME-B does not explicitly parameterize bioavailability. It relies on KOW and assumes that all HHCB in the water column is bioavailable. ADME-B also accounts for dietary HHCB exposure. For the dietary input, EPA used the highest measured concentration in fish of 2,100 microgram per kilogram. Taken together, these choices represent high-end inputs for uptake via both gills and diet. Next question: what is a non-metabolized reference compound used in ADME-B? EPA's response: ADME-B inputs include an option for choosing whether the OECD guideline study included a reference compound or not. The use of non-metabolized reference chemicals in the dietary bioaccumulation dictates the derivation of biotransformation rate constants in the reference by the OECD study, Gobas et al. 2020. Schneider et al. 2021 used a reference chemical which was HCB, or hexachlorobenzene, CAS number 118741. And this concludes EPA's clarifications for the record. Thank you.
Excellent. This is George Cobb. Excellent. Thank you for those responses. I really want to thank EPA for turning those responses around so quickly. That was a lot of information to respond to, and I really appreciate you and your team pulling that together and providing that for us first thing this morning.
You're welcome.
Let's circle back to the committee. Some of the folks that asked those questions first, and are there any clarifications or further things that we need to clear up about the relative to those answers from the committee? Dr. Schlink.
Yeah, the question I had is, how do I get to file 31 for 4.3.1.1? What I'm trying to find is the tabular data that created figure 4.5 and 4.6 in that section. And that was what I was looking for. And I spent all night last night looking for those data, and all I could find was a 2014 table that actually had some description of the sites, but it didn't have the description of the California site or the Texas site, which was in the text of the physical fate document. I couldn't find the actual numbers. I couldn't find where the 25.4 came from. I guess that's the bottom line from that particular site. The question I have is, did it come from the Trinity River? Because it's kind of important for question 17 as well, for the estimates for the worst case scenario. So if you can give me some help on trying to find that supplemental file 31, which it sounds like that's where the data came from, that would be great.
Okay,
Hey,
go
this is
ahead,
Karen
please.
Eisbeck from the EPA. We can pull those files, they're all in the docket, but we can pull those files and send them to Ola, and he can make sure that you have more clear access to them. So you're looking for the one supplemental document, and anything else in particular?
No, mainly what I'm looking for, Karen, is basically the site that the sample was taken from. If it's a worst case scenario site, which I think it is, but it's hard to say from the text and from the figure 4.5 and 4.6. 4.6 just has dots, right? It doesn't tell you where those dots are. I mean, it shows it's in Texas, and it looks like it's the Trinity River, but and the California site, it says a waterway in California, but was it the Santa Ana River site, which I would predict it would be, but I couldn't find that confirmation anywhere.
Okay. I think
that's what I'm looking for.
you need, and we'll make sure that we get those files more easily to you.
Thank you. Sorry to be a pain.
Yeah, no worries. Thank you.
All right, thanks for that discussion, everybody. Dr. Chason.
Thanks again to EPA for providing this information. It's very helpful, and I think Dr. Schlenk gets the award for persistence here for the model. Anyway, Dr. Cobb, I'd like to take a look again at the work, given the responses that we heard today. If we have additional questions, can we send them to you or Dr. Alla if we have other detailed questions to be, how could we do that? I just want to make sure don't want to have a protocol problem.
Let's talk about that offline, Chris.
Okay.
Dr.
Right.
Chason.
I mean, I may not, because they did answer most of this, but I just want to sort of take a fresh look back through that whole thing after the conversation. And I really do appreciate their attention so quickly to this. That's very helpful. Thank you.
Dr. Rubin?
Yes, thank you, Dr. Rubin here. Thank you to EPA for those responses. And I just wanted to ask a quick follow-up question on the EPI studies question. I wonder if you can provide the rationale for filtering studies with fewer than 3 exposure levels.
Hi, this is Karen Eisenreich, EPA. Our epidemiologist is not online right now, so we'll have to get back to you, but we'll get back to you as soon as we can, taking note of your question.
Okay,
Sorry about that.
No problem.
Okay. So, and now traditionally we circle back to the committee to see if there are any other clarifications from yesterday that may have gotten missed that want to get brought up now. Okay. If there are none, then we can proceed to the remainder of the EPA presentations. And my understanding is that we're at occupational exposures for HHCB, and Dr. Hollinshead will present for us today.
Hi, this is Dr. Whitney Hollinshead. I'm an engineering assessor in the existing chemicals risk assessment division. I'll be introducing the iterative tiered approaches that were used to screen for risk for the human exposure, focusing on the occupational exposure assessment for HHCB. Next slide. So this portion of the presentation will cover the topics related to charge question 18 on the screening approach used for the occupational risk assessment. Next slide. So you're looking at the document map for HHCB. The TSD, the human exposure assessment, contains the occupational exposure, and the human health risk assessment within the risk evaluation are the relevant documents for charge question 18. The relevant sections are sections 2.1 and Appendix E in the draft human exposure assessment, as well as sections 3.3.1 and 3.4.2 in the draft risk evaluation. Next slide. In TSCA risk evaluations, multiple conditions of use, or COUs, are assessed for a high priority substance, from the manufacturing to the use of products containing the substance. For HHCB, an iterative tiered approach for the human exposure assessment was applied, as introduced earlier by Brian Goza. Following this flowchart as shown, step 1 of the process that we took for HHCB was that we did a qualitative assessment. So for each condition of use, we identified the relevant exposure scenarios and reviewed the reasonably available data. A full data collection for all scenarios are still required with this approach, which allows us to analyze the exposure potential for all scenarios. I'll be going over the exposure factors considered in the next slide. Moving to step 2, we did select the exposure scenario with the highest potential exposure by weighing the different factors which contribute to exposure potential. And I'll be covering that in the next few slides as well. In step 3 of this process, EPA calculates risk estimates. In the HHCB occupational assessment, the risk estimates did not indicate the potential for risk to human health when compared to the relevant benchmarks. Therefore, additional refinement and/or evaluation of additional exposure scenarios was not warranted. Next slide. So these are in general qualitative assessments considerations. So this is what was discussed in step 1. In this, you can find our specific one for HHCB in Appendix E of the draft human exposure assessment for HHCB analysis for each COU. For each potential physical form, vapor, mist, and/or dust, we consider the relevant worker activities task, proximity to the source of exposure, daily volume of HHCB handled, duration and frequencies of exposure, the concentration of HHCB in the raw, intermediate, and final materials of the process, the vapor pressure and the process temperature. And things that could be considered, for other chemicals would be scenario-specific factors, including the spray mechanism, level of automation and closure, or particle size. Next slide. For vapor inhalation for HHCB, we selected the scenario of formulation of fragrance oil as the occupational exposure scenario with the highest exposure potential for vapor. This scenario serves as a sentinel high-end case to represent the upper bound across OESs. The selection was based on 4 key factors. The first factor considered in selecting the OES was the HHCB concentration represented in the first box. The higher the concentration of HHCB, the higher the expected potential exposure. Through our review of the data, we identified that formulators of fragrance oils often handle near-neat HHCB when blending into fragrance oils. Other scenarios such as manufacturing or repackaging of HHCB are also expected to handle HHCB at high concentration. However, later processing scenarios handle lower concentrations, typically weight fractions of 5 to up to 60% HHCB for fragrance oil use. And commercial and consumer products typically contain less than 1% HHCB. The second factor we considered was the elevated temperatures used for activities occurring under this OES. An elevated temperature raises a chemical's vapor pressure, resulting in higher potential for exposure via vapor. This is represented in the second box. The unloading of concentrated HHCB is typically done at elevated temperatures to reduce its viscosity, up to 167 degrees Fahrenheit per the 2008 EU risk assessment report on HHCB. This increases vapor pressure and its inhalation potential. At room temperature, HHCB is a semi-volatile chemical with a low vapor inhalation potential. So most scenarios that are conducted at room temperature therefore have low vapor pressure potential or vapor exposure potential, so exposure via vapor. The third factor was the high volume of chemicals attributed to this OES. High daily batch volumes increases the potential for exposure. We estimated for the fragrance oil formulations, they can involve batch volumes up to 1,500 kilograms per day per site. For manufacturing and repackaging, daily volumes were more uncertain. Majority of CDR sites indicated importation of HHCB, and the evidence that we have for repackaging should be comparable to the formulators. Lastly, for this scenario, the frequency of exposure was a factor in its selection, represented in the fourth box. Chronic exposure is the exposure of interest for this assessment, and they are higher when the activities are more frequent. So for this scenario, workers handle HHCB repeatedly as part of their daily work activities. In conclusion, we use the formulation of fragrance oils as a high exposure screening scenario for vapor inhalation. This working scenario also provides a useful upper bound when considering potential consumer exposures for vapor inhalation, given the lower HHCB concentration and typical absence of elevated temperatures in consumer use. Next slide. Workers may also inhale HHCB via mist and dust, and there are different considerations for those. Mist exposure will be covered in the consumer exposure assessment. Here I am focusing on dust. Dust can be generated when handling HHCB containing plastic pellets that's caused by abrasion during handling and transport, or by handling of powder products. EPA conducted a qualitative screen of these scenarios to identify the highest potential dust exposure. We selected the plastic compounding and converting as a protective high dust scenario for the 3 reasons. The first factor considered in selecting the OES with the highest exposure potential was the HHCB concentration, which is represented in the first box. Plastic pellets contained higher weight fractions of HHCB than levels found in commercial and consumer powder products. Note, we only found 1 powder product with concentration data, and that was a consumer stain reliever with less than or equal to 0.1% HHCB. The second factor considered in selecting the plastic compounding and converting OES was the high volume of chemical attributed to this OES. Plastic manufacturers are likely to handle larger quantities than other applicable scenarios, which increases dust generation and exposure potential compared to the use of commercial powder products. Lastly, the frequency of exposure for this OES was a factor in its selection. That's represented in the third box. The worker exposure for this scenario are expected to be more frequent due to repeated handling events, whereas other commercial consumer use may be more intermittent. Taken together, these factors make plastic compounding and converting the most appropriate scenario to screen for dust-related inhalation risk. Next slide. Thank you for your attention. I'll take it back to the chair.
Thank you. And I'm sorry for the delays. My screen somehow is not responding as quickly as I would like. So thank you for providing that information for us. Are there questions from the committee? If there's none from the other committee, I have one question, and that is related to the commercial products. You mentioned that there were no commercial products or only one that had a weight fraction or a percentage. Was any attempt made to require that information or to request that information from the different manufacturers that had HHCB in their products?
Thank you. This is Dr. Whitney Hollenshed again. So we did quite intensive product search. So that is in a supplemental file, and I can give you the number 22, and that covers all the products we found. We didn't find many powder products. We did find a lot of products, but it was just the powder products. We didn't see HHCB in a lot of those products.
So that wasn't the question.
Oh.
The question was, you said there was only one, but was that the only product that had HHCB in the product list, or is that the only one that had a fraction of HHCB listed?
I'd have to look. So I have to get back to you. This is still Dr. Whitney Hollenshed. I'd have to get back to you on that. What I recall is that there weren't many powder products.
Okay.
So most products were liquid products or articles.
Okay. And then the follow-up, the real question is, did EPA make any attempt to get that information from the manufacturer?
I'd have to follow up with you again on that one as well. I think we did most of our searches via online public searches. We weren't able to find a lot of products because of a California law. So even though we might not have the concentration data, we do know that because they have to provide ingredient disclosure forms, we do know that they had HHCB in them.
Yeah, excellent. So thank you, and I look forward to receiving the answer to that question at some point. I don't think it's time critical, but at some point. Dr. Gotti.
Thank you. If you can go back to the previous couple of slides, I have a quick clarifying question in terms of exposures. Since HHCB is a viscous liquid, would you still expect it to be as a dust exposure, or is it a mist that you are looking at?
This is Dr. Whitney Hollenshed again. So for most scenarios, we wouldn't expect dust. It is a viscous liquid. That's why they heat it. I'm getting little notifications on my computer. That's why they heat it. So no, I would not expect dust in many scenarios. So we're looking at dust mostly in the plastic compounding and converting, or where if they're handling a powder laundry detergent, any kind of powder product, there might be dust from those products. But outside of that, if it's any liquid handling, we're not expecting dust.
Okay, thank you.
Okay. Well, if there are no further, I see Dr. Rubin, sorry.
Hi, Rainbow Ruben. One question, or no, two actually, quickly. What was the rationale for not conducting a dermal assessment, evaluating the dermal route of exposure?
So this is Dr. Winnie Hollish again. I think the dermal will be covered later, so we're gonna be covering that in the presentation.
Okay, great. And then was there any consideration of evaluating exposure among domestic workers?
This is Dr. Winnie Hollish again. So domestic workers, I'm assuming you mean like using cleaning products. And so the basis for occupational assessment is that would be covered in the two scenarios that we estimated. So those exposures should be lower than what we estimated.
Okay, thanks.
Hey, seems there are no additional questions. Thank you for the information and for answering these questions. And now we can proceed to the screening assessment for HHCB and air fresheners. And Dr. Morales will present.
Good morning, everybody. My name is Giovanni Morales. I am an exposure assessor in the Existing Chemicals Risk Assessment Division, and I will provide a summary of the screening assessment used to assess HHCB exposure from the use of continuous action air fresheners. Next slide, please. This presentation focuses on charge question 19. The relevant documents to reference for additional information are linked on the right. Next slide, please. The sections and documents relevant to charge question 19 are section 2.2 and appendix B and the draft human exposure assessment, as well as sections 3.3.2 and 3.4.3 in the human health risk assessment of the draft risk evaluation for HHCB. Next slide, please. The HHCB consumer exposure assessment used a tiered approach as described by Brian Groza. For the consumer exposure tiered analysis, continuous action air fresheners were the only consumer products that needed to be evaluated. For this continuous action air freshener scenario, a screening analysis was conducted using conservative input parameters to build a protective story of how the product is used in a real-world environment. Conservative values were chosen for key input parameters, including the product mass, weight fraction, duration of use, room volume, and ventilation rates. Risk estimates were then calculated for this conservative screening assessment. These risk estimates did not indicate the potential for human health risk when compared to the relevant benchmark. Therefore, the criterion for step 1 on this slide was met, and additional refinement and advanced assessments were not warranted. As a general rule, we aim to clearly list all assumptions and identify the primary drivers of our results. With that framework in mind, let's look at how we developed our screening level assessment. Next slide, please. As described in the previous slide, the consumer exposure assessment focused on defining an upper bound exposure scenario, what we call our screening exposure scenario. We targeted products with constant exposures, as those were expected to result in higher exposure levels compared to products used intermittently. Since HHCB is a semi-volatile and persists longer in indoor air as an aerosol than as a vapor, continuous action air fresheners were selected as the product with the highest potential inhalation exposure. They release HHCB into the air continuously over an extended period of time. Non-aerosol products may have higher HHCB concentrations, but were not evaluated because vapor inhalation is considered a minor pathway. For the screening assessment, EPA selected the highest identified weight fraction for continuous action air fresheners based on publicly available safety data sheets, or SDS. EPA modeled a small 15 cubic meter room volume similar to a dorm room and applied low ventilation rates, assuming 45% of air is exchanged hourly. These assumptions were made to support the screening assessment, which had the goal of estimating an upper bound exposure concentration. These conservative assumptions estimate an upper bound exposure concentration that would capture potential exposures in residential and commercial spaces, such as hotel lobbies or vehicles. EPA assumed daily, continuous use of the air freshener product for 1 full year. This assumed duration for the duration of exposure that would represent a true upper bound scenario, capturing high exposure groups like commercial truck drivers who reside in sleeper cabins for extensive periods, or homebound individuals such as the elderly, infants, and the severely ill. Combining these factors, our selected scenario, as illustrated in the graphic on the right, is 24/7 exposure from continuous action air fresheners in a small room. And by modeling for this highest exposed individual, we ensure that the assessment is protective of other of bystanders and other users from different environments. Next slide, please. Thank you for your attention, and I will now take any clarifying questions.
Excellent. Thank you for that presentation. Are there questions from the committee? Dr. Gadia.
So the Research Institute for Fragrance Materials have conducted a news survey for different product categories, which come from all the large manufacturers of fragrances and personal care products. And they have the maximum use survey limits, or rather exposure data. Has EPA considered that in their assessment?
Yes, this is Dr. Giovanni Meirelles from EPA speaking. Yes, we did consider the, I believe that's the RIFM or RIFM.
Yes.
Yes, we did consider their report as we had some meetings with them through which we were provided their reports. Thank you.
Okay, thanks.
Dr. Rubin?
Hi, Rainbow Rubin. So just to clarify, there were minor contributors that were not considered. And so these included things like air fresheners in motor vehicles and laundry scents, all of those. Is that correct?
Yes, this is Dr. Giovanni Meirelles speaking. Yes, that is correct. We did find some paper, I guess you'd call them paper tree or article air fresheners that are typically used in vehicles. We considered that as part of the assessment, the qualitative assessment, but we did not incorporate that into our quantitative assessment as they did not yield high enough concentrations. We didn't expect for them to yield high enough concentrations to be protective of other scenarios. And the same goes for the laundry products as well.
Okay, and then were those minor contributors aggregated at all?
We did not aggregate those minor contributors.
Okay, and is there a reason for that?
The assumption is that the high end or upper bound scenario that we considered would be protective of these other scenarios. But we do look forward to any feedback that you may have on any other considerations that we could consider for the final draft.
Okay, great, thank you.
As a follow-up, Dr. Meirelles, you were assuming 24/7 exposure in your high-end scenario, is that correct?
Yes, that's correct.
And so that may help answer Dr. Rubin's question. If you have the high exposure and you have 24/7, you can't necessarily add additional exposure to that. I
Yes.
think. So let's see. Go ahead. I'm sorry.
Dr. Cobb, I think there might be some additional perspectives on what you just said. So,
Well, let us hear them then.
well, I'm not sure this is the time to debate these, but the concept of doing aggregate is not supplanted correctly by a high-end estimation on one kind of exposure opportunity with the purpose of ignoring other opportunities that do not have the same kind of profile. So I would take issue with the idea that you can just jack up the exposure in a screen and then ignore other routes of exposure to the population. So, but that's just my opinion on that, but I'd like to get that in the record. Thank you.
All right, Dr. Gentry.
I think if part of this issue and what Dr. Chason has raised, I think EPA would need to demonstrate that moving to aggregate, because those exposures are so small that they don't significantly change what that upper bound concentration is. So you're not just picking that because it's a high concentration, you're also demonstrating that these smaller exposures, when you aggregate them, it won't change that.
Dr. Gentry, this is Chris Chason again. I concur that a demonstration, in fact, that's my point. If you can illustrate that other exposure opportunities are not a significant addition, you are in fact considering aggregate, but to simply over what I fear is an urge to be too conservative and overestimate in something that's considered a screen or sentinel exposure with the purpose of covering other exposure opportunities rather than doing the calculation that you suggest. So that's just to be clear. Thank you for that.
Thank you.
Mr. Wright?
Sorry, wasn't ready. I'm not sure if this should be directed to the current presentation or the last one, but were exposures to finished air fresheners in use considered only a consumer exposure? That makes sense.
Hi, Mr. Wright. This is Dr. Giovanni Meredith speaking from EPA. No, we considered those air fresheners to be potentially used in residential spaces and also commercial spaces as well. So both a consumer and a worker could be exposed to those products.
Okay, what about as an occupational exposure? The reason I ask is I think
those would be covered by occupational spaces.
Sorry, go ahead.
Sorry, this is Giovanni speaking again. Those air fresheners would be considered an occupational use.
And what particular use in a fixed building or room or?
Right. As I mentioned in the presentation, the assumption is that someone who is, I guess, a company who is using the continuous action air fresheners in a hotel lobby, may have a product that may be leading to exposures, to continuous exposures, not just to the individuals who are walking in, but also the workers, the attendants that are working in that lobby as well.
Yeah, I think that's quite useful, but I think that you would probably find the highest exposure among truckers, especially long distance truckers. I've never been in a truck that did not have an air freshener. And a trucker is usually exposed to the air freshener, to that air freshener for the whole duration that they're driving. And sometimes if they're sleeping in the cab of the truck as well, and they're pretty close to it. So it would have been interesting to look at that as a opportunity for exposure.
This is Dr. Giovanni Meredith speaking again from EPA. We did have a qualitative assessment of that, where we considered the potential exposures to truckers who we estimate them to reside in these sleeper cabins for upwards of 300, I believe in 315 days per year. And so qualitatively, we did consider their exposure to these air fresheners.
Then forgive me, I missed that. There was a lot of reading to do, and I must have missed where you described that. Thank you.
Found in section 2.2 of the consumer exposure assessment.
Thank you. So Dr. Gotti, I had clicked in, but now you're gone. Is that no question there?
Yeah, we can clarify that later.
Okay. This is and this George Cobb, and I have a question, but it may span into the next one, but I wanna ask maybe two questions. So Dr. Morales, can you remind me what the concentration was that you computed for the high-end exposure scenario in this exercise?
Thank you, Dr. Cobb, for this question. This is Giovanni Meredith speaking. The highest concentration that we computed, that we found in SDSs was 1%.
But for the concentration in the air.
Oh, in the air. Please allow me a second to convert my team on that.
You know what? If you need to take some time to figure that out, we can cover it in the next question.
Hi, this is Giovanni speaking again from EPA, and we can follow up on that question.
Yeah. We've got some time because we're going to the next question, and this can relate to that as well. So thank you very much for having this conversation and getting the information into the record for us. And now we can move on to the HHCB Human Health Hazard Assessment by Dr. Barnett.
Right. Hello, everyone. I'm Lily Barnett. I'm a toxicologist in the Existing Chemicals Risk Assessment Division. And in the following slides, I'll discuss the Human Health Hazard Assessment for HHCB. Next slide, please. This table lists the 4 charge questions that are related to the Human Health Hazard Assessment for HHCB. It also lists the documents that are relevant to each question. And in the following slides, I'll provide a high-level summary of the supportive information that's in these documents. Next slide. For consistency, this slide shows the document map for HHCB. And on this map, the Human Health Hazard Assessment and the Human Exposure Assessment, shown in green, are the technical support documents that are relevant to the charge question that I'm discussing. Next slide, please. The next slides discuss the point of departure selected for evaluating risks from intermediate and chronic oral and inhalation exposures. This is relevant to charge question 20. Next slide, please. EPA identified decreased offspring body weight as the most sensitive and robust non-cancer hazard endpoint for intermediate and chronic exposure scenarios. Among the studies that reported decreased offspring body weight, EPA identified a 2021 extended one-generation reproductive toxicity study by International Flavors and Fragrances as the most appropriate study for dose response and POD derivation. This key hazard endpoint and study are supported by the following weight of evidence. First, in the extended one-generation study, decreased body weights were dose-dependent and biologically adverse, meaning they decreased by at least 5 or 10% relative to control animals at pre-weaning or post-weaning time points, respectively. Furthermore, these body weight decreases persisted into adulthood in F1 generation males and females and persisted until the last day of measurement, which was postnatal day 21, in the F2 generation males and females. Second, 2 additional studies that measured offspring body weight in perinatally exposed animals support the no observed adverse effect level of 26.8 milligrams per kilogram per day and lowest observed adverse effect level of 45.6 milligrams per kilograms per day identified in the extended one generation study. Specifically, a study by Ford and colleagues identified a no observed adverse effect level of 20 milligrams per kilograms per day at the highest tested dose, and a study by International Flavors and Fragrances identified a lowest observed adverse effect level of 34 milligrams per kilogram per day. Third, decreased offspring body weight in the extended one generation study is protective of other effects identified in this study. And these include delayed preputial separation in F1 generation offspring and decreased anogenital distance in F2 offspring. It is also protective of maternal toxicity noted in other studies. Finally, this developmental endpoint is protective of potentially exposed or susceptible populations, including sensitive life stages, such as pregnant women, infants, children, and adolescents. And it is also protective of potential exposures via cord blood and human milk. Next slide, please. Next, to derive a point of departure based on this key endpoint and study, EPA performed benchmark dose modeling on F1 generation offspring body weights. EPA modeled body weights from all measured time points in the extended one generation study, and this included postnatal day 1 through postnatal day 21, sexual maturation, and adulthood. At pre-weaning time points, BMDL5 values from the best fitting model ranged from 30 to 35 milligrams per kilograms per day. At post-weaning time points, BMDL10 values from the best fitting model ranged from 36 to 112 milligrams per kilogram per day. And as a reminder, BMD modeling results are summarized in section 2.4 of the draft Human Health and Environmental Hazard Assessment for HHCB. They are also described in more detail in the draft benchmark dose modeling results for HHCB, which is a supplemental file in this draft risk evaluation. Next slide, please. Of the candidate benchmark dose modeling values, EPA selected the most protective BMDL5 of 30 milligrams per kilogram per day as the point of departure for intermediate and chronic oral and inhalation exposures. This BMDL5 is based on decreased body weight at postnatal days 4 and 14. In accordance with EPA guidance, allometric body weight scaling using the 3/4 power was applied to this value to account for toxicokinetic differences between rodents and humans, yielding a human equivalent dose of 7.09 milligrams per kilogram per day. EPA calculated a benchmark margin of exposure of 30, and this was based on an interspecies uncertainty factor of 3, which accounts for toxicodynamic differences between rodents and humans, and an interspecies uncertainty factor of 10, which accounts for potential variability and sensitivity among humans. Next slide. No data are available for the inhalation route that are suitable for deriving route-specific PODs. Therefore, EPA is using the intermediate and chronic oral POD to evaluate risks from intermediate and chronic inhalation exposure to HHCB. The oral human equivalent dose was extrapolated to an inhalation human equivalent concentration in accordance with EPA's 1994 RFC methodology using the updated human body weight and breathing rate for continuous at-rest exposure from the Exposure Factors Handbook. Next slide. Now that we've covered the point of departure selected for evaluating risks from intermediate and chronic oral and inhalation exposures, the next slides cover EPA's conclusions regarding the acute hazards for HHCB. And this is relevant to charge question 21. Next slide. EPA determined that it is unlikely that any adverse effects will result following a single exposure to HHCB at concentrations relevant to human exposures. Therefore, the agency did not propose an acute hazard value. This conclusion is based on the following weight of evidence. First, no adverse clinical findings or changes in body weight were found at max doses of 2,000 milligrams per kilogram per day in acute oral and dermal studies, and at up to 5.04 milligrams per liter in acute inhalation studies. This far exceeds typical exposure levels. Additionally, no health effects were observed across the available developmental toxicity studies that were relevant for setting an acute POD. Next slide. This next slide, or excuse me, the next few slides cover two charge questions. First, I'll discuss EPA's conclusions regarding the dermal hazards for HHCB, which is relevant to charge question 22A. Then I will cover EPA's use of a flux-based approach to assess dermal exposures to HHCB, which is relevant to charge question 22B. Next slide. EPA did not derive a dermal hazard value because dermal absorption is low and because there is evidence in humans and animals that HHCB is not hazardous via the dermal route. This conclusion of no dermal hazards is based on the following weight of evidence. When applied to neat skin, HHCB did not produce any systemic effects in an OECD 402 acute dermal toxicity test at doses as high as 2,000 milligrams per kilogram. It did not produce irritation in an in vitro OECD 439 study. And it did not produce irritation or sensitization in a human repeated insult patch test. Furthermore, in studies involving mixtures of HHCB with other chemicals, HHCB did not produce any systemic effects in subchronic dermal toxicity studies at doses as high as 130 milligrams per kilogram per day, and effects in acute irritation studies and in human repeated insult patch tests were limited to mild reversible irritation that was likely due to the presence of alcohol SDA39C, which is a GHS category 2 skin irritant, and or diethyl phthalate, which produces mild skin irritation in animals. Notably, the agency's conclusions regarding dermal absorption, acute dermal toxicity, dermal irritation, and dermal sensitization are consistent with other regulatory agencies. Next slide. In addition to the lack of dermal hazards in available human and animal studies, EPA additionally concluded that HHCB is not dermally hazardous because of low dermal absorption. And this conclusion is based on the following weight of evidence. First, HHCB is lipophilic, which leads to retention on or within the skin and minimal entry into systemic circulation. Second, HHCB has low dermal absorption in human studies, although the exact value ranges depending on whether amounts retained in the skin after dose removal are included. The table to the right shows the available studies on dermal absorption for HHCB. And if we focus on the studies in human skin, which are in the top two rows of this table, we can see that both studies found that less than 1% of the applied dose of HHCB penetrated past the skin. However, if the amount of HHCB within the skin is assumed to be completely absorbable over time, then the percent absorption increases to a conservative upper bound of 8.85% or 11.28% in each study, respectively. Now, as you will see in the coming slides, additional analysis shows that much of the HHCB in the skin is not absorbed. So these 8 and 11% values actually overestimate the potential absorption. Next slide, please. Since the release of the draft risk evaluation for HHCB, EPA carefully reviewed the available data concerning the fate of HHCB that remains in the skin after dose removal. And as I alluded to previously, during this review, EPA identified further evidence suggesting that HHCB within the skin is not a significant source of continued absorption that contributes to body burden. And in the following slides, I will summarize this additional evidence. Next slide, please. The main reason why HHCB that is within the skin is not anticipated to be a significant source of continued absorption is due to reverse diffusion. Specifically, lipophilic chemicals like HHCB readily absorb into the lipid-rich layers of the stratum corneum. Once the chemical is removed from the skin surface, this causes a concentration gradient that pulls HHCB that is within the skin back towards the skin surface. And as a result, after dose removal, a certain percentage of HHCB within the skin diffuses back out over time and is not available for continued absorption into the bloodstream. This is supported experimentally by data in both rats and human subjects. And in the next slides, I'll review these studies. Next slide, please. This slide shows the fate of HHCB in rats that were exposed dermally for 6 hours. When the skin was washed at 6 hours, 79 to 81% of the applied dose of HHCB was recovered. And by the study conclusion, which was 120 hours, an additional 5.68% of the applied dose had diffused back out of the skin and into dressings. Now, this is equivalent to over half of the amount that was originally remaining in the skin at the 6-hour dose removal. Taken together, this demonstrates that a significant percentage of HHCB that is in the skin diffuses back out over time and is not available for absorption. Next slide, please. Similar to rats, when human subjects were dermally exposed to HHCB in this study, 55% of the applied dose was recovered when the skin was washed at 6 hours. And by the study conclusion, which was again at 120 hours, an additional 19.54% of the applied dose had diffused back out of the skin and into dressings. Of course, this study did not quantify the amount of HHCB in the subject's skin outside of tape stripping, so it is therefore impossible to compare the full amount of HHCB in the skin at dose removal to the amount that diffused out 5 days later, like we did for the rat study. However, this data does confirm that in humans, a significant percentage of HHCB is lost from the skin via diffusion and is not available for absorption. Next slide, please. Furthermore, if we look back at the rodent component of this study and compare the recovery of HHCB in tissues and excreta over time, we see that by 48 hours, HHCB in tissues steadily decreases, while HHCB that is excreted steadily increases. Of note, the dose level used in this animal study is much higher than the doses that humans are anticipated to be dermally exposed to. And this suggests that even at these higher doses, any HHCB that does remain available for slow continued absorption from the skin is small enough to be efficiently cleared and does not contribute significant additional body burden. Next slide, please. Taken together, EPA has concluded that the true absorption of HHCB is likely closer to the lower bound estimate of less than 1% based on amounts that penetrate past human skin. HHCB remaining in the skin after dose removal is not likely to be a significant source of continued absorption that contributes to body burden. Next slide, please. To summarize the points that I've discussed so far, EPA did not derive a point of departure for dermal risk assessment for HHCB. And as I discussed in the previous slides, this is because, number one, dermal studies in animals and humans did not identify any hazards. And number two, because EPA's recent updated analysis suggests that dermal absorption is low. EPA did conduct a dermal exposure assessment for HHCB, which is detailed in Appendix C of the draft human exposure assessment. And in charge question 22B, EPA is specifically seeking SACC input on the dermal exposure modeling methods used in this assessment. It is important to note why we are asking this question. HHCB has multiple dermal studies, and the dermal absorption is well understood. Therefore, even though EPA did not identify dermal hazards for this chemical, we recognize that this chemical is a good example for a case study to get feedback from the panel and from the public on our dermal exposure approaches. This feedback will help us quantify dermal exposure for current and future chemicals with similar properties, such as lipophilic chemicals where absorption continues from the skin after dose removal. Now that we've discussed the relevance of this question and case study for current and future chemicals, in the following slides, I will discuss EPA's approach for assessing dermal exposure for HHCB in more detail. Next slide, please. Of the available dermal absorption studies, EPA selected the in vitro dermal absorption study in human epidermal membranes for calculating dermal flux for HHCB. EPA selected this study because it was conducted in human skin, it was generally consistent with OECD Guideline 428, and because it provided time course data, which is required for dermal flux calculations. Next slide, please. When evaluating this study, EPA concluded that dermal absorption is flux limited for HHCB, meaning the skin's barrier properties are the primary rate limiting factor rather than the amount of HHCB applied. This decision is rooted in the following supportive evidence. First, looking at the bar graph on the right from this study, most of the applied dose, 81.3%, was recovered in the donor chamber, wash, and wipe, indicating that the bulk of the HHCB never entered the skin. For the portion that did enter the skin, we see a gradient through the tape strips with concentrations decreasing significantly as we move into deeper layers of the skin. Most notably, only 0.642% of the applied dose, less than 1%, actually moved past the skin samples. This was calculated by adding the 0.397% in the receptor phase and the 0.245% in the underlying filter paper, which collectively represent the portion of HHCB that's available for systemic absorption. Because the amount in the receptor phase and filter paper was so low relative to the total load, this confirms that dermal absorption is flux limited for HHCB. This also makes sense given HHCB's physical properties. HHCB is a high molecular weight compound that is not miscible in water, which would limit its ability to pass through the skin. As noted by Kissel and colleagues in 2011, when dealing with chemicals like this, the total amount sitting on the skin surface matters much less than the rate at which the skin barrier allows transport into the body. Because the skin itself acts as the bottleneck, a flux-based model provides a far more realistic assessment of systemic exposure relative to a fractional absorption method. Therefore, in alignment with this guidance, EPA chose a flux-based approach for the case study rather than a traditional fractional absorption method for estimating dermal exposure to HHCB. Next slide, please. The graph on the right shows the dermal absorption kinetics for HHCB based on the in vitro dermal absorption study. Next slide, please. Thank you. The graph on the right shows the dermal absorption kinetics for HHCB based on the in vitro dermal absorption study. The x-axis shows the 1, 2, 6, 12, and 24-hour time points that were measured, and the y-axis shows the amounts of HHCB that were absorbed past the skin and into the underlying receptor fluid at each of these time points. Using this graph, EPA derived two different flux values that were specific to our consumer versus occupational models. For consumer use, we modeled a 1-hour hand dishwashing scenario, and for this we used the average 1-hour flux, which was 6 × 10⁻⁶ milligrams per square centimeter per hour. For occupational exposure, since there was no measured 8-hour time point in the study, to account for an 8-hour shift, we used the average 12-hour flux, and this value was 2 × 10⁻⁵ milligrams per square centimeter per hour. Next slide, please. As discussed in the hazard assessment, although HHCB remaining in the skin is unlikely to be a significant source of continued absorption, for the purposes of quantifying dermal exposure, the exact duration and rate at which HHCB continues to enter systemic circulation from the skin is unclear. For example, as Ford and colleagues noted in 1999, physical actions like washing and rubbing and biological processes like reverse diffusion and the natural shedding of skin cells can remove HHCB and limit absorption. Conversely, in vitro studies could underestimate absorption because they do not account for the microcirculation that is present in living tissue. So to address this quantitatively in our dermal exposure equation, we estimated an additional occupational scenario, assuming a continuous exposure where duration and frequency of absorption is set to 24 hours a day, 365 days a year. In this worst case scenario, absorption continues post-rinsing and reapplication as expected for workers, which results in almost continuous absorption of HHCB. The results of these calculations show that even in this worst case scenario, overall dermal uptake is low, specifically 6.48 times 10 to the negative third milligrams per kilogram per day. And to conclude, once again, even though EPA did not derive a dermal hazard value for dermal risk estimates due to low absorption and no hazards in the available dermal studies, the dermal exposure assessment for HHCB presented herein represents a case study that will aid other risk evaluations. The EPA looks forward to the SACC and public feedback on this case study. Next slide, please. The next slides discuss the final topic in the HHCB human health hazard presentation, which is EPA's evaluation of HHCB using the recap weight of evidence framework. This is relevant to charge question 4B. Next slide, please. Because there are no cancer bioassays for HHCB, EPA used the Rethinking Chronic Toxicity and Carcinogenicity Assessment for Agrochemicals project, which is also called the Recap Weight of Evidence Framework, as an organizational tool to evaluate whether the absence of cancer bioassays imparts uncertainty on the risk assessment for HHCB. Using this framework, EPA preliminarily concludes that the lack of cancer bioassays for HHCB is not a significant source of remaining scientific uncertainty in the risk characterization, and that the non-cancer POD based on decreased offspring body weight is health protective, including for potential cancer effects. Next slide, please. To support this conclusion, EPA evaluated the following evidence streams for HHCB, which are listed in this first box on the left. These include physical and chemical properties, toxicokinetics, acute toxicity, subchronic toxicity, genotoxicity, evidence of hormone perturbation, evidence of immune system perturbation, mechanistic studies to support cancer mode of action, chronic toxicity, and evidence from read across to related chemicals. Upon evaluating these sources of evidence, EPA made the following supportive conclusions, which are listed in the middle box. These are: HHCB has low potential for bioaccumulation in human tissues based on toxicokinetic studies in rats. HHCB is not acutely toxic based on the available acute, oral, dermal, and inhalation toxicity studies in rats. HHCB causes no adverse organ weight changes and no pre-neoplastic lesions after repeated subchronic exposure. And this is based on an OECD 408 90-day oral toxicity study and a 26-week subacute dermal toxicity study. HHCB is not genotoxic or mutagenic based on a micronucleus test in mice and multiple in vitro assays. HHCB is not an endocrine disruptor in rodents based on an OECD 408 90-day oral toxicity study, an OECD 443 extended one-generation reproductive toxicity study, and a mouse uterotrophic assay. HHCB is not toxic to the immune system based on the aforementioned 90-day oral toxicity and extended 1-generation studies. And in addition to reviewing available studies and previous assessments, EPA used the Generalized Read Across, or GENRA, online tool to identify potential analogs for read across. EPA did not identify any suitable HHCB analogs with available cancer data for read across. And as a reminder, these conclusions and studies are discussed in detail in section 2.5 of the draft Human Health and Environmental Hazard Assessment for HHCB. Finally, the last box on the right shows the overall weight of evidence conclusion that EPA made using the recap framework. This is, once again, that the lack of cancer bioassays is not a significant source of remaining scientific uncertainty in the risk characterization, and that the non-cancer POD is health protective, including for potential cancer risks. Next slide, please. Thank you all for your attention, and I'm happy to take any clarifying questions.
Thank you for that detailed presentation. It's very nice information. I see Dr. Ottinger has a question.
Thank you very much for that very detailed presentation. I really appreciate it. I have several questions. One, and I'm not sure if this is only for the section that you've and this is Marianne Ottinger, sorry. I'm not sure if this is only pertinent for the section that you presented, or if others might be able to also help answer some of these questions. My question really is about some of the conclusions of the lack of some more physiological responses. The extended 1-gen or the 90-day test, neither of them really examine whether or not the F1 and then subsequently the F2s show usual reproductive performance. In other words, in the extended 1-gen, usually it's going to focus on the mortality and the development of these pups and perhaps, coming into sexual maturation. It's not going to look at long-term reproductive lifespan, at least going through the studies that have been referred to. There really isn't much said about the number of pups that reproduce, for example, or metabolic endocrine measures, even immune measures. So some of the conclusions that are in the diagram or the figure that you just showed in the last couple of slides, where it's not an endocrine disruptor, is not convincing to me. And so I guess I have two questions out of that. One is whether there are any explanations beyond disruption of metabolic systems for the long-term body weight depression in the offspring. And secondly, because that suggests to me a metabolic effect. And then secondly, are there any kinds of environmental tox effects, ecotox effects? Because in one of the other, under one of the other charge questions, there's the question about environmental effects. And really, there are very few studies on anything outside of a couple of vertebrates, a lot of plants and inverts, but we know nothing about studies on birds and other species that would be potentially affected. So sorry, I'm kind of hitting you with a bunch of different questions and really appreciated the presentations.
Thank you, Dr. Ottinger. This is Anna Lowe at OPPT, Senior Science Advisor. I guess there were a lot of questions there. It was unclear to us where the notification question is. To our knowledge, the HHCB database largely follows many of the OECD guidelines, including the extended 1-gen, and it actually has some fairly unusual and robust data for a typical industrial chemical, including some of the human studies and the extended 1-gen, and in fact, some of the endocrine studies. And so it's unclear to us what the clarification question is, as opposed to maybe things that you might want to write in the report.
Yeah, I realized that as soon as you got on, it's like, sorry about being, conflugaling a bunch of things together. If there's one question, I guess it would be, are there other measures that are endocrine revealing in terms of effects on the F1s and in some of the OECD types of trials that would explain the loss of body weight and if their metabolic endocrine systems impaired by the exposure?
So all of the endocrine studies that we're aware of, we found in the systematic review and are described in TSD, and there's an entire section on that, and that is actually a fairly unusual data set for an industrial chemical, which makes it one of the more robust parts of the data set. So if if the panel's aware of more studies that we missed, we'd like to find out about those. And I would also remind you with the extended 1-gen, the development of that protocol was done, I don't know, maybe a decade or more ago, largely based on an analysis of hundreds of pesticide 2-generation studies. Where a lot of that work was actually done by EPA to do a retrospective analysis. And it's actually relatively rare for the 2nd generation to show effects that are not picked up in the 1st generation, which is why the OECD has largely put that protocol together, and many countries have picked it up, and many people largely do the 1-gen and the 2-gen now.
No, I've been involved in the development of all those, so I'm quite familiar with it. I'm just concerned about that loss of body weight and what that could be, what could be going on. And it may be beyond the purview of this particular set of charge questions and something, that would be looked at in the future, perhaps.
So we are using it for our point of departure, so it is the most sensitive endpoint. So we would be protecting for a full complement of uncertainty factors. So, but again, I'm not sure this is a clarification question, and maybe something for your report.
Yeah, very fair. Yeah, I appreciate it. Thank you.
All right, thank you for that question and for the response, Dr. Lowett. Dr. Gadia.
I also have some clarifying questions. In terms of the body weight, was there recovery in the body weight after postnatal day 14 or 21? I remember reading somewhere that postnatal day 1 body weight and 21 were relatively similar. Could you comment on that, please?
Yes, this is Lily Barnett, EPA. The body weight changes did persist over time. They occasionally stabilized and perhaps were not significant in certain groups, but in general, there was a general trend where they persisted into adulthood in both sexes, and then in both generations as well, when you consider through postnatal day 21. In addition to that, I want to highlight that there is a data evaluation record for this study that we have included as a supplemental file, and you can see the body weight changes in that data evaluation record. So if you would like more information on those trends or to kind of see the particulars of what's going on, I just want to refer you to that document. I think I also summarize the trends that are happening throughout the lifespan of these animals in section 2.3.3 of the hazard TSD, the technical support document, excuse me. So I hope that helps clarify your question.
Okay, thank you. And to follow up on that, since the effect was in that sensitive period, and it's the most sensitive effect, which is the developmental stage, could you comment on the use of the uncertainty factor of 10 for intraspecies? And if that is an overly conservative use or not, or why would you recommend using a factor of 10?
Hi, yeah, thanks. Anna Lowett, EPA OPPT Science Advisor. Thank you for that question. It is standard practice to use the full interspecies factor for the full complement of the population when we use data like pup weight or other developmental endpoints. That's pretty standard practice. But you know, if the panel has comments on that, we'd look forward to that in your report.
Okay, thank you. And two more questions, sorry. On slide 223, where you talked about occupational exposures, I believe you mentioned it was considered as 24-hour exposure for 365 days. Is that correct? Or the assumption was 24 hours for 365 days?
This is Dr. Whitney Hollenshed, and yes, we did 2 scenarios for occupational. We did one where we did an 8-hour, and then we did this one, which we considered a worst case, and that was for 24 hours and 365 days.
So just to elaborate on that, could you talk about a possible scenario where somebody's going to be exposed to this material for 24 hours a day, 365 days in an occupational setting?
Mm-hmm. So the contact, right, is not continuous. What we're saying is the absorption could be continuous, or more so we have limitations with the time absorbed, the duration of absorption, because the HHCB is present in the skin at the end of the dermal absorption study. So that's why we did a kind of worst case, because we know it's somewhere in between the 8 hours that they have contact with the liquid, but maybe it's not the 24 hours, but that's the limitations that we have with the flux-based approach.
Okay, I would argue that in the 26-week dermal study, there was no real effect as such. So if HHCB was absorbed even after the material is removed, you would see some effects, and essentially you don't see anything. So that's something that I would recommend considering. Thank you.
Is that an error? I see an EPA hand raised.
Hello, this is, sorry about the delay in the video. This is Mi Young-Yoon from EPA. Just additional clarification about the extended dermal absorption. And the context is that since in vitro study shows the remaining content on the skin, we wanted to run the worst case scenario, not that the workers are exposed for 24 hours, but the possibility of the amount remained on the skin may be contributing to the additional absorption to the systemic side. And our worst case scenario and the bounding exercise shows that even if we are assuming that worst case scenario, the systemic absorption is not significant and not meaningfully adding to the systemic body burden. That was the context of that exercise. Just wanted to clarify. Thank you.
Thank you.
Okay, anything else from the committee? I actually have a question or two. This is George Cobb. And I think I got the answer to this, but just to make sure, in the rodent studies, were were the pups exposed after weaning throughout the generations, or was it just through maternal exposure?
The pups were exposed continuously, so gestation through weaning, lactation, weaning, all the way and continued into adulthood as well. And then those animals were then, they produced the F2 generation,
Right.
so they were also exposed. And then that F2 generation was also exposed gestationally and then lactationally as well. So hopefully that helps clarify.
That it does. And I didn't have a chance to read that document, and I thought that's what you said in your presentation, but I wanted to double check. And then for the inhalation point of departure or threshold that you were using to determine whether there was, enough exposure to warrant concern, what was that value? What was the either threshold or point of departure there?
This is Lily Barnett, EPA. Apologies if I'm misinterpreting the question, but we performed route-to-route extrapolation using the oral point of departure. So our inhalation hazard value is based on the reduced offspring body weight, which was 10 point for oral.
So do you have an inhalation hazard value though?
Yes, we do. Yes, we.
And what is that?
That is, I can refer you to the section in the document where that is located. Apologies, I don't know it off the top of my head. But it is detailed in section 2.4 of the Human Health and Environmental Hazard TSD.
Okay, I'm writing that down. That's why I'm pausing. Okay, we'll have to circle back to that because it's important what that number is, because there's recent publications out of 2025 with measured atmospheric concentrations indoors, and that may specifically inform how this hazard is done. That'll certainly be part of the written response, but I want to see where those values are relative to your hazard values. Okay. The other thing is, I think please go back and check. I believe your acute inhalation concentration values that you had showed to us something like 5 milligrams per liter. That is unrealistically high. I think that's just a unit value, maybe 5 milligrams per cubic meter. Even so, you wouldn't be able to see across that chamber. So please double check that in your slide deck, because I can't believe that 5 milligrams per liter is the appropriate concentration.
Thank you. Yes, we appreciate you highlighting that for us, and we will double check. Thank you.
Okay. All right. Well, with that, I think we've finished our presentations, or EPA's finished their presentations for us. And so before we go to the public comments, are there any clarifying questions from the committee about anything we've heard from the agency so far? All right, seeing none, I think we'll go to the public commenters. Oh, Dan Slink just raised his hand.
Sorry. Yeah, it's too many buttons. I've been in contact with the law for trying to find the locations of those sites in figure 4.5 and 4.6 without much luck. The document 31 has the location tab empty. There's no, although the coordinates are listed, there's no, it's very, very difficult to find where those are. So again, just if the agency could provide site locations for the figure 4.5 and 4.6 and where those sites are, specifically river locations rather than geographic coordinates, which again makes it really, really difficult to find out where they are. That would be very, very helpful. Thank you.
Yes, we do need an answer to Dr. Slink's question, because having coordinates in a table buried in an appendix is not realistic for this kind of evaluation. Dr.
Yeah.
Lowett.
Yeah, Anna Lowett, OPT Science Advisor. So I apologize for the disconnect. I apologize you're having trouble finding what you're looking for. I'm starting to wonder if we're not understanding your question. So we're going to talk to Dr. Kamela offline and see if he understands your question and what you're looking for, so we can be responsive to your question.
Yeah, it's a pretty simple question, Anna. I just want to know where the sites are in that figure and whether or not they're in a wastewater dominated stream. It's pretty simple. If they're in the Trinity River, which is again where the biological fish sample, which has the highest level is, then that would significantly change the scenario in terms of uptake when we get to question 16 and 17. If it's, again, and if the second highest level is in California, which I think it is, but I just would love to confirm that, is in the Santa Ana River, which is a wastewater dominated stream, that's what I'm looking for. He said low flow conditions, which I assume both of those systems are low flow conditions. He just didn't decide, he didn't tell me that they're wastewater dominated. And that's, I think, a really important issue for the environmental side of this. So that's what I'm looking for.
Thanks
Yeah,
for
and
that.
I'd add, not just are they effluent dominated, which streams are they? I mean, the names
Well,
of the rivers.
Yeah, I mean, can it match the biological collection, which was made by Brian Brooks' lab in the Trinity River? That I think that's very significant because it's a very unique case where you have water from a system and biology from that same system. So that's what I'm after.
We'll keep trying.
Thank you.
Dr. Ottinger.
Yes, this is Marianne Ottinger. So Doctors Lowett and Barnett, I just wanted to circle back and thank you for the information provided. I think the clarifying point from my earlier comments was really based on other information throughout the report showing that, in this part of the report showing that there's weak endocrine disruption associated with this compound, mostly in vitro tests. So the clarifying question I have for you is then your conclusion is based solely on the in vivo studies for the conclusion that there's not a risk of endocrine disruption. And again, sorry if I was confusing before, and I really appreciate all that you are putting together for us.
This is Lily Barnett, EPA. Thank you so much, Dr. Ottinger. Our conclusion is actually based on, I believe, both in vitro and in vivo studies.
Okay.
We integrated across those studies, specifically for endocrine effects, within section 2.3.3.
Right. Yeah.
TSD. And so I just wanted to highlight that. There's also an appendix C
Right.
at the end. Okay, so you're aware.
Right.
In that
I am.
discussion of
Yeah.
thyroid as well. I just wanted to highlight that for you.
Right.
That consists of all of our evidence integration across all of the information that we have available.
So basically, the issue is that there are some weak endocrine disruption effects, but they don't reach a threshold in which it would be appropriate to take further action, is the clarifying comment I guess I would ask.
Lily Barnett, EPA. Excuse me, Lily Barnett, EPA. Yes, that is correct.
Okay, thank you very much.
Excellent. I think that concludes our questions. Thank you again to EPA for the wonderful presentations and all of the discussion. And now I'm going to, for purely logistics, and because Dr. Kamal is very adept at introducing our speakers, I'm going to turn the floor over to Dr. Kamal, our designated federal official, because he has the updated list of presenters, which is changed a bit because we had to postpone the public comments from late yesterday till early today. So I'm going to turn it over now to Dr. Kamal.
All right, thank you, Dr. Cobb, and hello again. So our first public commenter, the oral comment will be presented from Jennifer Sass from the Natural Resources Defense Council in Washington, D.C.
Hi, and thank you. I'm a senior scientist with NRDC, the Natural Resources Defense Council. I am also a molecular and developmental biologist. I'm speaking today about EPA's use of new approach methods, or NAMs, in these assessments and what that means for the scientific integrity and public health protectiveness of EPA's conclusions. I also have submitted detailed comments with Earth Justice. I think they're called NGO comments. I hope you have them. They're about 20-something pages and fully referenced. So I have scientific and document references for all of these comments. I'm giving you the short version now. Our core concern is straightforward. EPA is using a short 5-day transcriptomic study and related ETAP analysis in ways that go beyond what those methods were designed to do, and then use those results to discount stronger and more relevant lines of evidence. EPA has a 2024 ETAP standard methods guidance that directs that these tools are intended for chemicals that lack suitable repeat dose studies or human evidence. In other words, they're meant to be used with chemicals that don't have a database, don't have studies. But here, and especially for the DCBs, EPA acknowledges that there is substantial toxicology and epidemiology and sums it up. So the concern is that EPA is not using NAMs to complement the evidence base, they're using it instead of the evidence base. That matters because the 5-day transcriptomic assay is not a reliable basis for dismissing evidence of hazards that emerge from much longer timeframes or through more complex biology. EPA is using the short-term assay to support conclusions about carcinogenicity, endocrine-related effects, reproductive toxicity, developmental concerns, and sex-specific susceptibility. These are precisely the endpoints that in EPA's 2024 ETAP standard methods guidance says that this test will not adequately capture or be able to recognize. This is compounded, this problem, by the fact that the transcriptomic study for the dichlorobenzenes was conducted in female-only rodents. I'm not sure why. And the ETAP standard methods describe the test as both sexes. The broader literature indicates that male animals may actually be more sensitive for certain outcomes, including kidney and reproductive effects. Notably, last year when California EPA updated its non-cancer chronic reference exposure level for p-DCB, it did base the new, more protective value on male reproductive effects in a 2-year male inhalation mouse study. There's also some evidence from male infants, human, having decreased birth weight in some epidemiology, and also some epidemiology and other rodent studies. Again, it's detailed in my longer comments. We're also concerned about the cancer analysis. It's too narrow and too confident. p-DCB as a proposed CAR-mediated mode of action that EPA uses to discount rodent liver tumor findings and suggests that they're not relevant to humans. But incomplete mechanistic evidence shouldn't be treated as proof of safety. That's the first point. And secondly, a proposed proposed mode of action is not the same thing as the exclusive or only mode of action, and it shouldn't be used to dismiss other evidences of concern from chronic animal studies, epidemiology, and especially there's a number of inflammation findings and endocrine-related events, including some rare tumor patterns such as childhood brain cancer in epidemiologic studies. More broadly, if EPA had used the key characteristics of carcinogens framework, it would have considered tumor promoting potential as well as inflammation. And it's concerning that EPA aggregated the inflammation effects from the ETAP 5-day test with apoptosis, cytotoxicity, oxidative stress, and making it impossible to figure out whether this is a mode of action for these outcomes. Another uncertainty is the database deficiency uncertainty factor. EPA has reduced the uncertainty factors beyond what was recommended in the ETAP standard methods and by the Board of Scientific Counselors, the NIEHS BOSC, that reviewed the test. Both recommended full uncertainty factors. Our recommendations to the SACC is to advise EPA to use the full body of evidence and to use the full uncertainty factors. Thank you.
Thank you very much. And the next presenter would be Lindsay Holden from BNC Consortium in Washington, D.C.
Good afternoon, and thank you for the opportunity to provide public comment to the SACC today. My name is Lindsay Holden. I'm a diplomat of the American Board of Toxicology with over 17 years of testing, research, and toxicological experience, and I am a senior toxicologist with Bergeson and Campbell. I'm here on behalf of Willert Home Products to highlight and supplement the public comments related to the p-DCB draft technical support documents submitted to the docket for SACC consideration. Willert is an importer and processor of p-DCB and wishes to continue to safely use p-DCB and ensure that any risk management rules are supported by the best available science and weight of scientific evidence. There are 4 aspects that I will highlight related to the draft technical support documents for p-DCB. First, Willert supports EPA's decision to use the 2018 draft registration review human health risk assessment for p-DCB authored by OPP to inform the hazard points of departure. There is no reason for OPPT to repeat the excellent work done by its sister office, especially considering the astronomical workload faced by the existing chemicals team. It is reasonable and appropriate to use the toxicology summary reports that have already been developed by OCSPP as a foundation for assessing toxicological hazards of existing chemicals, and the OPP assessment represents the best available science covering recent and relevant toxicity studies. Second, OPPT appears to agree with the majority of the critical studies for human health hazard assessment as identified by OPP and applied further a refined point of departure determination by applying BMD modeling to the critical endpoints, which is best practice. Willert applauds EPA's transparency by providing direct links to the BMD model information and encourages the SACC to review that information during its review. Willert supports this refined approach for points of departure for non-cancer hazard assessment. Third, EPA correctly confirmed that p-DCB is not likely to cause cancer in humans in agreement with prior assessments. Willert applauds EPA's application of a weight of evidence approach using mode of action analysis and application of the IPCS human relevance framework. As a toxicologist, I am encouraged to see EPA apply this approach in a methodologically sound and transparent manner with clear articulation of each of the considerations at each step. Fourth, one point of contention with the OPPT assessment is that OPPT did not maintain OPP's acute oral hazard endpoint. The study that OPP relied on was Bernadowitz et al. 1994, which is originally in German. We urge that the SACC be provided with both the original German and the English translation of the Bernadowitz study for close review to evaluate whether OPPT is justified from diverging from the OPPT is justified from diverging from the OPP 2018 assessment. Our initial review of the Bernadowitz study found that pup outcomes were analyzed at the level of individual animal rather than litter, which is a critical consideration for developmental toxicity studies. Because pups within a litter are not independent observations, the unit of analysis can substantially influence data interpretation. So if 100 pups are distributed across 12 litters, and postnatal mortality is observed in 15 pups. There are very different implications based on how those effects are counted. If all 15 affected pups come from a single litter, this suggests a localized litter-specific effect. In contrast, observing affected pups across multiple litters would indicate a broader, more consistent response. Analyzing outcomes on a per-litter basis ensures that these distinctions are appropriately captured and interpreted. The English translation of Bernadowitz's study did not appear to contain adequate data for reanalysis using an appropriate statistical approach to determine if this study is appropriate for point of departure determination for acute oral hazard. The SACC may also wish to request input from OPP, such as supporting documentation for critical study selection in the 2018 assessment, to understand better why OPP did not consider Bernadowitz. To conclude, Willert and Bergeson and Campbell recognize the substantial demands placed on EPA's existing chemicals program and applaud OPPT's reliance on recent scientific review by its sister office. We also appreciate EPA's release of the draft TSDs, which provide an important opportunity for scientific review and stakeholder input on the hazards of p-DCB. We encourage SACC to consider advising EPA based on the nature and extent of revisions made in response to SACC feedback on whether additional peer review of the hazard assessment is warranted for the draft risk evaluation. And if significant changes are made to the human health or environmental hazard assessments, a subsequent round of SACC review would ensure that draft risk evaluation reflects a high standard of scientific rigor. We appreciate the SACC's careful consideration of these comments, and we thank EPA for the opportunity to contribute to this important process.
Thank you very much. And I'm sorry, I did not ask the SACC if they had any questions for the first presentation and also for this comment. So if there are any questions, please raise your hand. Okay, I don't see any questions. So then we will move to the next oral comment by Gina Hilton from People of the Ethical Treatment of Animals in Norfolk, Virginia.
Good morning. Thank you. Can you hear me okay?
Yes.
Great. Good morning. My name is Gina Hilton, and I am a senior toxicologist working for PETA. And today my comment is going to be mainly addressing charge question 4, which requests feedback on the EPA's use of the RECAP framework. And RECAP is also known as Rethinking Chronic Toxicity and Carcinogenicity Assessment for Agrochemicals Project. So the EPA used the RECAP framework to structure weight of evidence evaluations for o-DCB and also HHCB. I just wanted to quickly note that the RECAP framework, it was originally published, it's open access. This was published in 2022, and it states that the framework can be applied to chemicals other than agrochemicals. So just to make a statement that it was intentionally created to have broader applicability beyond the agrochemical space. Okay, so as you know, earlier this year, the EPA published cancer risk evaluations for 2 phthalate chemicals using the RECAP framework. And this really demonstrated a landmark action in fulfilling data needs for carcinogenicity assessment without the rodent cancer bioassays. And using the RECAP framework provides scientifically sound weight of evidence approach to protect human health by considering existing information related to exposure, metabolism, mode of action, and toxicity data. So this framework was established, it has established itself as a valuable component in the field of risk assessment. And this was evidenced by the OECD publishing 2 case studies so far. They were published in 2024, demonstrating the applicability of the weight of evidence RECAP framework. And so we saw EPA's use of this framework with 2 other chemical evaluations, and the agency has once again leveraged the RECAP framework to support cancer risk assessment for o-DCB and also HHCB. In using this framework, the agency has minimized uncertainty in qualitative and quantitative risk characterizations based on the availability of toxicological and mechanistic information for the substances under evaluation. The information used in the agency's assessment substantiates the weight of evidence evaluation that new chronic toxicity and carcinogenicity studies would not further reduce uncertainty in the qualitative and quantitative risk characterization for o-DCB and HHCB. Yeah, I just want to wrap up saying that the agency's use of the RECAP framework for these 2 chemicals spares another estimated 1,600 animals. And while providing a scientifically sound approach to protect human health. So I hope to see more use of the RECAP weight of evidence framework and where applicable, certainly in future TSCA evaluations to support regulatory decision-making. And I also wanted to say thank you to the Scientific Advisory Committee on Chemicals for this opportunity to provide oral comments to this peer review panel. Thank you.
Thank you very much. Does anyone have any question for Gina Holton? Okay, I don't see any questions, so we will move to the next oral comment by Adam Bettman from PETA Science Consortium International in Cottage Grove, Minnesota.
Thanks, Dr. Bell. Can everyone hear me okay?
Yes.
Okay. Yeah, my name is Adam Bettman. I am also a toxicologist with PETA. And I will be commenting on the broader use of new approach methodologies throughout these evaluations. EPA's integration of new approach methodologies, or NAMs, across these evaluations represents an important and scientifically appropriate advancement in TSCA risk evaluation. These approaches support more mechanistically informed decision-making and align with TSCA Section 4H, which directs the EPA to reduce and replace vertebrate animal testing wherever possible. First, on transcriptomics and the derivation of transcriptomic points of departure for o-DCB and p-DCB, it's important to note that the 5-day transcriptomic studies used here are in vitro vertebrate animal studies. So moving forward, it would be helpful for the EPA to take near-term steps to transition to in vitro approaches. And when in vivo is used to describe what information needs could not be met with the in vitro approaches. This level of transparency will help to guide the development of fit-for-purpose in vitro models that can be used with transcriptomics. Similarly, for the selection of transcriptomic points of departure for o-DCB, human relevance can be strengthened by moving away from reliance on animal endpoints as anchors and toward NAM-derived points of departure that do not depend on animal data. The current evaluation can be used to support the development of in vitro transcriptomic points of departure. For p-DCB, EPA's evaluation of the constitutive androstenedione receptor mode of action is a strong example of how transcriptomic data can be integrated within an AOP-informed framework. This is a scientifically robust and internationally aligned approach. The use of key event analysis and species comparisons helps to move beyond default assumptions based solely on animal data. And at the same time, these transcriptomic data are in vivo. While EPA has described these as near-term bridging tools, continued progress, again, towards human-relevant in vitro and in silico approaches will be important for supporting mode of action analysis going forward. Turning now to phthalic anhydride and skin sensitization. EPA's use of the skin sensitization AOP alongside in chemico and in vitro data and application of the SARA ICE model is very commendable. This approach demonstrates that quantitative risk characterization can be achieved using these existing new approach methods. For respiratory sensitization of phthalic anhydride, EPA's use of the AOP framework is appropriate and consistent with international best practices. And in addition, the selection of a point of departure based on human occupational data is a notable strength. Grounding the assessment in human relevant evidence while using NAMs to provide mechanistic support reflects a transparent and scientifically sound approach. Lastly, turning to HHCB, EPA's conclusion that a dermal hazard point of departure is not warranted is well supported by human data, in vitro skin models, and toxicokinetic considerations. The use of flux-based exposure modeling also provides helpful content following a hazard-based determination that systemic dermal toxicity is not biologically plausible. In closing, these evaluations demonstrate meaningful progress in integrating NAMs into TSCA risk assessment. We hope to see continued movement towards in vitro transcriptomics and continued use of NAMs data in regulatory decision-making. I'd like to thank you for your consideration and the opportunity to present these comments to the Secretary.
Thank you very much. Are there any questions for Adam Bittman? Okay, then we move to the next public comment, and it will be by Jessica Ryman from American Chemistry Council in Washington, D.C.
Hey, thank you. Good afternoon. My name is Jessica Ryman. I'm a Senior Director of Chemical Management at the American Chemistry Council, as was just mentioned. ACC is a trade association. Our members are the leading companies engaged in all aspects of the business of chemistry, from the largest corporations to the smallest, and everything in between.
If available, that you can turn on your camera. If not, no problem.
Yes, I'm in the process of doing that. I don't think it's working, unfortunately.
No problem.
There we go. There we go. Okay, great. Here we go. All right, so EPA has implemented a number of new approach methodologies, or NAMs, in its draft human health hazard assessments and human health risk evaluations. These are the ETAP, the RECAP, and SARA-ICE. We will comment today on the ETAP and RECAP and on a study we believed EPA missed in systematic review related to skin sensitization, for which EPA is using the NAM SARA-ICE. Our comments today on these NAMs and this study summarize more detailed comments that will be submitted to the docket. I will begin with ETAP. For the first time, of which ACC is aware, the ETAP 5-day transcriptomic assay is being used to support regulatory endpoints under TSCA. The ETAP does not establish a causal relationship between a transcriptomic product and an adverse effect. EPA is not currently using the ETAP as a standalone to support a regulatory endpoint. Instead, the ETAP is being used in conjunction with apical endpoints that EPA considers adverse, which is appropriate since the transcriptional changes may or may not result in an adverse effect, and TSCA authorizes regulation of unreasonable risk of injury to health or the environment. I will next move on to the RECAP. In general, ACC applauds EPA's use of the RECAP to support not likely to be carcinogenic cancer classification under EPA's 2005 guidelines for carcinogen risk assessment when chronic toxicity and carcinogenicity studies are not available. ACC notes that the RECAP can be considered a NAM and that the use of NAMs is consistent with both provisions in the TSCA statute and a recent agency memorandum entitled Recommitment to Reducing Animal Testing and Eliminating Mammalian Testing by 2035. The last issue I will discuss today is skin sensitization. EPA's systematic review process has a tendency to miss important studies, and the assessment for phthalic anhydride is no exception. A study by Basketer and Kimber, published in 2016, entitled Phthalic Anhydride, Illustrating a Conundrum in Chemical Allergy, concluded that there is a, quote, lack of persuasive evidence that phthalic anhydride causes skin sensitization, or ACD, end quote, and that contact urticaria has been reported only rarely in association with phthalic anhydride exposure. This is consistent with the MOA that for dermal sensitization, phthalic anhydride, a highly reactive, aqueously labeled chemical, would need to traverse the stratum corneum and multiple layers of keratinocytes to reach Langerhans cells in the stratum spinosum for antigen processing and presentation. ACC appreciates the agency's efforts to advance the use of NAMs and encourages the agency to consider all of the available evidence when evaluating the results. That concludes my comment.
Thank you very much. Are there any questions? Okay, I don't see any questions. Then we will move to the next public comment by Mark Caffarella from 3 Points Ecotox Consulting in Marion, Massachusetts.
Thank you for the opportunity to speak today. My name is Mark Caffarella, and I'm a principal scientist with 3 Points Ecotox Consulting. I'm speaking to you today on behalf of the American Chemistry Council's para-dichlorobenzene TSCA Consortium. I understand there are no charge questions on the environmental hazards for the SACC to consider, and I'm concerned that the environmental hazard assessment will not be externally peer-reviewed. Therefore, I'm providing brief comments today to raise awareness regarding potential deficiencies in the quality of the ecological hazard data and selection of these studies for points of departure. The environmental hazard assessment appears to be comprehensive and thorough, although some discrepancies have been identified. While additional environmental fate information may be forthcoming in the risk evaluation, EPA has been inconsistent with its presentation of the draft hazard assessment. For example, environmental fate was taken into consideration when describing hazard for terrestrial environments, but it was not considered when discussing hazard in aquatic environments. In a typical full EPA TSCA evaluation, there is a comprehensive environmental fate section that precedes the discussion of environmental hazard. According to EPA, the evaluation of strength of the evidence of hazard effects occurs only for relevant environmental systems and exposure pathways and media. This is a critical deficiency for hazard assessment because the data utilized to assess hazards were extremely limited and did not consider the physical chemical properties of para-dichlorobenzene in aquatic systems. Due to those physical chemical properties, the potential for chronic exposure to para-dichlorobenzene in aquatic systems is very low. Additionally, the relevance for the selected points of departure and subsequent concentration of concern for chronic aquatic taxa, both invertebrates and vertebrates, are anchored solely by singular studies. For invertebrates, the study EPA rated medium quality was selected to define the point of departure over studies rated high quality. The vertebrate study that was used was rated high quality yet had significant scientific and design deficiencies from the current test guidelines. Therefore, each EPA should provide additional discussion regarding the rationale for specific study selection. And further, there is concern about how uncertainty was considered in reaching overall hazard conclusions, and it's important to consider how these uncertainties can be effectively managed given the paucity of the data used to define hazard. Thank you for the opportunity to provide these comments.
Thank you for your comment. And are there any questions? Okay. Then we move to the next public commenter, and that would be Heather Lynch from Integral Consulting in Boston, Massachusetts.
Thank you for the opportunity to speak today. I'll be commenting on the draft hazard assessment for para-dichlorobenzene, or p-DCB. My comments today are focused on the charge questions to the SACC. In charge questions 5 and 6, EPA requested feedback on the transcriptomic analyses and the overall mode of action, or MOA, analysis for cancer. First, the use of transcriptomic data in this assessment represents a crucial step forward in EPA's efforts to reduce reliance on animal testing. EPA's transcriptomic analysis is well described and the gene set is appropriate. Using the well-regarded ICPS MOA human relevance framework, EPA thoroughly evaluates and convincingly supports the proposed MOA that CAR activation drives the observed liver tumors in mice and that this MOA is not relevant to humans. The transcriptomic data also provides support for excluding alternative MOAs involving other nuclear receptor pathways. Overall, EPA's MOA assessment and weight of evidence assessments both support its classification that p-DCB is not likely to be carcinogenic to humans. Charge question 7 asks the SACC members to consider the strengths and limitations of the approach to deriving the acute oral and dermal POD using the 2-generation study by Bornatowicz et al. 1994. EPA's benchmark dose modeling utilized the Rao-Scott transformation to adjust for intralitter correlation in the postnatal mortality because it was reported on a per pup basis. Data on a per litter basis are preferred because in a standard binomial model, each observation is treated as independent. However, pups in the same litter are not independent because they share fetal and postnatal environments. The Rao-Scott transformation is most effective when some litter level information is available. However, when historical data must be used to estimate correlations, the transformation may yield benchmark dose levels or BMDLs that are plus or minus 50% of the BMDL that's based on litter-specific data. Assuming EPA has been unable to retrieve the litter level data from the study authors, there are other options. At a minimum, EPA should evaluate the 6 other methods recommended by Fox et al. 2017 to approximate intralitter correlation and examine the range of BMDLs that result. Other options that we recommend include using the Chemical Manufacturers Association or CMA 1989 study, for which litter data were available, or other endpoints from the same Bornatowicz et al. Study, such as delayed eye opening, which does not require the Rao-Scott transformation. EPA can also consider using the acute inhalation neurotoxicity study by Monsanto 1994, which was selected by OPP for its acute oral POD in the 2018 assessment. Both the CMA and Monsanto studies have less uncertainty than the Rao-Scott transform data. In Bornatowicz et al. Study, offspring were exposed through gestation and lactation. It's unknown what dosing period or MOA drove the observed mortality. Thus, if that study is retained for this endpoint, the F1 POD is more appropriate for use in the risk evaluation. The F2 generation results are particularly irrelevant for occupational populations because this would infer multi-generational occupational exposure to p-DCB. Question 8A pertains to the proposed intermediate inhalation POD screening range of 10.4 to 46.8 ppm. First, presenting a range without clear guidance on which value in the range is most appropriate in a given scenario introduces practical uncertainty for risk assessors. Perhaps more importantly, the 3 underlying inhalation studies each have notable limitations that collectively undermine confidence in the proposed range and call into question whether EPA is following its charge to use the best available science and leverage the TSCA data quality evaluation system. The high end of the range is the lowest BMCL modeled from the Inhalation Developmental Toxicity Study, CMA 1989. This is the study EPA chose not to use for the acute exposures due to unclear adversity and concerns over reliability of measured air concentrations. The middle value is based on maternal body weight changes that were not considered adverse. The lower bound of the range is based on a dose range finding study in dogs with only 2 animals per sex. It's unclear why EPA did not consider the higher quality 13-week inhalation study by ASO et al. 2005. EPA should consider selecting this study as the basis for the intermediate inhalation POD. The new charge question 8B asks the SACC about the chronic inhalation POD. EPA used a regional gas dose ratio of 0.22 to extrapolate from animals to humans. However, the effects in the study occurred in the extrathoracic region, and the 2012 EPA guidance on inhalation dosimetry recommends using an RGDR of 1 for effects in this region. Therefore, this RGDR should be updated. Finally, in charge question 9, EPA requested feedback on its proposed dermal, intermediate, and chronic PODs based on the Monsanto 1996 oral dog study relative to an alternative approach using the 21-day dermal toxicity study in rats. First, the weight of evidence indicates that p-DCB dermal absorption is negligible under real-world conditions due to its high volatility. Regarding the POD, there's more uncertainty associated with the use of the dog oral study relative to the rat study. Dogs were treated with a large bolus dose that was absorbed quickly into the gastrointestinal tract and distributed directly to the liver. In contrast, skin exposure will result in slower absorption through the skin and a lower maximum concentration in the liver. EPA should consider using the rat dermal applied dose in milligrams per centimeter squared and compare it to estimated dermal loading doses, also in milligrams per centimeter squared, for risk characterization. Note that using the rat may even still be overly conservative because no toxicity was observed at the highest dose tested. In summary, the hazard assessment has many strengths, but we recommend that EPA revisit study quality and relevance criteria and consider alternative studies for certain proposed points of departure. Thank you for your time.
Thank you for your comment. Are there any questions? I see a hand. Dr. Cobb?
This is more a comment than a question related to the multi-generational effects and worker exposure. There are, although the population would be small, likely, there are populations where generations of people work in the same industry. I grew up in an area where everybody for 3 or 4 generations worked in the same industries there in town. So again, the populations are probably very small, but those types of scenarios do exist. So I would take a little issue with that comment. But I acknowledge that the population is likely to be small.
Fair. Thanks, Dr. Cobb.
Thank you, and it's good to see you again.
Likewise.
Any other questions? Okay, thank you very much. And we will move to the next.
Dr.
Sorry.
Kamal,
Sorry.
am I able to speak on behalf of my colleague who couldn't make it? I think he was next in the queue, but I can also go at the end if you would prefer.
So who is your colleague?
Andrew Mayer. He is
Yeah,
at another EPA meeting. Yeah.
Yeah, he is next. Andrew Mayer. You're right.
Yep. So I'm just going to present his comments for him since he is literally on site at EPA today, right at this moment. So.
Okay. So Heather Lynch will be presenting on behalf of Andrew Mayer, and he is from Integral Consulting in Cincinnati, Ohio.
Thank you. Thank you for the opportunity to speak on behalf of Dr. Mayer today. I'm commenting on the occupational inhalation and dermal assessments in the phthalic anhydride risk evaluation. Although the inhalation exposure assessment is not included in the charge questions, the issues raised here are critical to appropriately characterizing potential occupational risks. In its inhalation exposure assessment, one of the data sets on which EPA relies includes personal breathing zone samples from Stepan, a PA manufacturer and processor. This was cited as Cardno Chemist 2020. There is a newer data set from Stepan that was submitted after the draft risk evaluations release. The combined Stepan dataset should be given greater weight than other datasets in the occupational exposure assessment because these datasets are well annotated and more temporally relevant. Using all datasets, EPA developed a separate exposure estimate for, quote, high exposure workers engaging in certain tasks. This category is not needed because task-based exposures are already included in the full shift measurements. EPA also assumed tasks were 2 hours in duration when tasks are typically much shorter. Finally, assuming the exposures during the rest of the shift are equal to the average of the full shift time-weighted average, likely overestimates exposure. EPA's proposed occupational exposure value of 10 micrograms per meter cubed is based on a study by Nielsen et al. 1988 that reported rhinitis and markers of respiratory sensitization in workers. The study is limited by its cross-sectional design and potential confounding by cross-reactivity to other anhydrides, but it's likely the most relevant study available. However, the resulting point of departure of 0.4 mg per meter cubed as a full shift time-weighted average should be viewed as highly precautionary. The authors reported that 0.4 mg per meter cubed was a full shift average for workers that were loading PA, but it's unclear whether this is a long-term average. Regardless, PA loaders were exposed to varying full shift average concentrations with peak exposures ranging from 6 to 17 milligrams per meter cubed for their short-term tasks. Average job tenure of loaders was 13 years. Therefore, the OEV should only be compared to long-term average exposure data. Since the POD arises from an epidemiology study of a highly exposed susceptible population with a predisposition to atopy, or some of which may also have had non-occupational asthma, the population already represents the most likely to respond. An uncertainty factor of 10 for human variability is therefore not warranted. EPA should apply a total UF no greater than 3 for human variability. EPA calculated dermal exposure using its dermal exposure model, which requires estimates of dermal loading. EPA used a published study of dermal loading of powdered calcium carbonate for this purpose. Manufacturers of PA handle it in flake form, which would not transfer as readily to the skin as powder would. Thus, EPA's loading estimates are likely biased high. PA manufacturers also ship PA as a molten liquid, and thus, at least for step-in, is not a possible exposure route for liquids. EPA states that phthalic anhydride is a well-documented dermal sensitizer. However, EPA did not cite a key review conducted by Basker and Kimber in 2016, which concluded that while PA elicits positive responses in the murine local lymph node assay, or LLNA, and in vitro sensitization tests, actual cases of allergic contact dermatitis from PA are rare. This is likely because PA hydrolyzes rapidly in water on the skin to orthophthalic acid, which is not a dermal sensitizer. In fact, several in vitro sensitization assays conducted in aqueous cell culture medium were negative, which EPA erroneously categorized as false negatives. The 45 microgram per centimeter squared sensitization benchmark derived by EPA using the Sarah Ice model suggests PA is a potent dermal sensitizer. EPA ran this model using two different approaches, one that included the data for all key events, and a second approach excluding 2 of the 4 key events, which were the false negative results. EPA selected the second approach, which excludes critical pieces of the adverse outcome pathway. A weight of evidence approach leveraging all key events and data is more appropriate and yields a higher yet still productive protected POD, given the low prevalence of allergic contact dermatitis in the PA literature. In sum, EPA's occupational inhalation and dermal assessments for phthalic anhydride hinge on methods and data that collectively overestimate risk. Correcting these errors would substantially alter the risk characterization and any resulting risk management decisions. Thank you.
Thank you very much. Are there any questions? Okay, the next presenter will be Monita Sharma, and she will be presenting on behalf of Andreas Stuckey from PETA Science Consortium International in Thun, Switzerland.
Thank you so much. Good afternoon, everyone. My name is Monita Sharma. I am an inhalation toxicology specialist with PETA. I thank the Scientific Advisory Committee on Chemicals for the opportunity to provide oral comments to this peer review panel today. My comment is mainly addressing charge question 8B and more broadly on the assessment of inhalation toxicity. So rats have historically been used for inhalation toxicity studies, often chosen for practical reasons. They breed quickly, have a relatively short lifespan, and are small enough to house and easily handle. However, there are substantial differences in the anatomy and physiology between the human and rat respiratory tracts. Those differences may affect toxicological assessments, such that finding in rat should not automatically be assumed to reflect what would happen in humans. One important example can be found within the rat nose, which is a lot smaller than the one of humans. Rats do not see particularly well and therefore heavily rely on their smelling senses. It is therefore no surprise that approximately 50% of the surface area in a rat's nose is lined by olfactory epithelium, meaning cells that are responsible for detecting odors. In contrast, humans rely more on other senses such as sight, and the olfactory region represents only about 3% of the human nasal cavity. The rat nasal cavity is also considerably more complex, with multiple turbinate structures that channel a greater volume of air towards the olfactory epithelium, resulting in higher localized exposure than in humans. In addition, the olfactory epithelium contains a specific cell type, cystentacular cells. They contain high levels of cytochrome P450 enzymes and therefore play a key role in the local metabolism of inhaled compounds. This in situ metabolism may increase the rat's susceptibility to substances that require metabolic activation, such as acetaldehyde, styrene, and naphthalene. For these reasons, findings in the rat olfactory epithelium, as was observed for p-DCB, should be interpreted carefully when considering potential human health relevance. In this case, the agency based the chronic inhalation point of departure on the severity of eosinophilic globules found in the rat olfactory epithelium reported in the ISO et al. Study. But those globules are known to be common age-related background findings in rodents. In fact, all female control animals except one showed them in the study. Although there was a treatment-related increase in severity of those globules in female rats, but not in male rats, the relevance of this endpoint to human health remains unclear. As noted by Harkema and colleagues, eosinophilic globules are common background findings in all rodents. Weber and colleagues concluded that in the absence of other clear signs of irritation or pathological changes, these globules should not be used to define points of departure. Overall, I would encourage the panel to interpret these rat findings with appropriate caution and to carefully consider their relevance, if any, to human health. More broadly, I would welcome further consideration of human-relevant in vitro and in silico approaches to assess inhalation toxicity in the future. Again, I thank the SACC for the opportunity to provide these oral comments again. Thank you.
Thank you for your presentation. Are there any questions? Okay, then we can move to the next public commenter, and that would be Caitlin Kukula, who will be presenting on behalf of Adriana Antezana from Earth Justice in Brooklyn, New York.
Good afternoon, everyone. My name is Caitlin Kukula, and I'm currently a master's student at Duke University working with Earth Justice this summer. I'm here to give comment on behalf of Adriana Antezana, who is a staff scientist at Earth Justice but cannot attend today's meeting, and thank you all for your time to provide this comment. Earth Justice and NRDC submitted joint comments specific to EPA's use of new approach methods, or NAMs, in the current health risk evaluations that we would like the SACC to consider in your review. I specifically want to highlight our comment on EPA's misuse of the Rethinking Chronic Toxicity and Carcinogenicity Assessment for Agrochemicals project known as RECAP. EPA has previously stated that the purpose of RECAP is specifically to determine if a chemical needs a cancer bioassay for pesticide registration. It should not be used to draw broader conclusions that a non-cancer point of departure would be protective for any potential carcinogenicity, which is what EPA is doing in the risk evaluations for HHCB and o-DCB. Additionally, and related to question 4A of the SACC charge, EPA's use of RECAP in o-DCB is substantially different from the use that the SACC reviewed for the DCHP and DIBP risk evaluations. In those evaluations, EPA was using RECAP to determine if cancer-specific, chemical-specific cancer bioassays were needed, or if the robust data available for related phthalates adequately addressed cancer hazards. This use case is aligned with RECAP's purpose. For o-DCB, EPA is attempting to use RECAP to answer if the chemical's limited and equivocal database leaves uncertainty regarding potential carcinogenicity. The o-DCB database does contain studies that indicate carcinogenicity, and these studies are further explained in our joint NAMs comments. EPA cannot use RECAP to simply conclude that uncertainty is low for each line of evidence. We respectfully request that the SACC consider the EPA's use of RECAP for o-DCB is not scientifically defensible nor appropriate in this case. Now I'll turn to the issues with the HHCB RECAP assessment related to question 4B of the SACC charge. As noted in our written comments, the EPA has known since 2014 that HHCB lacked cancer bioassay studies and had ample authority and opportunity to order them. Unlike DIBP and DCHP, the HHCB database assessed with RECAP contains significantly more data gaps. For example, toxicokinetic information is only available for dermal exposure, but EPA did not evaluate dermal hazards. EPA's RECAP assessment does not provide any rationale for how the absence of toxicokinetic studies related to the quantified oral and inhalation hazards are compensated by only dermal data. The joint written NAMs comments further highlight areas where the HHCB RECAP assessment lacks data and rationale. We respectfully request that the SACC consider that the limited data for HHCB and lack of rationale to support a finding of no uncertainty make the application of RECAP unsuitable for HHCB. The source for these comments are provided in more detail in the written comments submitted by Earth Justice and NRDC on NAMs, and separately in comments submitted by Earth Justice specifically on HHCB. Thank you all again for your time and attention today, and I'm looking forward to continuing to watch the SACC discussion over the coming days.
Thank you very much for your comment. Are there any questions? for Caitlin Kakula. Okay, so let's keep going and we move to the next presenter, and that would be Jonathan Kalmus-Katz from Earth Justice in New York, New York.
Thank you and good afternoon. I'm John Kalmus-Katz, an attorney with Earth Justice. We submitted written comments on 3 of the 4 chemicals that the SACC is discussing this week. Today, I'll focus on 2 issues raised in those comments. The impermissibly narrow scope of the HHCB risk evaluation, which goes to charge questions 18 and 19, and EPA's failure to apply necessary uncertainty factors for o-DCB, which goes to charge question 3. HHCB is a persistent, widely used, and toxic fragrance. Yet EPA proposed finding that it presents no unreasonable risk to human health or the environment, which would leave the chemical wholly unregulated under TSCA. To support any risk determination, EPA must comprehensively evaluate chemical exposures and risks under the conditions of use, alone and in combination. The draft HHCB risk evaluation does not come close to that required analysis. For consumers and workers, EPA calculated risks from only 3 of the chemical's 22 COUs, and only through 1 exposure route. EPA claims that because it expects those uses to result in the greatest overall exposures, if they don't contribute to unreasonable risk, then neither should any other use. That approach is unsupported and unlawful for multiple reasons. First, there's nothing in the record to back EPA's expectation that the exposures that it evaluated will exceed those from all other COUs. This morning, EPA said that domestic worker exposures were likely to be lower than consumer exposures. But when you look at all the ways that domestic workers can be exposed from multiple products as well as air fresheners, there's really nothing that supports that. Second, risk is not solely a function of exposure, and EPA has never considered whether people who are exposed to HHCB from the uses that it failed to evaluate would be more susceptible to harm. Third, even if the 3 selected uses did not contribute to unreasonable risk on their own, the SACC has repeatedly told EPA that it must also consider aggregate risks from combinations of uses, pathways, and routes. While the draft risk evaluation evaluates a handful of aggregate exposure scenarios, EPA's failure to calculate exposures from the vast majority of COUs precludes a true aggregate exposure analysis. To Dr. Cobb's question this morning about whether the 24/7 consumer exposure scenario would cover aggregate exposures, it does not, since you can have continuous exposure to an air freshener and also use HHCB-containing products at the same time, and people who work with HHCB and then come home to rooms with air fresheners may have higher total exposures than people who are only exposed as consumers. Fourth, EPA understated exposures and risks from the few HHCB uses that it did evaluate. I don't have time to address the shortcomings of all of those exposure and hazard assessments today, but there are air fresheners and other products that contain higher concentrations of HHCB than EPA used in its high-end assessments, and I refer the SACC to our written comments for more information on that. Turning to o-DCB, so as you heard yesterday, EPA calculated transcriptomic points of departure based on a 5-day study of rats and mice. EPA's own guidance calls for the use of a 10-fold database deficiency uncertainty factor when it's relying on transcriptomic PODs. That adjustment is needed because, according to EPA, developmental, reproductive, endocrine, neurotoxicity, and immunotoxicity endpoints are not fully addressed by its 5-day in vivo transcriptomic study. Here, EPA lacked data on those endpoints, and it failed to apply the recommended uncertainty factor, resulting in a significant underestimate of o-DCB's risks. And I want to close with one point that is not in our written comments. Yesterday, CNN published an alarming report of political interference with EPA's TSCA risk evaluations. Multiple EPA scientists said that they were pressured by political appointees to make findings of unreasonable risk disappear, and that they were told to ignore factors that can increase susceptibility to chemical risks because considering them would run counter to the administration's anti-DEI policies. Few chemicals were mentioned by name in that report, but it covers the period when all of the risk evaluations being discussed this week were being developed. TSCA requires EPA to make decisions based on the best available science, not political coercion. The SACC's role is to advise EPA on what the best available science is. While this is an admittedly unusual request, I urge the members of the SACC to review that report, which I'm going to be attaching to my oral comments. If the situation that it describes runs counter to your understanding of the best available science, I urge you to let EPA know that as well. I thank you for your time, and I'm happy to answer any questions.
Thank you for your comment. And if there are any questions, George Carr.
Yes, thank you for those comments. I really appreciate them. I want to ask a clarifying question. Do your written comments contain the HHCB concentrations in products that were not reported in the EPA document? Is that what I heard you say?
They do. There was a plug-in vehicle air freshener. This is a spray air freshener that contains 25% HHCB, which is twice as high as EPA used. And there was a fragrance oil that can also be used as an air freshener that contains 40% HHCB. Both of those are referenced in our comments, and there are cites to the SDSs.
Excellent. I appreciate you clarifying that, and I enjoyed your comments. Thank you.
Thank you.
Thank you. Do we have any other questions? Okay, let's move on to the next presenter, and that would be Paige Varner from Environmental Defense Fund in Durham, North Carolina.
Yes, thank you. Good afternoon, SACC. My name is Dr. Paige Varner, and I'm a scientist with Environmental Defense Fund. I appreciate this opportunity to comment. EDF appreciates the work EPA has put into the risk evaluation for phthalic anhydride and the SACC's review of this. However, I'd like to comment on a few deficiencies that result in substantial underestimation of risks to workers, consumers, and the general population in the draft phthalic anhydride risk evaluation. First, EPA incorrectly concluded that fence line communities are exposed only to O-phthalic acid and therefore did not assess risk from phthalic anhydride in ambient air. EPA incorrectly assumed that phthalic anhydride hydrolyzes in air at the same rate it does in surface water. EPA then selected the shortest available hydrolysis half-life in water from the literature of 30 to 90 seconds as a surrogate for hydrolysis in air without providing justification. Simple wind transport calculations show that phthalic anhydride released from a facility reaches 100 meters in as little as 33 seconds in typical wind conditions of 3 meters per second. Therefore, it is likely that fence line communities will be exposed to phthalic anhydride or at least a mixture with O-phthalic acid in ambient air, and EPA must assess general population exposure to phthalic anhydride itself. Second, EPA also ignored the potential for mixture effects between phthalic anhydride and O-phthalic acid, which is an irritant. EPA assessed the chemicals in isolation. However, both are present simultaneously in real-world exposure scenarios. A recent systematic review by Jensen et al. Published this year found that co-exposure to a sensitizer and an irritant enhanced the sensitization or elicitation response, in most cases resulting in synergistic effects, therefore reducing the threshold dose to induce sensitization by up to a factor of 10. The review also found that no validated NAMS-based approach exists for mixture assessment, indicating that EPA's SARA ICE model, which was used to derive the dermal point of departure, does not account for co-exposure to O-phthalic acid. EPA should instead assess risk from combined exposures to both phthalic anhydride and O-phthalic acid. Next, EPA's uncertainty factors applied in its human health hazard assessment are insufficiently protective. For example, EPA selected a loic to noic uncertainty factor of only 3 for the inhalation point of departure, or POD, rather than applying a well-supported factor of 10. Particularly, EPA ignored a statistically significant increase in asthma that supports a larger uncertainty factor. EPA's comparison of background asthma rates or asthma prevalences in American adults today to asthma observed in Swedish workers in the 1980s is not an appropriate rationale to disregard this finding. For the dermal POD, EPA applied a human variability uncertainty factor of 1, or in other words, no safety margin at all for variability in human sensitization responses to dermal phthalic anhydride exposure. In the formaldehyde risk evaluation, EPA applied a 10-fold human variability factor for the dermal POD and should do the same here, particularly as the most sensitive effect, elicitation, is the same for both chemicals. EPA should further consider elicitation as the most sensitive effect for phthalic anhydride, since people are repeatedly exposed to phthalic anhydride and elicitation occurs at doses lower than sensitization. Next, EPA failed to consider real-world exposures to phthalic anhydride by not aggregating exposures across conditions of use, exposure routes, and population categories. EPA even acknowledged that consumers may use both adhesives and paints containing phthalic anhydride, and that consumers can simultaneously be exposed dermally and by inhalation. Further, workers also use consumer products. EPA should update its assessment to capture these aggregate exposures, as this is the best available science. Finally, with respect to potentially exposed and susceptible subpopulations, EPA states that bystanders of all ages were quantitatively evaluated, yet no child-specific inhalation rates or body weight adjustments appear anywhere in the bystander analysis. Pregnant women are also not considered as pests, despite ophthalic acid carrying a GHS reproductive toxicity classification. And workers with pre-existing sensitization are also not characterized as a distinct susceptible subpopulation. We urge EPA to provide a complete quantitative risk characterization for susceptible subpopulations in the final risk evaluation as required by TSCA. These comments and all the sources are provided in more detail in our written comments that were submitted in May. Thank you for your time.
And thank you for your comments. Are there any questions? Okay, then our next commenter would be Julie Pankow from Tox Strategies in Pittsburgh, Pennsylvania.
Hi, everyone. My name is Julie Pankow. I'm a principal scientist and certified industrial hygienist with Tox Strategies. Today, I'm speaking on behalf of the ACC Phthalic Anhydride TSCA Consortium, and I appreciate the opportunity to share comments and observations on the occupational risk assessment aspects of the draft risk evaluation for phthalic anhydride. Next slide. The first topic is regarding EPA's categorization of worker exposures. In EPA's evaluation of worker exposures to phthalic anhydride in the manufacturing and processing COUs, the agency performed a literature search to identify worker activities that could potentially result in occupational exposures. As a result of this search, EPA identified specific tasks, namely bag handling, unclogging baghouse chutes, filling drums with process impurities, and cleaning equipment with high solids content that lead to higher levels of inhalation exposure. Consequently, EPA categorized the manufacturing and processing workers that engage in short-term high-exposure tasks as quote-unquote high-exposure workers. Workers who were not associated with these tasks were categorized as just workers. The high-exposure workers were assigned to this category regardless of their job title and actual tasks that each perform. As a result, all of the high-exposure workers were assumed to have the same central tendency and high-end full-shift exposures, regardless of their actual job function and tasks. This mixing and matching of job titles and tasks is inappropriate because the activities of the workers are different. For example, operators do not perform the same tasks as maintenance or others. Additionally, the duration and the frequency of their tasks may be different, and the activities of the worker when not performing the high exposure tasks will be different. Combining different job titles into one exposure category across the COU can lead to exposure misclassifications. The recommendation is to analyze worker exposures by job titles to approximate similar exposure groups within a COU. This will reduce the potential for exposure misclassification and allow for better translation to risk management. Next slide. The second topic I have is the use of short-term task level data. In calculating full shift exposures for the quote-unquote high exposure workers, EPA assumed that the task durations were 2 hours and that for the balance of the 8-hour or 12-hour shift, the exposures were equivalent to worker full shift exposures. EPA has indicated that the task exposure duration is assumed because actual task durations were not available to them. A closer review of the literature used for the manufacturing COU, however, provides data that demonstrates that the assumption is incorrect and an overestimate. In the Excel file named Draft Occupational Exposure and Risk Calculator for phthalic anhydride, the manufacturing tab includes a list of all the data used to assess workers in the COU. The table on this slide is an excerpt of that data where full shift air sampling data were available for workers who performed those high exposure tasks. As shown, the full shift exposures calculated by EPA are orders of magnitude higher than those reported in the data submission. The recommendation here is that task level data should be used to target activities that contribute significantly toward the full shift exposures in order to identify where exposure controls should occur. And use the full shift data that's provided to characterize the potential for long-term exposure. Next slide, please. Lastly, in response to charge question 13A, the consortium is not aware of another study with values for dermal loading of solids onto the skin besides those that EPA has considered. However, it seems that in the case of phthalic anhydride, that standard operating procedures requiring PPE should be considered in the dermal exposure assessment. In EPA's dermal exposure assessment for workers in the COU, it was assumed that there was dermal contact across the surface areas of both hands and a quarter of the arms. This assumption is likely to significantly overestimate dermal contact as it fails to consider SOPs at the facility level. Because phthalic anhydride is classified as a sensitizer, the consortium companies are required to assess the potential for their workers' exposure and select PPE to protect them in accordance with OSHA's PPE standard. A survey of the consortium members confirmed that the dermal protection for workers is used. It's used consistent with the physical form of the chemical being handled and the potential for opportunity for contact during work tasks. This survey data was submitted with written comments for the SACC's review. The recommendation on this point is for the agency to account for the required dermal protection in the final risk evaluation. And that's the last of my comments. Thank you for your time.
Thank you for your comment. Any questions? Okay, so let's move to the next oral comment. Sorry.
I have a question.
Okay, please.
In the classifications that this is Dr. Chris Chasen. In the classifications that you're suggesting, where would you place people like the cleaners of the containers, tools, or floors after spills? And you suggest like a high level, lower level. How would you classify something like that, please?
I'm not suggesting a high level or a lower level. I'm suggesting that the worker exposures be categorized according to job title. It seems the clearest way to do that. So I suppose that cleaners who have potential for contact with phthalic anhydride be assessed by their job title. That's my recommendation.
Okay, thank you.
Okay, Mr. Wright, you have a question?
Yes, I do. Thanks for your presentation. You indicated at the end that that OSHA requires, if I heard you right, OSHA requires employers to provide PPE against dermal sensitizers. Can you refer me to the precise OSHA standard that requires that?
So OSHA requires employers to assess chemical hazards that workers may be exposed to and provide the appropriate PPE to protect them. So that's in the OSHA standard. It's 29 CFR 1910.132.
Thank you.
Mm-hmm.
Thank you for your question. Are there any other questions? All right. So our next commenter would be Chad Thompson from Tox Strategies in Houston, Texas.
Yes, thank you. So my name is Chad Thompson. I'm a toxicologist and risk assessor at Tox Strategies, LLC. And my comments today were on behalf of the American Chemistry Council's Phthalic Anhydride TSCA Risk Evaluation Consortium. Next slide. So as the overview slide here indicates, and generally overall supportive of the point of departure, selected, start your video, sorry. Can you guys, okay, video started. Okay, so as my slides indicate, I'm in support of the overall point of departure used for the respiratory sensitization endpoint, although I do note and support previous comments that this is likely an overall conservative value. My comments today focus on the uncertainty factors that EPA applied to that point of departure in deriving their effective hazard value. Next slide. So with regard to comments on the human toxicokinetic variability factor, EPA considered either a value of 3 or 1. And I agree with the characterization in the TSCA evaluation that generally haptenization is chemically mediated, and thus the lack of metabolism, et cetera, would reduce the human variability, and would also indicate or remind people that the various adverse or key events in the adverse outcome pathway for respiratory sensitization would be addressed by the threefold toxicodynamic factor. However, there could be a variation in lung dosimetry that could warrant a threefold uncertainty factor for toxicokinetics. And so in the assessment, EPA evaluated the magnitude of this pharmacokinetic factor using 2 methods. One was the MPPD modeling program, and the other was equations from ICRP 1994. Next slide. As we heard yesterday, the results in Appendix E indicated that for using the MPPD program, that the activity levels had a great impact on the phthalic anhydride dosimetry to the tracheobronchial region. And broadly, heavy exercise and sitting respectively increase and decrease the dosimetry to the tracheobronchial region by about 1.5-fold, which EPA used as potential support for a toxicokinetic factor of 1. However, they also noted that the distance between the predicted dosimetry from sitting versus heavy exercise was 3-fold, which EPA also used as partial justification for the 3-fold toxicokinetic factor option. However, we point out that based on the high exposure workers being exposed during vessel loading, that the sitting scenario would seem to lack relevance here. We also ran additional analyses in MPPD using parameters for females, since that was not presented in the report, and found that those differences were similar to males, indicating less than 1.5-fold differences in dosimetry. And we also compared normalized dose metrics between males and females under light and heavy exercise, and again found those estimates differed at most 1.4-fold. So together, these analyses in MPPD support either a data-derived uncertainty factor of 1.5-fold or simply 1, and do not support an uncertainty factor of 3. Next slide. Yeah, so as described in the Appendix E, EPA also evaluated the phthalic anhydride deposition in smaller and larger individuals, basically a proxy for females and males, by varying the upper respiratory tract volume by 20%. And EPA noted that in the smaller individuals, one would expect more impaction of phthalic anhydride in the extrathoracic region, and thereby would also have decreased penetration to the lower lung, when in fact the NPD modeling results indicated that there was very little change to the deposition in the extrathoracic region and actually slight increases in dosimetry to the tracheobronchial and pulmonary regions. So this sort of unexpected outcome, we think, allowed EPA to focus or rely more heavily on the ICRP report equations. And as we heard yesterday, by using the 95% confidence limits on some of the parameters in these model equations, that the predicted penetration differed approximately threefold between the central tendency and upper 95% confidence limits in each sex, and EPA used these differences to support a human toxicokinetic factor of 3. Now, one of the things we were able to replicate most of the results with NPD modeling, but the transparency of the results from the ICRP approach in the Appendix E was lacking a little bit. And so we would request that EPA be more transparent about that. In particular, there was reference to Brown et al. 2013 as what EPA was using as the basis of these analyses. And looking at that paper, we did not see the same magnitude of differences between the central tendency and the 95th percentile. So some improved transparency here would be helpful, and that would help address the issue of whether these predictions would reflect true differences among healthy working age individuals. So basically, we're asking for an increased transparency with regard to the ICRP analyses. Next slide. With regard to the low L to no L uncertainty factor magnitude, EPA's 2002 reference dose and reference concentration process review indicates that the magnitude or size of the low L to no L uncertainty factor should be influenced by the magnitude and nature of the responses at the low L. And as EPA presented in Appendix E, that there were minor statistical differences in effects between the high and low exposure groups, indicating an apparent shallow exposure response pattern. And even the statistical differences that were observed, for example, between asthma in the high and low exposure groups were questioned, given that the incidence of asthma in the low dose group or the comparator group was essentially 0%, which is below background. Next slide. EPA 2002 also cites evidence that the low L to no L ratio is frequently empirically observed to be around threefold and more rarely 10. And more recent meta-analyses report that the median low L to no L ratio is approximately 4. If we consider that the low exposed workers in the Nielsen et al. Study were exposed to approximately the limit of detection of 0.1 mg per cubic meter, then the ratio of the LOAC to the hypothetical NOAC here would be at least 4. So taken together, the analyses that EPA presented in Appendix E, the historical NOEL to low L ratio data, and the possible difference in exposure between the LOAC and the potential NOAC here supports EPA's decision to use a threefold low L to no L uncertainty factor. Thank you.
Thank you for your comment. Are there any questions? Okay, we can move to the next presenter, public commenter, and that would be Rashmi Juglikar from Stanford University in Stanford, California.
Thanks, Ella, and hello to all. My name is Rashmi Juglikar. I'm the Science Policy Director for the Woodruff Science Policy Lab at Stanford University. I have no financial conflicts of interest to declare, and I appreciate the opportunity to provide comments today. I want to stress that across all 4 evaluations that are being reviewed by the SACC, EPA does not use the best available science and relies on an incomplete evidence base, the inappropriate application of new approach methodologies, or NAMs, and the industry-aligned recap framework that's been discussed today to downplay and disregard health hazards that will result in acceptance of serious risks to human health. First, the evidence bases for all 4 assessments are incomplete and selectively filtered. EPA did not conduct a comprehensive up-to-date literature search for any of the chemicals, and in some cases performed targeted updates only for select endpoints. In HHCB, phthalic anhydride, and p-DCB, EPA for the first time in TSCA risk evaluations introduced data evaluation records for hazard evidence, an approach that is not a systematic review method. For o-DCB and p-DCB, EPA failed to publish publicly accessible chemical-specific protocols and unduly narrowed epidemiologic evidence through a further filtering step that excluded PICO-relevant studies with fewer than 3 exposure levels. In HHCB, EPA limited epidemiologic data extraction to studies with statistically significant findings. Statistical significance is not a valid basis for including or excluding studies and introduces avoidable bias. EPA must apply gold standard systematic review methodologies to fully evaluate the scientific evidence and obtain all reasonably available information in accordance with recommendations from the NAS and consistent with the IRIS and OHAT methods. This means discontinuing non-transparent further filtering processes, the use of data evaluation records in place of systematic review, and requiring chemical-specific systematic review protocols to be published for public comment well in advance of the draft hazard or risk assessment. I also want to stress that EPA cannot adequately determine data gaps for any of these chemicals without starting with a complete evidence base. Second, EPA misapplied new approach methodologies. Despite identifying sufficient in vivo evidence for cancer and non-cancer hazards for the dichlorobenzenes, using inadequate evidence evaluation methods, EPA dismissed those data to justify using a 5-day transcriptomic ETAP study that's also been discussed today to fill non-existent data gaps for o-DCB and to support a mode of action judgment that was then used to discount cancer risk for p-DCB. The ETAP standard method states that transcriptomic changes used to identify a point of departure do not discriminate between specific hazards and are not used to infer mechanism or mode of action. It is only intended to derive non-cancer PODs when repeated dose animal or adequate human evidence are lacking. I want to emphasize that those words are repeated in the standard method at least 5 times. EPA's application of ETAP for both the dichlorobenzenes significantly departed from the standard method, restricting sex and tissue coverage, as Jen Sass mentioned in her comments, using narrow gene set selections and omitting recommended uncertainty factors, all without adequate justification or the external peer review that BOSC and EPA have said is required for such departures. TSCA allows reliance on NAMs only when they provide information of equivalent or better scientific quality and relevance than traditional animal testing. EPA's ETAP studies and analyses are underpowered and significantly deviate from the standard method, external peer review, and cannot replace existing evidence. Finally, EPA failed to conduct a full and unbiased cancer hazard evaluations for the chemicals. I want to draw attention to the fact that while EPA claims that it used the RECAP framework only for evaluating cancer hazards and 2 chemical assessments, principles from this framework, including waiving the need to characterize cancer hazard, relying on data from NAMs, refuting alternate modes of action, asserting that acute effects are protective of chronic effects, and declaring that chemical non-genotoxic effects, even with positive genotoxicity data, are reflected throughout all 4 assessments to downplay hazard and risk. This is a blatant violation of scientific integrity, and it must be addressed by the SACC. EPA should eliminate the use of data or methodologies that do not constitute the best available science, or the use of data obtained from studies with authors that have financial conflicts of interest or are funded by industries with direct financial conflicts of interest. EPA should also conduct full cancer hazard assessments that take into account all relevant human epidemiologic evidence, in vivo evidence, and mechanistic evidence in accordance with those cancer guidelines. Thank you.
Thank you for your comment. Any questions? Okay, so our last oral commenter would be Ted Simon from Ted Simon LLC in Winston, Georgia.
Thank you for the opportunity to speak.
If you can turn on your camera, it would be great if you can turn on your camera. If not, then no problem.
I got my camera working. Give me just, I can, sometimes it
No worries.
chokes out on me, and I know how to fix it.
It's okay. So don't worry about the camera. That's fine.
Almost there. Can you see me now? Yes.
Yes, thank you.
Okay. Okay. Thank you for letting me speak today. The Toxic Substances Control Act requires the EPA administrator to reduce and replace the use of vertebrate animals in the testing of chemical substances, quote, to the extent practicable, unquote. And that is, provided such actions are scientifically justified. As part of reducing and replacing animal testing, TSCA also requires the use of computational methods and accompanying prediction models prior to animals testing. My comments today will describe a highly cost-effective approach that does not include any animal testing at all and addresses charge questions 1 through 3 in the draft charge to the TSCA SACC. As noted in these charge questions, EPA has proposed the use of the ETA transcriptomic assessment product, the ETAP, as a cost-effective alternative to traditional animal testing. The ETAP is indeed a cost-saving method, and the economic benefit of ETAP has been demonstrated by Hajiwara et al. In a 2023 paper in the journal Risk Analysis. Here, I suggest using the threshold of toxicological concern, or TTC, as another cost-saving measure prior to ETAP. Now, briefly, the TTC is the level of human exposure considered to be of negligible risk based on different classes of chemical structure originally developed by Kramer et al. In 1978. In a 2023 commentary to the journal Regulatory Toxicology and Pharmacology, authored by myself, Dr. Jessica Ryman, who also spoke today, and Dr. Rick Becker, the use of 2 TTC values, the first 1.5 micrograms per kilogram per day for Kramer class 3 substances and 0.0025 micrograms per kilogram per day for genotoxic substances, were compared with ETAP using a value of information approach. The cost of delay for using the TTC was much, much less than for ETAP, and the return on investment was orders of magnitude greater. Now, these values are shown in the table accompanying my submitted written comment, along with a flow chart for incorporating the TTC into the workflow for developing toxicity guidance values. The set of substances used in developing ETAP was also used to develop the economic benefit of using the TTC. Details of the calculation provided both in the commentary that I and Drs. Ryman and Becker authored and in the Hajiwara et al. Paper. On average, the return on investment using the TTC was about 5 million-fold that of traditional human health risk assessment methods and 140,000-fold greater than ETAP. Hence, I raised 2 questions. First, why not take advantage of the TTC as an initial screening step to fill the applicable data needs prior to initiating any additional in vitro or in vivo testing? And second, isn't the decades-long experience with the TTC sufficient to provide enough confidence to waive requirements for animal testing when actual human exposure, albeit with an adequate margin exposure, is lower than the corresponding TTC? I'll stop there. Thank you for allowing me to speak. I'll answer any questions.
Thank you very much for your comment. And if there are any questions, all right. So that concludes our public oral comment session, and I will turn it back to the chair of the SACC, Dr. George Cobb.
Thank you, Dr. Kamal, and thank you for leading us through that public comment period. I think my time here in this last minute is short because it's time now for us to take a lunch break, and so I think we'll do that, and Would it be 1 hour, Dr. Camo?
Yes, so give enough time for everyone to have lunch and be ready for the afternoon session.
All right, and we'll see you back in an hour.
Thank you.
Right. Welcome back. It's George Cobb chairing the EPA Science Advisory Committee for Chemicals. We're entering our afternoon session for Tuesday afternoon. And it's time for us to take the roll before we get started back. So let's get through that. Dr. Apte?
Yeah.
And Dr. Fong?
Here. Thank you.
Dr. Baker?
I'm here.
Dr. Chason?
Here.
Dr. Fox? Okay, Dr. Gentry?
Here.
Dr. Graham?
I'm here.
Ms. Jenkins?
I'm here.
Dr. Lee?
I'm here.
Dr. Merced Nieves? Okay, Dr. Ottinger?
I'm here.
Dr. Prisbilla?
Here.
Dr. Rubin?
Here.
Dr. Samuel?
Here.
Mr. Wright?
I'm here.
Dr. Gadia?
I'm here.
Dr. Islas Robles?
I'm here.
Dr. Caramaus?
I'm here. Thank you.
Dr. LaRocca?
I am
Dr.
here.
Thank you. Thank you. Dr. Lovato?
I'm here.
Dr. Pandiri?
Present.
Dr. Rager?
I'm here.
Here and hopefully ready to go.
Sure.
Dr. Slink?
Here.
Dr. Shao?
I'm here.
Dr. Strickland?
Hello.
And Dr. Wolf?
Present.
Okay, so let's go back real quick. Dr. Fox? Dr. Merced Nieves? Okay, so we still have quorum, but those two folks we don't.
I'm showing my face again. Hello. I was here earlier as well.
Great, thank you. Okay, let's really quick circle back to see if there's anything that the committee wants to bring up before we start the afternoon session. All right, if not, Mike, are you trying to ask a question?
Yes, I'm trying to. It's really not a question, it's just a statement. I want to make sure this is in the record. The final speaker, whose name I have forgotten, from I believe ACC, said that that OSHA essentially required companies whose workers were exposed to phthalic anhydride to wear protective equipment. And she correctly cited the OSHA standard, which on its face does that. The standard, though, which I worked on, is actually mostly requiring employers to pay for it. There is some language that suggests that suggests employers should require PPE for things that are not regulated by OSHA, which this isn't. It has never been used successfully. Occasionally, OSHA has used it as a bargaining chip, always removing it during settlement talks. As far as I know, no company has ever been successfully cited for it. And I just want to make sure that was clear after the answer.
Yeah, thank you, Mr. Wright. That's very important information. Anything else on the committee? All right, if not, we can turn the floor over to the OPPT folks and to get us through the first charge question.
We're not hearing you, Dr. Lowett.
All right, let's try it again. Sorry about that.
We're here now.
So Dr. Cobb, we did have one clarification that we're prepared on related to the DCP epidemiology question from this morning. Do you want to do that now because we'll be talking about DCBs this afternoon, or do you want us to hold on that?
That is excellent. Please proceed. I was trying not to put you on the spot so many times in one day.
So I'm going to pass to my colleague, Keith Jacobs, and he has the answer to the question.
Hello, this is Keith Jacobs, EPA. This is in response to Dr. Rubin's question. What is the rationale for filtering epidemiological studies with fewer than 3 exposure levels? And please clarify if you asked a different question. But in response to that question, we offer that as stated in section 2.1.1 of the draft human health and environmental hazard, this is for both O and P dichlorobenzene, should be the same. EPA adopted further filtering as a fit-for-purpose approach before studies underwent data evaluation and extraction. The purpose was to increase the efficiency of systematic review by filtering out studies that include fewer than 3 exposure levels, including control, because in that case, if studies did not have more than 2 exposure levels, they could not be used quantitatively for dose response analysis. However, although those studies were filtered out and do not have data quality ratings, they are still discussed in the hazard identification section, and they do contribute to the overall weight of scientific evidence for their respective health effects. That's all. Thank you.
Thank you very much. That was my question.
Dr. Rubin, did you say that answered your question?
Yes, thank you.
All right, well, thank you for getting that response to us. And now we can proceed to charge question 1.
Okay. Hi, everyone. I'm Anne Huang from EPA. I'm the assessment co-lead of the para-dichlorobenzene project. I'm going to read DCB charge questions into a record. Charge questions, transcriptomics supporting O-dichlorobenzene and the p-dichlorobenzene hazard. Next slide. Next slide, please. Can we go back to the charge question 1? Yes, thank you. Charge question 1. In 2023, EPA's Office of Pollution Prevention and Toxics, OPPT, requested that the National Institute of Environmental Health Sciences, NIEHS, conduct a 5-day in vivo inhalation study with targeted transcriptomics for o-dicobenzene, NIEHS 2025, for use in the forthcoming TSCA draft risk evaluation, US EPA 2026. As part of EPA's efforts to apply transcriptomic-based approaches for human health risk assessments, EPA explored multiple approaches for interpreting the transcriptomic data. These analytical approaches were designed to identify differential expressed genes and analyze aggregated gene sets to determine transcriptomic points of departure, TPODs. Furthermore, a variety of approaches were utilized in the analysis for o-dicobenzene to evaluate the appropriateness of mechanism-informed TPOD derivation. EPA is seeking comments from the SACC on the bioinformatic analysis of o-dicobenzene described in section 4.2 of the technical support document for the draft risk evaluations, supporting hazard characterization of o-dicobenzene and the p-dicobenzene using 5-day in vivo transcriptomic studies. US EPA 2026. EPA evaluated 6 different approaches for deriving TPODs for o-dicobenzene using 3 different signature catalogs and 2 different estimates. Example, the lowest value estimated over the 5th percentile of the distribution of the gene set catalog. Next slide, please. The most conservative. Example, lowest value estimated TPOD from the Gene Ontology Biological Process Catalog. Example, GOBP low. Specifically, this is the lowest gene set BMDL from the GOBP catalog. The most conservative. Example, lowest value estimated TPOD from the Molecular Signature Database Catalog. Example, M6DB low. Specifically, this is the lowest gene set BMDL from the M6DB catalog. The most conservative. Example, lowest value estimated TPOD from the mechanism-informed supersets within the M6DB catalog. Example, M6DB superset mean that are related to apical outcomes. Specifically, this is the lowest gene set BMDL from the M6DB catalog within the superset space. Using the 5th percentile of the distribution of gene sets from the GOBP catalog as a TPOD as described in section 4.2.3 and presented in tables. Example, table 4-1. Using the 5th percentile of the distribution of gene sets from the full M6DB catalog as a TPOD as described in section 4.2.3 and presented in tables. Example, table 4-1. Using the 5th percentile of the distribution of mechanism-informed supersets from the M6DB catalog as a TPOD as described in section 4.2.3 and presented in tables. Example, table 4-1. For each approach in I to VI, please comment on the analytical approach to derive the TPODs and the visualization of the results. Please include in your comments a consideration of the mechanism-informed curated superset of terms within the SACC-DB catalog. Please also include your comments on the use of the 5th percentile of the distribution of gene sets or supersets for approaches IV through VI. Superset is defined as an aggregated gene list defined by all SACC-DB pathway names or descriptions that include the superset term supporting an apical effects, example, apoptosis, necrosis, etc.
All right, thank you for getting that into the record for us, and I truly appreciate that. And now we can turn to our lead discussant for this first very detailed question with Dr. Rager.
Sure. Am I able to share my screen so I can walk y'all through our responses? The
Yes,
correlated
you can.
response?
You can.
Okay, great. Just checking that that's okay. I feel like I'm the guinea pig going here first.
Well, if you share your screen, anything shared will have to be posted in the docket. If you are reading off this, then it's going to be transcribed, so you will not need to share it.
Okay, I think I'd rather share. There's 9 pages of feedback. So I don't think it's physically possible to read all 9 pages. So I would like it if people could maybe follow along with me, if that's okay.
So if you share it, then we will have to put it in the docket. And these are just preliminary responses summarized. They're not the final responses.
Yeah.
Okay, I won't share. I will speak eloquently, and then I will also open it up the floor to other reviewers for this question to make sure that I'm hitting the important points.
Right, and this is George Cobb. Don't feel a whole lot of pressure to get every last detail in. It's good to get the big points in. Don't leave out major points. And yes, your associate discussants will follow along after you do your presentation.
Great. All right, first I want to thank the other contributors to this response. Y'all's feedback was really helpful. We had a total of 4 reviewers to address this question. In reviewing all the reviewers' feedback, I identified major themes throughout our responses. So I collated all of the reviewer feedback according to these themes to better facilitate discussions. Just to begin with, overall, the reviewers felt like the EPA did a commendable job of incorporating this newer approach of transcriptomic-based T-pods into the risk assessment process, and believe it serves as an important first step towards improving our integration of NAMs into chemical risk assessment. And there's several bits of feedback that are in support of this effort in general, saying that it's in line with laying the crucial scientific groundwork for utilizing transcriptomics as a primary alternative approach to derive pods in the future. Also, it's important to more quickly obtain values that can protect public health. There's a quote here that includes one from Jim Jones, former OCSPPAA. He used to say that protection delayed is protection denied. This has the dramatic potential to solve that issue. So with that overall narrative provided, I then provide in the summary document a summary of some of the main discussion points that were brought up by the reviewers. So we'll read my summary, and then I'll hit on some of the highlights, and then I'll open it up to the other reviewers. The following represents some of the major points of discussion with corresponding recommendations. In terms of recommendations to improve method clarity, formatting and textual descriptions could be improved upon, particularly surrounding the reference of each bioinformatic method used to derive T-pods throughout the text, with suggestions provided below. There is also a consensus amongst panel members that there are inherent limitations to the TempoSeq S1500 Plus platform, particularly in relation to this new method using customized gene set supersets that have yet to be evaluated for reproducibility across studies. There is currently a discord among panel members surrounding the use of 3 genes as a minimum gene number per pathway gene set, though further information on this topic has been provided below in hopes that it assists discussion. Clarifications surrounding mathematical derivations of BMDs and BMDLs are requested. There is concordance surrounding the use of the 5th percentile distribution of gene sets for T-pods, and multiple reviewers also point to further justification of this selection. In terms of recommendations to improve implemented methods, there are some low-hanging fruit edits that could be applied as detailed below. The majority of discussion remains surrounding the use of the superset of mechanisms-informed gene sets. There are points of discussion pertinent to the utility of these new gene sets, rationale and transparency in how they were curated, modeling suggestions to identify if these gene set distributions might influence shifts in the 5th percentile T-pods, and effects of these supersets on response curve slopes. Multiple reviewers pointed to the limitation in using volatilized external concentration values as the x-axis in BMD modeling efforts, particularly when whole body inhalation exposure designs were employed. Reviewers at this point demonstrate concordance in using tissue-based concentrations as more suitable values for BMD modeling. There is also a discussion point supporting the investigation of highest dose group omic responses informing which gene sets to prioritize in BMD modeling efforts. Lastly, there is a discussion point poised surrounding the potential incorporation of a threshold of toxicological concern. In terms of recommendations to more clearly recognize methods limitations and context of use, there is consensus among panelists to more clearly recognize the context of use of the superset of mechanism-informed gene sets, particularly if this method is accepted and used for future assessments. There are other limitations worth clarifying in the assessment document, including animal bioassay limitations and overall applicability of T-pods. Finally, there are specific limitations discussed within section 4.2.4 to provide further clarity surrounding the use of these T-pods for the risk assessment of o-dichlorobenzene. So that was the synopsis that we drafted. I can now provide some more details on some of the more heavy points of discussion that, and then I can open it up to the panelists. To begin with, there were reviews stating that the methods appear to be standard methods in terms of data pre-processing, including pre-filtering, differential expression analysis, and curve fits that are used. Also, in terms of reproducibility and transparency, data have been made publicly available through SRA, and also all gene sets are notably from publicly available databases, increasing reproducibility and transparency. At some point, the analysis script should be posted on GitHub to further provide reproducibility and transparency. In terms of recommendations to improve method clarity, there are some specific recommendations provided to allow for the 6 different methods that were tested to be more consistently referenced throughout the text and also more clearly described at the forefront. And those suggestions are in our response. In terms of the TempoSeq platform, more information is needed on the sequence technology and reasoning for selecting this platform as opposed to whole genome sequencing and the limitations that might result from this selection. Presenting the number of genes on this panel that overlap with the query gene sets is needed. And this was supported from several reviewers. For the MSIG-DB analysis, it was noted that it was interesting to see that cell proliferation was not identified as a category. Other categories identified included apoptosis, cytotoxicity, inflammation, etc., all lead to compensatory cell proliferation, which forms the basis of cytotoxicity mode of action. And then there's discussion of the minimal gene set gene number per pathway or gene set, and why that was selected as the cutoff of using 3 genes. 2 reviewers brought this up, but then I also added in my remarks that from my experience, this is pretty standard to include at least 3 genes as a cutoff. And then I included reference to O'Brien et al. 2024 text that further justifies this, that I think the EPA could use. For BMD, BMDL calculations, it's currently unclear how the BMD or BMDL for each specific gene set or superset was mathematically derived. And then there's some suggestions to clarify this. Also, to provide further justification for the use of 5th percentile distribution of gene sets, several reviewers agreed that this was an adequate approach, and also there was further justification provided by the reviewers to further support and advocate for this approach, which is in the reviewer response. In terms of recommendations to improve the implemented method, more clear presentations of some statistics throughout the text is provided. Also to include missing data and some select visualizations are noted in figures 2.3 and 2.6. In terms of PCA visualizations, one reviewer requested that alongside the discussion of the PCA analysis, there should be visualizations. And then there was a lot of discussion surrounding the superset of mechanism-informed gene sets, including their utility. There's cautionary notes on using supersets and curated gene sets. These are groups of genes that are considered to be involved in driving same or similar cellular processes. However, this is sometimes highly subjective and based on how researchers think they work. While most curated gene sets are highly vetted, there's also a possibility that some genes may be associated with multiple cellular processes. Basing T-pods on these gene sets carries a risk of bias. Superset geneless curation. There's a request to provide more information on how the selection process occurred to enhance transparency. It's also advised to perform a sensitivity analysis to determine exactly how the estimated T-pods are influenced by these expertly curated terms. Specifically, if the expertly curated terms were expanded to include more or restricted to include fewer, how would that impact the T-pod? Also, similarly, a sensitivity analysis or simulation modeling effort was requested to identify whether the supersets might cause potential shifts in the 5th percentile derivations. Also, reviewers suggested evaluation of potential impacts of the supersets causing effects on the slope of the BMD accumulation curves. So those represent the main points from the supersets discussion. The next point of discussion that was a large one amongst the reviewers was the use of the exposure concentration values on the x-axis of the BMD modeling efforts. And there's quite a bit of detailed text surrounding this, including the identification of tissue levels identified from an NIHS report that could be included in the modeling effort. And also that this is particularly important because the design of the exposure for the 5-day test was a whole body inhalation exposure design, which heavily influences the amount of chemical that actually reaches the mouse lung and can provide variability between how much each animal gets in the lung. Also, there's alternative approaches that are discussed for GO and pathway prioritization. One of these approaches is based off of using data from the high dose group to prioritize which gene sets could be modeled throughout. Also, consideration of use of a threshold of toxicological concern was brought up as well. And then lastly, in terms of recommendations to more clearly recognize methods, limitations, and context of use, there was some discussion about the superset of mechanism-informed gene sets context of use. This is a new approach to define which gene set knowledge base is used for the derivation of gene set-based T-pods. The implications of this newer approach deem careful review and consideration. A suggestion is to provide clarity surrounding context of use for this new MOA-informed superset approach. This approach should not be extrapolated to chemicals that are understudied or lack an MOA. Setting guardrails on the utility of this new approach is vital to prevent misuse of this method moving forward. Also, the use of supersets to recapitulate apical outcomes as opposed to leveraging more global omics-based methods for quicker assessments requires further context. For example, in Table 4.7, rather than recapitulate the apical outcome approach with an attempt to align a mechanistic evaluation of DEGs using the more holistic approach would be better to illustrate the value of the use of toxicogenomics and BMD modeling for risk evaluation instead of the traditional apical endpoints. This would move the science forward quicker and move away from people still wanting to provide or search for apical endpoints when toxicogenomics is good enough and fit for purpose. There was also a suggestion to include further discussion of animal limitations within the assessment. Also, further context on the overall applicability of T-pods is requested, including addressing questions such as, does this T-pod really predict the apical effect? And then lastly, there's some further contextual explanations requested surrounding section 4.2.4. And this is hard for me to summarize, so I will read some of these sentences pertaining to the gene set approaches that provide a T-pod estimate. This approach has repeatedly been shown to be a scientifically appropriate and health protective approach for establishing a T-pod without worrying about describing a mode of action or incorporating bias into the selection of pathways to model or going down the wrong scientific direction because one can clump a bunch of genes around a specific described response that might be more related to excessive dosing than what would be relevant for human risk assessment. The goal has not changed, that being to find a level for protection. High dose effects, whether at the apical endpoint level evaluation or at the genomic level evaluation, are still effects due to excessive dosings and not necessarily relevant for risk evaluation. Also, in terms of the EPA elected to develop an alternative approach to estimate T-pods, this superset approach used to find MSIG-DB gene sets. In relation to that comment, while evaluation of the mechanistic underpinnings of the transcriptomic data is useful to further characterize the likely outcomes from continuous exposure and the test species, there's no need to perform additional evaluations since the entire gene set DEGs for BMD analysis provides an adequate determination of the BMR for risk evaluation and achieving a protective goal. In this case, the additional collections of genes indicating oxidative stress, necrosis, and apoptosis, for example, are likely high-dose events for the CAR-mediated mode of action in the liver and at most associated events in the mode of action analysis. With high doses of nuclear receptor agonist, there is well-documented increased oxidative stress secondary to the enzyme induction and stimulation of Kupffer cells in the liver and may enhance the process leading to a tumorigenic response as an associated event, but are not a key event in the CAR-MIE leading to liver tumors in the rodent. This oxidative stress can damage the hepatocytes sufficiently, leading to apoptosis or even necrosis as part of a general cytotoxic response. So that's my whirlwind tour of what the reviewers came to after addressing this charge question. At this time, I will open it up to the other contributors to this charge question.
Thank you for that detailed response. And I know that that's a lot, having had to do that myself. Several others have had to do this before too. So thank you for doing this without getting to see how it was done by some others before we started down this path. So
good.
I really appreciate it. So let's go to the associate discussants. The first one I have on my list is Dr. Wolf.
Well, yeah, Julie Dr. Egger did a great job on that. I did want to maybe belabor 2 points, which are really important. One has to do with dose response. And it is typical, as Dr. Egger pointed out in the comments, to use the high dose to identify subsets of genes that relate to pathway, in this case, apoptosis, cytotoxicity, and that type, sort of thing. But there's still artifactual high dose effects that aren't necessarily relevant for the low dose region that we're trying to select, because the point of departure is no effect. So we're really talking about the zen of toxicology, where there's nothing going on. And that's what we want to identify using these new technologies. So it's really important not to start looking at things that are at high doses and thinking they're relevant to low doses. It's the same trap we get into with 1,000 milligrams per kilogram causing liver tumors. What does that mean at 0.001 milligram per kilogram per day? So that we have to guard against that. The whole goal of using these types of approaches with a lot of dose response is to be able to characterize the biological responses when they're barely happening to small amounts, and then use that to identify a point of departure. The other thing, and I was in the clarifying questions yesterday, it seems like a week ago, but yesterday, we talked about the tissue concentrations. And that's something for decades I've always wanted our kineticists to give me tissue concentrations so I could better relate what was happening in the tissues to how much was actually going on. In this particular case, NIEHS did quantify tissue concentrations, the liver and the lung, as well as blood concentrations. So I would suggest that, and this will have a bearing on all the other charge questions and all the other answers we go down. The agency needs to go back, and NIEHS needs to go back, and you didn't have the data at the time, and actually do this based on tissue concentrations. So why do we do pharmacokinetic, physiologically based toxicokinetic models? We do that in order to understand the difference between rat, mouse, human, and how much is in the blood. So you're exposed to a dose that gets in your body, goes in your blood, and goes to the target tissues. And we use those models to be able to equilibrate across the different species. Well, here, we don't have to do that. We have to back calculate. What we actually have is how much chemical is in the liver. And we have the response in the liver. So we don't have to say the mouse is different than the rat. We just say the toxicodynamics are based on how the body responds to the chemical, how the chemical acts on the body. And we have that amount in the livers. And then you can do a single looking at that tissue concentration to the transcriptional profiling effect. Then the model, the PBTK model of the different species, will back calculate what exposure concentration you would need to see that concentration in the liver and that response. This is fabulous. This is a level of detail I wish I'd always had, both when I was at EPA and when I was at Syngenta, but never did. But now you have that, and I think it's a great test to see that. And then that allows you to do a better job of doing your human equivalent calculations based on internal concentration, and you have the blood concentration. The only thing I'll point out is in the file that's on the NIHS website, the 4 tables, female rat and female mouse, it all says 1,2-DCB. I assume 2 of them are 1,2-DCB and 2 are 1,4-DCB. So you want to make sure that when you do that, you correct that. And I think that will, if you do that and use the entire holistic approach, the whole DEGs, instead of parse out into these things that are happening in high dose, you'll you'll have a really great characterization of the response to amount of chemical in the tissue, and then you can do the public health risk preparation. And there was a comment in the public commenters about you didn't use the male. Well, it made sense actually because of the alpha-2 globulin nephropathy. That would have messed up the male rat. Whether you should have male mice, I don't think it would have mattered because that wasn't the point of the study. So that's all I have. I think anything else we can edit. So great job, Dr. Rager. Thanks.
Excellent. Thank you. Dr. Apte?
Yeah, Dr. Rager did a great job of capturing most of my comments. I just want to bring up one thing, and that is a bit of surprise to see that in the MSIC-DB, cell proliferation or a compensatory proliferation was not highlighted because the other things that are highlighted, apoptosis, cytotoxicity, inflammation, oxidative stress, and necrosis, they all actually lead to a compensatory response in the liver or in any majority of the tissues, but mainly in the liver, and that's very well recognized, and that has some bearing on the apical endpoints, and so lack of that was a bit disconcerting here. Otherwise, most of my comments were captured. Thank you.
Great, thank you. And then finally, I have Dr. Shao.
I'm not sure why I cannot turn on the video. It says it's disabled by the host. But anyway, yeah, Dr. Rager summarized my comments very well, and actually my comments was finished before yesterday's presentation. So yesterday I asked some clarification questions, and then I actually have something to bring up, and which is not provided in my previous comments. So based on my understanding, the figures 2-3 to 2-6, so each dot is a BMDL estimate of the gene set, or the median of the BMDL of each gene set. My concern or my suggestion is maybe it's better to use BMDL of the lower bound of the BMD estimate instead of a BMDL estimate. The reason we estimate BMDL is that we want to quantify the uncertainty in the modeling process. This is specifically used when we have a very important dose response data set, and this data set will be used to derive the point of departure. But in this case, when we model the genomic data, it's different. We have thousands of genes. Well, we first go through the screening process and identify the genes have significant change associated with those changes. And then we identify those genes and we model, we perform dose response BMD modeling and to identify BMD and BMDL. And usually for each data set, the genomic data set, it's the data size, the sample size is quite limited. Typically 5 or 6 dose levels, and in each dose level we have 3 repeats. That's it. So in total, probably just 15 sample points. That's very limited compared to some in vivo data sets. So in reality, the BMDL estimate is very unstable. So that's why my suggestion is for each gene dose response modeling, probably we use a more reliable estimate, which is a BMD estimate, instead of a BMDL estimate. So that's most important reason which one is more reliable. Then the second reason is that, as I mentioned, we are not trying to quantify the uncertainty in the dose response data set because there are so many. It's not, those data sets are not used for the final decision. For here, I think the main purpose is to get a reliable estimate. And then, so based on the BMD estimate for each one, for each gene, and then once you have a gene set, then we can be a little conservative once we have a gene set, and then we choose the lower bound instead of the median value. So that is something I recommend EPA to consider. And other than that, I think our panelists have already discussed some other point I mentioned in my comments.
So thank you. This is George Kopp. Thank you. Please make sure Dr. Rager gets those comments in writing. And just so that I'm understanding, basically you're saying instead of using a BMDL, use the lower bound of the BMD for a gene set. Is that correct?
Well, so there are several things here. So first the thing is they want to estimate, they do the dose response modeling for each gene. And for that step, I recommend they use BMD instead of a BMDL. So currently they use a BMDL.
Okay.
And then once each gene, they calculate the BMDL, they will find out the gene set based on those database. And then based on those gene set, a group of a BMDL, then they use a median value of those BMDLs. So in my opinion, the first one should be BMD instead of a BMDL. And then once they have a set, then I think the lower bound is more appropriate instead of the median value.
Yes. Great. Yeah. Then that's much more eloquent than I captured it. So thank you. And Dr. Rager, did you capture that as well?
Yes, I understand. And I think also providing clarity on those steps, which is also in our response of breaking down each step of each method in a table that actually goes into what value did you use for your gene-based dose response modeling, then what value did you use for your gene set-based dose response modeling. And then I think after that, then people would understand the utility of incorporating consideration of tweaking one of those selections like Dr. Shao just described.
Excellent. All right. So let's turn it over to the rest of the committee. Did anyone else on the committee have comments related to this charge question? I see Dr. Gentry's hand.
I just wanted to follow up on Dr. Wolf's comments because this kind of feeds into some of the clarifying questions I asked yesterday around the 5th percentile and using that. And I was trying to get in, I know for both the mouse and the rat, it was below the inflection point. But my point I was trying to make, and this may be addressed by incorporating tissue concentrations, is that the rat and the mouse were different. And we're using external air concentration. So while both were below the inflection, there's a big difference. And so can tissue concentration explain that rather than using air concentration?
Yeah, it absolutely does. That's why they need to make that change, because if you look at the information, for example, just real quickly, let's see, for the rat, the liver concentration of the 30 parts per million group was 237 nanograms per gram. And if you look at the, well, here, where'd it go? Yeah, if you look at Oh, I didn't pull that other document. Anyway, and the mouse was quite a bit more than that, so I won't. So at the same exposure concentration, there was a dramatic difference, sometimes many orders of magnitude as you get to higher doses.
In tissue concentration.
And the tissue concentration. And so that's why, that's why I was making the case, that's why we use PBPK models to equilibrate that, to say, okay, well, this 30 parts per million inhaled results in this blood level, this tissue level. But now we have that, so we can just look at that and then back calculate what the tissue concentration would, what the air concentration would have to be to get that level in a liver to have that magnitude of a response. And that's why, when I saw those data, I was very excited because this is a real leap forward in chemical evaluation. And to be able to do that and do the quantification back. I mean, that back when we were developing the comp tox program, this was like what we were hoping for. So kudos to the agency, this and NIHS doing the work. It's not trivial to get tissue concentrations like that. So it's quite an advancement.
See Dr. Carmouse.
Thank you. I'd just like to weigh in on the use of the supersets and especially the origin of the gene expression coming from the S1500. So I really appreciate the upset plots because it really does represent that genes are, attributed to multiple MSIG-DB pathways and that there is an overlap in gene identities contributing to these different gene sets. However, the S1500 was deliberately defined by inclusion of genes that map to multiple pathways, which is represented by the upset plot. But when narrowing down to specific MSIG-DB pathways, ensuring that an appropriate number of genes are being quantified that belong to those sets and pathways is really important. And if we're taking out the context of the 1500, which sought to identify, which pathways are most enriched and come to the top, if we're taking out the context of the genome and focusing in on specific pathways and gene sets, it would be important to identify relative to what MSIG-DB attributes for genes mapping to the pathway, how many are actually being quantified. So not just the overlap between pathways, but to say MSIG-DB thinks that, apoptosis has 500 genes and we quantify 300 of them. What relative amount is being quantified when we're looking at those in isolation of the whole genome? So I would really urge some consideration when using S1500 derived transcriptomics to apply it in a mechanistic way to make sure that we still have appropriate genes quantified to allow it to be used in that focused manner. Thank you.
Nice comments. Thank you. And please do make sure Dr. Rager gets your written versions of these comments so that she can incorporate them into the response from the committee. All right. Any other comments from the committee?
Could I get a clarification for what you just said? So my understanding is we will have written minutes from this week, correct? Of what was spoken.
Correct.
So we'll have an opportunity to collect, because we'll all be in the same boat, to collect what people say. And then if anybody is like me, as soon as I say it, I forget what I said. So to send in my comments next day of what I said yesterday is not going to happen. So, okay. So we will have all this text that we're talking now.
Yes, that will all be transcribed. There's usually a couple of days delay, but EPA is really good about getting those things to us. Okay.
And I'd like to add also, Dr. Cobb, there is also a YouTube video recording of this meeting and for every day. And the links may also, I think they are provided in the Zoom meeting invitation. And if you don't have it, please let me know. I'll send you these links. Thank you.
All right, excellent. So let's now go to EPA to see if there are any clarifying questions related to our response.
Good afternoon. This is Derek Haggard, EPA. We just want to appreciate the SACC members for all of their thoughtful comments for charge question 1, and we do not have any further clarifying questions at this time.
Okay, if there are no clarifying questions from the agency, we can move into charge question 2 if there's someone prepared there to read it into the record.
Charge question 2. The bioinformatic analysis presented in the draft technical support document for the draft risk evaluations supporting hazard characterization of o-dicobenzene and p-dicobenzene using a 5-day in vivo transcriptomic studies, US EPA 2026, represents the first quantitative use of transcriptomic data to inform a risk evaluation under TSCA. EPA is interested in comments from the SACC on the organization, clarity, and the transparency of this draft document to strengthen the o-dicobenzene and p-dicobenzene draft risk evaluations, and to inform the future evaluations that may include 5-day transcriptomic studies. Please include in your comments consideration of the utility and the completeness of the glossary of select terms, the description of the 5-day transcriptomic study, and the associated bioinformatic analysis employed.
All right, thank you for getting that into the record for us. And now we will go back to Dr. Rager to get this response into the record as well.
Sure, thank you. I'll structure this discussion similarly to charge question 1, where first I'll provide overall narrative feedback, and then I'll read out the summary of the main discussion points that were captured from this review process. And then I'll more quickly go through the reviewer comments and try to hit at all the high levels. But if I miss something or if you want to clarify anything, please, other discussants, you're welcome to clarify anything after I summarize. So to begin with, overall, we appreciate and acknowledge a custom approach was developed, intended to be fit for purpose, leveraging existing study guidelines including ETAP to integrate 5-day transcriptomic study findings into chemical assessments. Overall, the TSD is well organized and clearly written. This type of feedback was overall the sentiment amongst the reviewers. And I should mention there were 6 reviewers that contributed to this charge question. So thank you all for your feedback. To provide more details on the discussion points, these were again organized according to themes that I identified. The following represent some of the major points of discussion with corresponding recommendations. In terms of recommendations to enhance the utility and completeness of the glossary, there is consensus towards the appreciation of a robust glossary in general. Specific recommendations are detailed and are likely to be straightforward. In terms of comments and recommendations to enhance the description of the 5-day transcriptomic study, there are straightforward requests to make script publicly available, improve clarity surrounding tissue prioritization, and explain why so many tissues were contaminated, precluding their inclusion in the transcriptomic profiling analysis. There was a larger discussion surrounding the limitations of the whole body inhalation exposure design and the use of tissue-specific concentration modeling of transcriptomic dose response profiles to address this limitation. Multiple reviewers also highlighted limitations surrounding the use of only female mice and the need for improved documentation of their state within the study. Other tissues are discussed and represent easily other issues, not tissues. Other issues are discussed and represent easily addressable comments within this section. In terms of comments and recommendations to enhance bioinformatic analyses, many of the comments overlapped with those addressed in charge question 1. Additional concerns were raised pertaining to gene orthology conversions, clarifications surrounding upset plot visualizations, and other minor addressable concerns. Additional suggestions include the incorporation of the RISC-21 format for data dissemination. In terms of recommendations to more clearly recognize methods, limitations, and context of use, comments included the careful interpretation of T-pods against apical pods. The majority of discussion in this section surrounded the importance of relating findings to previous ETAP methods and results. Additional recommendations include the discussion of sensitivities surrounding tissue, gene, organ, cells, species sensitivities, and overall transition to non-chronic in vivo testing methods. So that was a summary of our main discussion points. To provide some highlighted examples of the reviewers' points, I'll now go through the reviewer feedback according to theme, starting with recommendations to enhance the utility and completeness of the glossary. Overall, the glossary was really appreciated. Reviewers thought it was pretty robust as is, but they do provide some specific suggestions of, for example, to keep definitions as generic as possible, clarify the MOA definition, add T90 into the glossary, clarify BMD, BMR, and also BMDL, and the term gene set, but specific suggestions are included. In terms of the next theme, which were relevant to comments and recommendations to enhance the description of the 5-day transcriptomics study, reviewers pointed out that the study demonstrated reproducibility and transparency from previously stated comments from charge question 1. Clarification could be provided on the tissue prioritization description to list all tissues that were analyzed for gene expression and justify why authors are only noting results from a few within the summary statement section itself. Reviewers also point out the tissue contamination issue. An explanation surrounding why so many tissues were contaminated is needed. Inhalation exposure design clarity is needed surrounding the selection of whole body inhalation exposure design. This could cause a portion of the exposures to be dermal as opposed to respirable, and much of the exposure to be scrubbed within the nasal cavity, muting the responses in the lung from actual deposited exposures and introducing inter-animal variability. This limitation could be addressed through tissue-specific chemical measures and inclusion and dose response modeling as discussed. Details on females that were used in this study. It is requested to include details like were they intact and cycling, what were their age and stage of maturation, what does 7 to 8 weeks post acclimatization mean? Similar thoughts from other reviewers as well. Further descriptive text was requested in section 3, stating that there is minimal descriptive text in this section. The TSD references the NIHS reports and provides key details in several tables. The TSD could benefit from a brief description of how the transcriptomic data are generated from the tissues evaluated. This would complement the general overview of transcriptomics in the introduction. Also, to improve the CAR endpoint utility, CAR may be an important reliable indicator of liver response despite observed differences in magnitude of response due to species, rat versus mouse. Further refinement of this measurement endpoint may provide a reliable indicator of exposure. and also some minor suggestions as well in terms of text edits. The next theme was comments and recommendations to enhance bioinformatics analyses. First, some clarifying points were suggested surrounding the methods. As discussed in charge question 1, increased clarity could be provided surrounding the explanation of the consistent explanation and reference to each of the employed bioinformatic methods. Also, in terms of the gene orthology conversion, it's not clear how scientists prioritize gene inclusion in instances when they are not one-to-one mappings of rat to human genes. And just to continue to account for species specificity of effects in transcriptional gene sets that have relevance to apical endpoints, gene orthologs are not always appropriate for defining signatures of functional gene sets. In terms of the superset gene set visualization through the upset plots, these were figures 4.3 and 4.4. There was some clarifying points in terms of how to interpret the data points on this plot. And then I included a suggestion to address this reviewer concern by providing some example legend text that we recently published from a paper from my lab that walks readers through examples of data points on upset plots to help guide them and how they can interpret them. So I included that there. In terms of transcriptomic TSD explanations on page 26, lines 566 to 568, these lines identify the second and third most DEGs from p-DCB exposures as heart and ovary. This does not appear to be the case according to figure 4.2, where the order of tissues with most DEGs appears to be in the liver, heart, lung for mouse, and liver, lung, ovary for rat. Please clarify how the rank ordering is done and how does this influence the rest of the analysis. In terms of derivation of the TPOD process, grouping into functional supergroups provides a logical basis for the interpretation and bioinformatics analyses. The consolidation of responsive genes related to potential MOAs is reasonable, but there are unknowns that show significant are there unknowns that show significant up or down regulation? The BMDL around genes associated with oxidative damage in mouse liver for o-dichlorobenzene shows considerable variability through the dose response curves. How does this affect the eventual TPOD estimation? Table 4.2 shows interesting relationships for the lowest BMDL and 5th% BMDL. This reflects not only some of the variability in the low dose effects, but also illustrates the relative variation in apoptosis and oxidative stress measures. Do the clusters of functional genes that contain fewer responsive genes show lower consistency? How about for different tissues? Are apoptosis and necrosis less reliable as bioindicators despite being important for physiological responses? In terms of gene set selection, further refinement for the selection of gene sets is suggested for grouping according to additional data from rodent studies as well as from other species. The superset approach should reduce some of the variability as well as lead to BMD analyses for setting TPODs for o-dichlorobenzene and p-dichlorobenzene. The S1500 was designed to optimize inclusion of genes that inform on multiple MSIG-DB pathways, as recently discussed. As such, there may be limits to the specificity represented for pathways of interest. For Go term clarifications, there's some minor suggestions on text surrounding how the names assigned may relate to the functional significance and perhaps not an appropriate term as it may be misleading for one of the Go terms. Maybe I'll open the floor to see what Go term that was. Transcriptomic TSD clarifications, delete unnecessary footnotes. That's minor. Please add references for the statement. Furthermore, CAR-mediated hepatic liver tumors in rodents determined by regulatory agencies is not relevant to human liver tumorigenesis. There's also a suggestion to present data in the format of risk 21. And this has been presented in several previous SACC meetings and can be incorporated using existing strategies from risk 21 decision support and communication frameworks. Lastly, in terms of recommendations for improved clarity on methods, limitations, and context of use. In terms of T-pod interpretation against relative apical pods, the use of T-pods integrated with available apical data for weight of evidence is well constructed. However, as discussed in section C 4.1, uncertainties remain for certain T-pod endpoints. Thus, further explanation of how T-pods are interpreted relative to apical pods and their role in endpoint selection would strengthen the weight of evidence. In terms of putting this into context of the previous ETAP assessment, please add to section 5 some anchoring back to the ETAP, which served as the foundation for the overall study design using the 5-day in vivo transcriptomics approach. While section B1 does delineate ETAP as a general framework with the mode of action focused transcriptomic analysis herein requiring different analysis approach, some fundamental considerations must still be addressed. For example, address why the applicability of uncertainty factors pursuant to the guideline from the standard methods for development of ETAPs was not used in this MOA-informed analysis. As stated in the B1 overview, the composite uncertainty factor of 300 should be applied for human equivalency when deriving the transcriptomic reference value. The summary sections 5.1 and 5.2 summarize final T-pod values without mention of applying uncertainty factors nor derivation of TRVs. Some consistency or acknowledgement to align or distinguish the conclusions and the language used should be included. And then this was corroborated by other reviewer feedback as well. It's also suggested to include discussion of sensitivities across tissues and genes. The liver may be most sensitive to the effects of p-dichlorobenzene. However, as pointed out, the supersets of genes may differ from o-dichlorobenzene. Also species differences. Additionally, species differences in sensitivity and vulnerability must be part of the overall interpretation and models developed from the data collected. Please update analyses to move away from nominal concentrations if the data are now available, as discussed. Lastly, overall transition to non-chronic in vivo testing should be contextualized. The transition to non-chronic animal testing will require extensive validation as well as understanding interactive organ and system regulatory pathways. Accordingly, the interpretation of data should be most conservative for potential adverse effects and consequently derivation of pods and overall risk to humans, wildlife, and other organisms. That was my summary, and I'll now pass it off to other members of this review panel to provide other clarifying points.
Excellent. Thank you for getting that into the record. That's a very nice summary. There are several discussants here, so let's just cycle through them. Dr. Ottinger?
I just wanted to say thank you. That was heroic, and I really appreciate it. All my comments are captured.
All right, great. Thank you. Dr. Fox? Dr. Fox here, I think she had a dissertation to defense to attend. Dr. Apte?
All my comments were addressed. Fantastic job. Thank you so much.
Excellent. Thank you. And then Dr. Wolf?
Yep, that covered everything that I was concerned about. So thanks.
Great. And then Dr. Kromhaus?
Thank you. I also agree that everything was covered. One thing just for the sake of getting it on the record, the glossary edits are minor and I absolutely value that there is a glossary, but for the sake of precedent and because it does come up in some subsequent charge questions, I think with regards to the use of transcriptomics data, it'll be really important to delineate the adversity language when it comes to especially setting a BMR for a cutoff of BMD. In the current glossary, BMR is stated as being, the response rate of an adverse effect. And I don't think we can necessarily consider transcriptomics data to be defining that adverse effect. I think this is recognized and stated in the document, but just not necessarily consistently applied. So for the sake of precedent and the glossary in particular, I would encourage a review of separating out the benchmark dose definition, take out BMR, and make sure adversity is appropriately addressed in this context. Thank you.
Excellent, thank you. Okay, turn it over to our committee members to see if there are comments from any other committee members. If there are no other comments from committee members, we can now proceed to charge question 2. I would like to say that Dr. Gentry is going to be moderating the proceedings now through, I believe it's charge question 6. And then I'll pick back up after she is done. Dr. Gentry, I'm only giving you the meeting 3.5 hours behind schedule.
Oh, and it's up to me to catch up, right?
No, I'm just teasing you. We're gonna gain an hour of lunch break that we're not that is built into that 3.5 hours behind. So you're gonna catch up an hour within 45 minutes or so. So I think we're really good. Usually we're behind at this point. We catch up and sometimes even end early. Ending early is probably not an option, but so I'm going to turn it over to you, and I'm sure you're going to do a better job than I did. So thank you. I'm signing off. Not signing off. I'm just in the background now.
Thank you, Dr. Cobb. I guess I will turn it over to the EPA to read charge question 3 as well as subpart A into the record.
This is Dr. N. Huang from EPA. I'm going to read charge question 3 into the record. Charge question 3, in the draft human health and the environmental hazard assessment for all dichlorobenzene, US EPA 2026, EPA determined that inhalation hazards are best characterized by critical points of departure, POD, for respiratory toxicity, and the oral and the dermal hazards are best characterized by critical PODs for liver toxicity. For these outcomes, the TPOD from lung and liver respectively were selected from the options derived in the technical support document for the draft risk evaluations, supporting hazard characterization of o-dichlorobenzene and the p-dichlorobenzene using 5-day in vivo transcriptomic studies, US EPA 2026, and were compared to POD options from apical findings in traditional toxicity studies in the o-dichlorobenzene hazard assessment. 3A, EPA has preliminarily determined that the most appropriate TPOD for use in the o-dichlorobenzene human health risk assessment come from the 5th percentile of the distribution of gene set level benchmark dose lower confidence limit, BMDL, medians using the mechanism-informed combined supersets with the M6DB catalog approach VI, specifically as found in tables 2-4 and 2-7 of the o-dichlorobenzene hazard assessment. EPA identified the lung TPOD of 0.45 ppm for inhalation exposures and the liver TPOD of 8.26 ppm, extrapolated for oral and dermal exposures from mice following inhalation exposures for consideration alongside apical PODs in the o-dichlorobenzene human health hazard assessment. Please comment on the this selection of the 50th percentile distribution of BMDL medians of the mechanism-informed combined supersets within the M6DB catalog, along with the strengths and the uncertainties of this choice.
Thank you very much. With that, I will turn it over to Dr. Wolf, who is the lead discussant for this sub-question.
Okie doke. There were 4 of us that reviewed this for this question. The challenge with this question is that the evaluation may need to be reworked based on the conclusions from charge question 1 and ultimately which approach is finally selected. And you just heard those discussions about question 1. The response to question 3A builds upon points raised in response to charge question 1 regarding the selection and derivation of the T-pods. Overall, there is support for aspects of the EPA's approach. There is methodological clarifications and statistical justifications needed. There'll be some repetitiveness in what I wrote in trying to put everybody's comments together so I don't miss anybody's thoughts. The primary issue is whether EPA's selection of the 5th percentile of the distribution of gene set level benchmark dose low confidence limit medians derived from mechanism-informed combined supersets within the MSIG database catalog constitutes an appropriate and scientifically defensible T-pod for O-dichlorobenzene risk assessment. Specifically, EPA selected a lung T-pod of 0.45 ppm for inhalation exposure and a liver T-pod of 8.26 based on transcriptomic responses in mice following inhalation exposures. The lung T-pod is conservative. However, the liver T-pod is not capturing the most sensitive responses as summarized in table 4.4-1 of the draft transcriptomic assessment technical support document, and also in comparison to the pathological-based POD modeling. In terms of transcriptomics-based POD, it appears that a more conservative approach would incorporate more globally all gene sets, regardless of mechanism, which would capture alternate pathways leading to toxicity not prioritized in the mechanistic-informed approach. In the response to charge question 1, one discussant pointed out that the high dose of the chemical drives a maximum expression of cytochromes leading to incidental oxidative stress to a degree that would result in tissue damage with sick cells, cytotoxicity, dying cells, apoptosis, rafts of dead cells, necrosis, and then cells recruited to clean up the mess, inflammation. These are all effects associated with dose response and not directly with the CAR-MIE that leads to enzyme induction, cell proliferation, and increased atypical hyperplasia that are stimulated to continue to proliferate with continuous exposure. One sees in the NIHS data that the mouse did have evidence of liver enzyme induction at the higher doses, not seen at the lower doses, but unfortunately there was no histopathology conducted that I could find on the NIHS data. But there's some publications regarding the mechanism of nuclear receptor agonism that are included in this report. Clarification on BMDL medians and methodological recommendation. The terminology and computation methodology surrounding the BMDL medians require a clarification in the text. It's not entirely clear if each data point represents the median value. I think that was clarified by EPA during the presentation yesterday, and Dr. Shao did mention that earlier. So some of that clarification has come, but it still needs to be in the report. The recommendation is using the central BMD estimate, the median or mean value of each gene to define the distribution of the gene set, then calculating the statistical lower bound of those BMD estimates for the set as a whole. This would be a more appropriate and statistically stable approach because individual BMDL estimates derived directly from genomic data can be unreliable due to sample size. complete MSIG database catalog versus mechanism-informed combined supersets. Regarding the choice between utilizing the complete catalog versus the mechanism-informed from a statistical perspective, that's easy for you to say. From a statistical perspective, using the complete MSIG database catalog provides a more consistent and objective approach. It relies on a standardized data set rather than the combined supersets, which inherently requires subjective case-by-case curation. Utilizing the complete catalog eliminates the need to continuously debate or worry about which specific gene set should be included or excluded. If the EPA proceeds with the mechanism-informed combined superset approach, it's critical to thoroughly justify the terms used to build these supersets. Therefore, a comprehensive sensitivity analysis is recommended to demonstrate that the subjective selection of those expertly curated terms has a limited or at least well understood impact on the final TPOD. One discussant agreed with the agency that the selected approach appears scientifically reasonable and health protective. By focusing on pathway level responses rather than individual genes, the method emphasizes biological coherent changes associated with toxicity relevant mechanisms while reducing the influence of highly variable gene-specific responses. The use of 5th percentile further provides a conservative estimate intended to capture sensitive biological perturbations. However, uncertainties remain regarding the biological significance of early transcriptomic changes. The selection of the percentile threshold, pathway redundancy within the MSIG database catalog, and the extrapolation of inhalation-derived transcriptomic responses to other exposure routes. The strengths of using the 5th percentile versus minimum values. Regarding the selection of the 5th percentile of distribution rather than a minimum lowest value, there was an agreement with the EPA's proposal. And let's see, it has key statistical and regulatory strengths, resistant to outliers. It's inherently more resistant to extreme outliers or biological noise. Appropriate characterization of uncertainty during the dose response assessment. Primary scientific goal should be to quantitatively characterize the associated uncertainty, relying on the absolute minimum value, and appropriately stacks conservative measures where objective quantification of variance is needed. And then robustness to new data. The 5th percentile provides a much more robust and stable estimate over time. Should new data transcriptomic data become available, a 5th percentile estimate will maintain greater consistency, whereas a minimum value is highly vulnerable to drastic shift caused by a single new data point. The 5th percentile distribution of BMDL medians of mechanism-informed combined supersets has limitation that the superset gene sets included a lower number of genes due to the nature of collapsing gene sets, affecting the overall distribution of data. Furthermore, there is bias on how the mechanistic-based gene sets were prioritized, which could be avoided when used more global approaches that more holistically capture more mechanisms. Lastly, the prioritization of the 5th percentile of this new distribution has yet to be evaluated by other research teams, representing a source of uncertainty that requires further exploration or replacement with genome-wide approaches. A strength of the selection of the 5th percentile distribution of BMDL medians of mechanism-informed supersets is that it highlights mechanisms and modes of action that may more specifically parallel overt changes observed phenotypically. Thus, the pods from mechanism-informed gene sets may correlate more closely with classical animal approaches, though we are trying to improve and move beyond these through NAMs, so it is still advised to use more global mechanistic agnostic methods. So the scientific rationale from one discussant, the mechanism-informed combined supersets approach offers several advantages compared with gene-level analyses. Grouping genes into biologically relevant pathways enhances interpretability and provides a stronger mechanistic basis for identifying molecular perturbations that may precede adverse outcomes. The use of BMDL medians further improves robustness by reducing the influence of outlier genes and emphasizing coordinated pathway responses. There was general agreement that pathway-based transcriptome analysis can provide valuable information for hazard identification and may detect biological perturbations at doses lower than those associated with traditional apical endpoints. The selected lung and liver TPODs are derived from tissues known to be relevant targets of o-DCB toxicity, supporting the biological plausibility of the findings. At the same time, several sources of uncertainty should be recognized. Transcriptome responses do not always translate directly into adverse outcomes. The quantitative relationship between pathway perturbation and toxicity remains incompletely understood for many biological processes. The choice of 5th percentile is a policy-informed decision that may substantially influence the resulting TPOD values. Alternative percentile selections could generate different points of departure and may warrant evaluation through sensitivity analysis. Gene set overlap and pathway redundancy in the MSIG database may bias the lower tail of the BMD distribution. Extrapolating inhalation-derived liver transcriptomic responses to oral and dermal risk assessments could introduce additional uncertainty regarding toxicokinetics, target tissue dosimetry, and route-specific metabolism. Despite this, the overall weight of evidence supports using the selected TPOD as complementary evidence when considered alongside traditional apical PODs. The approach is consistent with current efforts to incorporate mechanistically informed new approach methodologies into human health risk assessment while maintaining a high protective framework. Some recommendations. Conduct sensitivity analyses using alternative percentile thresholds, or evaluate the robustness of selected TPODs and quantify the impact of percentile selection on risk assessment outcomes. Provide additional justification for selecting this 5th percentile as the preferred point of departure, including comparisons with transcriptomic and apical POD concordance. Further evaluate the influence of pathway overlap and redundancy within the mechanism-informed MSIG database supersets to ensure that correlated pathways do not disproportionately influence the lower end of the BMD distribution. Continue integrating transcriptomic PODs with traditional apical endpoints within a weight of evidence framework until greater certainty exists regarding the quantitative relationship between molecular perturbations and adverse outcomes. Let's see, and there were some specific comments made line by line throughout the TSD that are also presented in here that are specific typographical or grammar or some other suggestions for clarification. So that concludes my reading of the will.
Okay, thank you, Dr. Wolf. I guess we'll check with the other discussants on this question, see if you have anything to add. Dr. Rager?
Nope, Dr. Wolf did a great job summarizing our feedback.
Okay. Dr. Lovato?
No, I've been checking. Dr. Wolf did an amazing job. He summarized and even extended my recommendations and concerns. So yeah, anything to add? So excellent.
Okay, thank you. Dr. Zhao?
No further comments. Thank you.
All right, thank you. And I'll open it up to the rest of the committee. Are there any additional comments on this charge question? Okay, not seeing any, so I guess I will turn it back to EPA to read subpart 3B.
I'm Anne Fong from EPA. Charge question 3B for estimating risk from inhalation route of exposure. EPA has preliminarily determined that the LOAEC for nasal damage from CHO ETAL 2023. HEC equals 2 ppm, total UF equals 100. And the ZZU 1995, HEC equals 4.3 ppm, total UF equals 300. And the lung TPOD BMDL, HEC equals 0.45 ppm, total UF equals 30. From the 5-day transcriptomic study are all co-critical in the derivation of the PODs and the HECs to be applied across all durations. Please comment on the use of these 3 studies as co-critical, including the use of the TPOD, HEC equals 0.45 ppm, total UF equals 30, from the 5-day transcriptomic study for risk evaluation. Please also comment on the preliminary conclusion that shortened exposure durations are protective of longer durations, as longer-term adverse effects were observed to be less severe in many studies, following an inverse duration response pattern.
Thank you. And I'll turn it back over to Dr. Wolf, who's the lead discussant on this question.
Yeah. You'll get tired of me by the end of this. So this had quite a diversity of thoughts, but I'll present all of them. We haven't had any chance to work through some of these somewhat differing opinions, but I think we will in the final write-up, but I'll have all the information out there. So the primary issue is whether EPA's preliminary determination to treat the nasal toxicity findings from Cho et al. And Zizou, together with the lung transcriptomic point of departure from the 5-day inhalation study as critical studies, is scientifically justified for deriving inhalation risk values across exposure durations. A related issue is whether the available evidence supports EPA's conclusions that shorter duration exposures are protective of longer duration exposures due to an apparent inverse duration response relationship, in which adverse effects observed following longer exposures were not more severe than those observed during shorter exposures. One discussant suggests that the toxicogenomic study is a better study to use for POD selection and risk determination than the Cho or Zizou studies. The discussants agree that the use of multiple co-critical studies appears reasonable because the selected studies evaluate distinct yet biologically relevant endpoints in the respiratory tract, including apical tissue injury and early molecular perturbations. The transcriptomic POD provides a sensitive measure of biological response, while the nasal lesion studies provide direct evidence of adverse effects. Together, these endpoints strengthen the overall weight of evidence for inhalation hazard characterization. The use of these studies as co-critical seems appropriate based on the available data, though there are notable limitations in these existing data resources. In terms of the lung TPOD BMDL, this value is based upon a 5-day whole body inhalation exposure condition, which also has its limitations. The whole body inhalation exposure design has limitations in that exposures are spread across dermal and inhalation routes, and the actual inhaled dose in the nose lung differs from the whole body applied amount. This limitation could have been addressed through tissue chemical measures in the lung, which were provided by NIEHS, followed by extrapolation to inhalation concentrations in the lung. Furthermore, the exposures were limited to female mice and rats when there is a massive amount of literature showcasing sex-specific vulnerabilities to exposure. The current one-line justification for this on page 30, given that existing toxicologically studies do not report gender-specific effects, only female rodents were used, needs more detail and justification. One discussant pointed out that uncertainties remain regarding the interpretation of early transcriptomic changes as predictive of adverse outcomes and the biological plausibility of the reported inverse duration response relationship across studies. I think, as an aside, again, predictors of adverse outcomes, and we have to differentiate that from identifying protection points of departure for protection goals. So we may sometimes want to be able to predict an adverse outcome, but the main goal of these types of assessments is to provide protection from any potential adverse outcome, regardless of what it is. So considering the weaknesses of the Zissou and Cho studies, EPA has more confidence in the strength of this approach, which is the teapot approach. So one discussant agreed with the statement about the weaknesses, so long as the transcriptomics are evaluated as suggested in response to question one discussant pointed out that using the Zissou study to set any kind of safety level is a gross overinterpretation of the data presented in the paper. One discussant pointed out that the goal of the Zissou study was to identify histologic alterations in the respiratory tract. It does not specify which dichlorobenzene is used. Using 50% respiratory depression as the indicator of dose and determine dose response does not represent how much chemical is actually arriving at the target site and how long it stays at the site. By depressing the breathing rate, the exposure time of an irritating substance at the surface of the respiratory tract could substantially increase the likelihood of tissue response and confound the exposure, as the duration of exposure is very different between RD50 and 0.3 RD50. As is typical with volatile chemicals, one sees the most severe lesions in the area of highest airflow. Within a short time, the severity decreased from very severe to moderate. From a complete loss of olfactory epithelium and partially denuded basement membrane for 4 days, but moved toward repair of olfactory epithelium at 9 and 14 days, instead of metaplasia suggesting adaptation to exposure leading to healing, and not change of the surface epithelium leading to a protective epithelium. It is also significant that no effects were seen in the trachea or lungs at these very high doses. Rodents are obligate nose breathers, unlike humans, and the nasal respiratory tract is structured very differently than humans. The conclusion of this work in the Zissou paper was that using the RD50 was not an acceptable way to select doses for mouse inhalation studies. Therefore, it's an overinterpretation to use these data for anything else. The discussants do agree with the EPA's assessment that the data presented in Zissou are inadequate for BMD modeling. In the Cho study, in the liver, as an aside, the response looks more like cholangiofibrosis than hepatotoxicity, and is consistent with the increased ALP in the liver, which can increase with damage to the biliary tree. One discussant suggests that the nasal damage data in Table 9 of Cho et al. Could be adequately BMD modeled, particularly if the data are treated as categorical or properly converted into dichotomous data. Currently, the draft lacks transparency regarding exactly which BMD modeling approaches and software tools the EPA attempted to use before deciding the data could not be modeled. Because successful BMD modeling is always preferable to a default LOEC approach, applying a LOEC to NOEC uncertainty factor of 3 for the Cho study is premature and potentially inappropriate without a more rigorous modeling attempt. One discussant agreed that the selection of Cho and Zissou as co-critical studies is supported by the observation of adverse effect in the upper respiratory tract, a known target tissue for inhaled irritants and volatile organic compounds. All of these studies provide apical evidence of nasal toxicity and offer direct relevance for human health risk assessment. The use of human equivalent concentrations further improves their applicability for risk estimation. The inclusion of the 5-day transcriptomic study as a co-critical line of evidence is also scientifically defensible. The lung T-pod is lower than the apical pods identified in nasal toxicity studies and may reflect an earlier biological response that precedes observable tissue damage. Transcriptomic approaches are increasingly recognized as valuable new approach methodologies for identifying sensitive biological perturbations and complementing traditional toxicological endpoints. The application of a lower total uncertainty factor reflects EPA's confidence in the biological relevance of the molecular response while accounting for remaining uncertainties. And I think that was that's been a consistent agreement amongst the reviewers. There is general agreement that integrating transcriptomic and applicable endpoints within a weight of evidence framework can provide a more comprehensive assessment of toxicity than reliance on a single study or endpoint. One discussant pointed out that there may be uncertainty about the extent to which transcriptomic changes observed after 5 days of exposure can predict adverse outcomes following chronic exposure. Additional information linking the affected pathways to establish adverse outcome pathways could further strengthen confidence in the selected TPOD. However, one discussant also pointed out that in this case, the goal should be to determine a protection level and not predict an outcome. Thus, the TPOD, even without tying it to an applicable outcome, can be used for establishing a protection goal. The conclusion that shorter duration exposures are protective of longer duration exposures warrants careful observation. One discussant suggested that the observation of an inverse duration response pattern is unusual. However, another discussant pointed out that adaptation to persistent exposure is not that unusual and is frequently seen in the liver and thyroid, for example. While many toxicological responses increase with exposure duration, they can also be very much dose and mechanism dependent. Several biological explanations may account for this pattern, including adaptive responses, tissue repair mechanisms, metabolic adaptation, or differences in study design and endpoint sensitivity. Regarding the preliminary conclusion on exposure durations, most discussants agreed with the EPA that shorter exposure durations are protective of longer durations, given the inverse duration response relationships observed in the broader literature. Because of this, utilizing the 0.45 ppm lung TPOD from the 5-day transcriptomic study for risk estimation is a scientifically reasonable approach, especially when evaluated alongside the higher values derived from Zissou and Cho et al. Even though there is agreement with the ultimate protective utility of the 0.45 ppm lung TPOD and the assessment, it's recommended that the EPA reevaluate the Cho data using appropriate BMD modeling tools designed for categorical or dichotomous data. If successfully modeled, the resulting BMD estimate for nasal damage would likely be higher than the 2 ppm LOEC value. Consequently, the derived POD for that specific study would be greater, as the uncertainty factor L of 3 would no longer be mathematically necessary. Documenting this attempt may strengthen the overall rigor and transparency of the hazard assessment. And there were differing opinions on the short-term protecting for the chronic adverse outcome. One discussant pointed out that while the available data may support EPA's interpretation, the inverse duration response relationship should be considered a source of uncertainty rather than a fully established biological phenomenon. A different discussant did not agree with that point of view and suggested that short-term endpoint, particularly in the respiratory tract, can and have been used by the agency to protect against long-term effects from exposure. The agency has performed similar risk evaluations for inhalation risk to chlorothalonil and formaldehyde. The agency should affirm that longer-term studies did not use less sensitive endpoints and that early effects did not resolve over time. One discussant suggested that the agency could provide additional biological context linking the transcriptomic pathways underlying the lung TPOD to establish adverse outcome pathways and respiratory toxicity mechanisms. Specifically, EPA should identify the key pathways of genes driving the lung TPOD and discuss how these molecular responses relate to known events associated with respiratory injury, including oxidative stress, xenobiotic metabolism, inflammatory signaling, epithelial cell damage, tissue remodeling, and impaired pulmonary function. Where possible, EPA should evaluate whether the affected pathways align with existing AOP frameworks or with mechanistic evidence from inhalation studies of chlorinated aromatic compounds and volatile organic chemicals. Another discussant agreed with this approach, as the tissue approaches described are dose-dependent Another discussant disagreed with this approach, as the tissue responses described are dose-dependent and not in line with recommendations made in response to charge question one regarding not using mechanism-based subsets of genes in lieu of the entire gene set for BMD analysis. The preliminary conclusion that shorter exposure durations are protective of longer durations may not be accurate or public protective, though select reproductive and developmental toxicity studies have been carried out for o-DCB after more chronic repeat exposure conditions. These studies are limited in terms of tissues evaluated post-exposure. Furthermore, there is plausibility for the bioaccumulation of o-DCB and potential for initiation of other outcomes that not captured through acute toxicity testing outcome prioritizations. For example, one of the findings from the ADME analysis is that o-DCB is distributed throughout the body with greater partitioning or retention in adipose tissue, kidney, liver, and bladder. It is important to evaluate targets of toxicity in addition to direct targets from acute exposures, particularly for chemicals that bioaccumulate in adipose or chronic exposure endpoints. One discussant suggested to further evaluate the biological basis of inverse duration response relationships and provide a more detailed discussion of alternative explanations. EPA should examine whether adaptive responses, metabolic enzyme induction, tissue repair mechanisms, receptor desensitization, or homeostatic compensation could explain the reduced severity observed in longer duration studies. In addition, EPA should discuss potential methodological factors, including differences in study design, exposure concentrations, endpoint sensitivity, histopathological evaluation methods, statistical power, animal age, and timing of tissue collection. Comparison of transcriptomic, biochemical, and apical endpoints across exposure durations may help determine whether the apparent inverse duration response reflects a true biological phenomenon or differences in study sensitivity. A different discussant did not agree and felt this level of evaluation is not necessary to determine protection levels, as the goal is to protect from developing a hazard and not to predict what hazards might develop from exposure. So there.
Thank you, Dr. Wolf. I'll check with the other discussants on this question. Dr. Rager?
Dr. Wolf did a great job. No further.
Thank you very much. Dr. Lovato?
Yeah, the same. I've been checking all the answers from Dr. Wolf and did a terrific job. Yeah, he also put all the agreements and disagreement in the group. So yeah, anything to add? It's great.
Okay, thank you. Dr. Zhao?
I do have some comments, additional comments on the Cho et al. BMD calculation. I mentioned in my comments that probably can be done using the categorical BMD modeling, and I conducted that in my the system, the Bayesian benchmark dose modeling system I developed, my group developed, and it's successfully carried out, and I think the results are very reasonable. And the result from this categorical data analysis, categorical BMD analysis, the BMDL equals to around 2 ppm. So it's no longer 30 ppm anymore. So currently the EPA uses Lowell as 30 ppm and then divided by 3, that's about 10. If we use the categorical regression, then it changed to 2 ppm. So that's a 5 folders lower than the current value. And if that's the case, then that will change the result, change something, because the proposed POD from this study, from the Cho study, will be smaller than the one from the genomic data. I just uploaded the file to the shared folder.
Okay.
Yeah.
Yeah, I was going to ask
but-
you if you have the ultimate file and spreadsheets to go with that, so we can provide that in response to this question to the agency, so they can see your work.
Sure. Well,
Yeah.
later after the meeting, I certainly will draft a more detailed report on that.
That'd be great, and then we'll just insert that into the response to the question in the final report.
Yeah,
Perfect.
so I know there's not a lot high quality categorical data available in literature, and actually this one is a very good one, and it can be modeled. And also, I think EPA attempted convert the categorical data to the dichotomous data, and then model the dichotomous data. Well, I don't recommend that if we do have a tool to model the categorical data directly. Because when you convert the categorical data to the dichotomous data, you certainly lose some information. And this one particularly, I think because EPA set the level 1 and the level 2 as a threshold to determine it's abnormal or normal. And once we use that like threshold to convert the categorical data to dichotomous data, I think a lot of very important information disappeared or just ignored by this conversion. So my recommendation is directly model the data as categorical data, and then use the categorical 1, which is defined by the EPA as the adverse versus non-adverse, then basically based on that curve to determine the BMD. So that's something I would like encourage EPA to further investigate. And there's a little bit of more general comment. I think when I review this document, I think I find one or two places mention that something like the BMD software cannot adequately analyze the data, and so we don't use the results, something like that. Well, I do want encourage EPA to investigate some alternative options. I know there is one like a toxicological profile document prepared by ATSDR. They first choice is using EPA's BMDS, but for that particular data set, they find that that's the most important data set. The EPA's BMDS failed, all kinds of way they tried, it all failed, but they used another software and then succeed. And then they use that to analyze the data. So I think my general comment on that is we should never use an excuse saying that the software cannot handle that, so we do not use the data as an excuse to exclude the data from being analyzed or being used as important evidence to derive POD or some similar quantity. So that's my comments. Thank you.
Okay, thank you, Dr. Zhao. I think I'll open it up just to see if any of the other committee members have a comment.
I have a quick question for better understanding of this approach. How does this account for tissue repair following an insult, considering that the genomic approaches tend to be more sensitive as compared to tissue response versus a proteomic approach? I find them a little more too sensitive, so to speak. Could you please comment on that?
Well, I'll take a stab, and then we could also pull in some of our EPA colleagues. So from my feeling, So first of all, the goal is protection. So there's nothing wrong with the transcriptional approach being more responsive to exposure and having an effect. So that's the sensitivity issue in an EPA construct, because we're trying to be precautionary and health protective. And repair, again, when trying to select, in this case, a benchmark response to select a point of departure, is irrelevant because that's not a consideration for selecting the point in the curve where you're saying there's not going to be a transcriptional response. So it's not, are we overcoming repair or are we going to have repair? It's that nothing's happening. And that's what you're trying to find. And once you find that point, then all doses below that won't cause any response either.
Sure.
And it's never, I mean, somewhere above that dose probably is also safe because you do repair and you do can deal with whatever chemical, but we're trying to find here a sensitive marker of tissue response that we can use to prevent anything downstream. And so, yeah, a lot of those things that we consider, particularly in a clinical setting, as a old cow doctor, in a clinical setting or that type of thing, we worry about what you're talking about. But in this particular case, we're trying to prevent all those things in the U.S. population.
Thank you.
Hopefully that clarifies the.
Thanks.
Okay, thank you. Anyone else? We've been pretty deep in the details the last while since lunch. I'm wondering if folks need a quick 10-minute break before we keep moving on. Any
Should
thoughts?
we have any clarifying questions or comments from the agency?
Oh, yeah. Thank you, Dr. Wolf.
Did I confuse the agency enough that they're not going to?
Any clarifying questions from the EPA?
Hi, this is Karen Eisenreich, EPA. We do not have any clarifying questions, comments.
Okay.
Thank you. All right. Any thoughts on a quick break, or we want to keep going? All right. Let's take a 10-minute break and then we'll get back to it. So if you'll set the timer, we'll rejoin in 10 minutes.
Excuse me, sorry, I couldn't hear it.
Do we need to take a quick roll to ensure quorum since we took a break?
We took roll in the afternoon already.
Right.
So I think we're okay.
Okay. I wanted to check before we started up again.
Sure. Thank you.
Okay. I guess with that, EPA, if you're ready, we'll start with reading question 3A into the record.
I'm Ann Huang from EPA. Question 3C for estimating risk from the oral and the dermal routes of exposure to orthodicarbenzene. EPA has preliminarily determined that BMDL from Robinson et al. 1991, HED equals 12 milligram per kilogram per day. Total UF equals 30. Umemara et al. 1996, HED equals 11 milligram per kilogram per day. Total UF equals 30. And the liver BMDL, HED equals 8.26 milligram per kilogram per day. Total UF equals 30. From the 5-day transcriptomic study, are all co-critical in the derivation of the PODs. Further, it was concluded that HEDs are applicable across all durations as discussed briefly below. Please comment on the use of these three studies as co-critical, including the use of the POD from Umemara et al. 1996. HED equals 11 milligram per kilogram per day. Total UF equals 30 for risk estimation. Please also comment on the preliminary conclusion that shortened exposure durations are protective of longer durations, as longer-term adverse effects were observed to be less severe in many of the available studies. Please also include in your comments the strengths and weaknesses of the root-to-root extrapolation conducted in extrapolating inhalation values from the transcriptomic study to oral doses.
Thank you. And again, we will go back to you, Dr. Wolf.
All right. Let's see. The use of these three studies as co-critical seems appropriate based upon the available data, though there are notable limitations in these existing data resources. For example, Umemara et al. Evaluate a single-dose exposure to o-DCB via intragastric administration in corn oil at multiple doses in male mice. The issue of sex-specific evaluations is present here, where this study selected males. Select endpoints in liver were captured after this single instance of exposure and included some endpoints collected at the highest dose up to 7 days post-exposure. In addition, endpoints seem to be limited. Data from this study should be interpreted with caution, particularly since it is being carried forward for one of the co-critical BMDLs. The determination that Robinson's et al., Umemara et al., and NIHS 5-day studies generate co-critical PODs is well justified and scientifically correct. While Robinson et al. And Umemara et al. Studies do not provide mechanistic data, they provide robust apical PODs, which are relatively close to the 5-day NIHS study, which produced the TPOD. Protection goals can be achieved from preventing the acute or short-term surface damage from a direct-acting cytotoxic agent by inhalation. This was established in the chlorothalonil OECD IETA and the recent formaldehyde evaluation, where preventing the acute effects protects from any chronic effects. The idea that shorter exposure durations are protective of the long-term adverse effects is well justified in the assessment and scientifically sound. One discussant had technical concerns regarding the BMD modeling of the Umemara et al. Data with respect to EPA's effort to identify co-critical studies for the derivation of oral and dermal PODs. Specifically, the variances in this data set are significantly different across the various dose groups. When there is non-constant variance across dose groups, relying on a BMR of 1 standard deviation can be inappropriate, as the 1 standard deviation metric is highly sensitive to the modeled variance. In this scenario, it is recommended that the EPA define the BMR based on a relative change, such as a 10% relative deviation, rather than relying on a 1 standard deviation change. This would provide a more statistically robust and biologically meaningful BMDL estimate for risk estimation. One discussant suggests that chemicals such as DCB, which produce cytotoxicity, inflammation, proliferation response in short term, tend to produce fibrosis, cirrhosis type changes in long term. The 90-day study did not provide any data on this, but the question is still open-ended. A different discussant disagreed with this point in that when no relevant effects as described are not present in the 90-day study, it is unlikely to have them suddenly arise after longer-term exposure. And there's some references given to support that conclusion. This approach is, the approach that EPA uses sound, especially because ETAP-based use of short-term studies to determine TPODs for risk assessment is a relatively novel idea. Such comparative analyses will improve confidence on using ETAP, Additionally, the available studies show that the nasal respiratory responses from exposure to longer periods results in adaptation to the agent and decreased severity of the tissue response. Although there was not unanimity of opinion on the use of the short term to protect for the chronic exposure effects, some discussants pointed out agreement with EPA's preliminary conclusion regarding exposure durations. The observation that longer-term adverse effects are less severe in many of the available studies supports an inverse duration-response relationship. Therefore, relying on data from shorter exposure durations to establish PODs is a scientifically sound approach, as it is inherently more protective of human health across all durations. One discussant suggests that using the old studies when one has the more credible toxicogenomics data for dose response characterization across tissues and better characterized blood and tissue concentration seems to be unnecessary. The newer study with high content data and better characterization for exposure concentration and response is more informative for selecting health protection PODs. The only caveat is that the final BMRs should be based on the conclusions from the response to the comments from charge question 1. There were some specific comments, there seems to be, and this came up a few times, on page 12, line 494, 495, mentions for inhalation exposure with POD of nasal lesions of 0 ppm, which then extrapolates to 11 milligrams per kilogram per day. The 0 ppm doesn't make sense, so that's in here to see if that's correct or not. There's a general comment on ADME. The fact that o-DCB is distributed adipose tissue in a significant quantity is critical for risk assessment. This is because close to 40% of U.S. population is either overweight or obese and could potentially have significantly higher body burden. Further significant evidence exists that 2 factors critical for DCB metabolism, including CYP2E1 activity and hepatic GSH levels, are both affected in people with obesity in a manner that likely increases the toxicity. Obesity induces CYP2E1 levels and decreases hepatic GSH, resulting in a condition where more toxic intermediates of DCB are produced while the protective cushion provided by GSH is reduced. A revised PBPK model could be potentially useful in generating various scenarios. This is further critical because both CYP2E1 and GSH will affect short-term effects and long-term effects. And I think relating that to the liver responses, the liver concentrations and the relevant responses in the transcriptomic might be very interesting and informative. And then the other question is, for the agency is, does the uncertainty factor policy cover for those differences one might see in susceptible subpopulations such as the obese community? The 90-day OECD guideline inhalation study identified major adverse effects in the nasal cavity, which are consistent with the fact that nasal epithelium expresses high levels of CYP2E1, which is the primary metabolic enzyme. Unfortunately, nasal lesions were not analyzed in the 5-day in vivo study for which T-pods were derived. And I guess you didn't take nasal respiratory tissue for transcriptional evaluation, although there are published methods on how to do that. So something to consider in the future. This is a major missed opportunity, especially because the agency is now considering shorter exposures, health protective long-term effects. The agency describes mechanisms of DCB liver toxicity are unclear. This assertion contradicts significant evidence on DCB mode of action in the literature, a lot of which has been well reviewed here. So it's not understood why the agency had that. So you might want to go back again. The page level line number and everything are in there for you to take a look at that particular statement. We read every word, agency. In terms of dermal exposure, the statement on page 52 that respiratory toxicity is the most appropriate endpoint of risk estimation via the inhalation route and thus effects are not applicable to other routes requires explanation, given that the respiratory toxicity tests were done using whole body inhalation exposures. While whole body inhalation exposure in mice and rats contributes to dermal exposure routes. And there's a reference given. For comments on shorter exposure durations being protective long duration, see responses to charge question 3B. In addition, authors report on page 45 stronger effects in the high dose group and at 90 days compared to 10 days of exposure, explaining findings from Robinson et al. 1991, which goes against the conclusion that shorter exposure durations are protective of longer durations. Weakness in the root-to-root extrapolation conducted, including the following: differences in metabolite generation were not incorporated, which are important seeing as inhalation exposure routes likely offer more time and tissues to metabolize o-DCB post-exposure before it reaches the liver. Furthermore, dermal limits are based off oral ingestion studies, which induce a large difference in metabolite generation as opposed to direct content on the skin with the parent compound. A specific comment is regarding a necessary technical correction using the BMD modeling for the Robinson et al. Data detailed in Appendix A4, which upon reviewing table Appendix A6 and table Appendix A7, the selected model should be explicitly identified as the linear model rather than the power model. The modeling output clearly demonstrate that the estimated parameters for the power model, as well as some other models, are exactly the same as those for the linear model. From a statistical and BMD modeling best practices perspective, when a more complex model reduces down to the simplest model, evidenced by identical parameter estimates, the simplest model, in this case the linear model, should be the one formally selected and reported. And that's our comments. Would like to say that you have transcriptional profiling in the lung, and then the lung, the lung tissue concentrations of the chemicals. And so the same goes for the lung as the liver in evaluating the transcriptional profiling changes relative to the lung concentration. Because there's so much blood in the lung, you'll want to balance that with what the blood concentration is as well, but you have those data as well. So I think there's a real opportunity here to dive a little bit more deeper into the lower respiratory tract effects. However, in the studies, the lungs were not impacted, although I'm sure the chemical got into the lung, and just the nasal respiratory tract were affected. So that's all. Off to the fellow reviewers.
Right. Thank you,
It's
Dr.
after 4, but this is water, not vodka.
Thank you for clarifying. I'll go to the associate discussant, Dr. Opti.
Yeah, hi. Dr. Wolf got all of my comments. I just want to re-emphasize one comment that he captured, and that is about the obesity and fat distribution of the chemicals that actually are soluble in fat. And, I think it's important for EPA to understand that they're doing risk assessment for pretty much everybody and not specific populations. One thing I did realize that the average body weight used is 80 kilograms, which is a very good estimate based on what Enhance and CDC now consider the body weights, and not 70, which used to be traditionally used, which is a good thing. But I think having a specific consideration for fat distribution, release from fat, and how that would affect metabolism, as well as apical effects and transcriptomic effects when chemicals that we are reviewing are fat soluble or are distributed in fat or have a depot effect. I think a special emphasis on that would be very important going forward, because that's a large population we're talking about now. Thank
I
you.
think that's an excellent point, Dr. Apte. Again, if you look at the high quality toxicogenomics study that NIH has performed, where they're looking at tissue concentrations, and to your point, if a chemical can concentrate in adipose tissue, it's pretty easy to grab adipose tissue from a rodent. And if you go into all the trouble analyzing tissue concentrations, I
Yeah,
know
you
it's
might
not
as well
simple.
use that. Yeah.
Scott Auerbach's head just exploded, but I know it's not simple, but you know, it it would answer those kinds of questions, which are going to continually come up. And also, you know, as you start developing physiologically based models for these to back calculate what the allowable exposure concentrations should be, those kinds of data, what's in the adipose, what's in the liver, what's in the wherever the other organs that are critical for that particular chemical, will be very useful in those back calculations. That's a very good point.
Okay, thank you. Dr. Rager.
Hi, thank you. I actually think a lot of our feedback was pretty concurrent across your responses, and I think Dr. Wolf did a great job of combining them. And it was great to hear Dr. Apte's continued input on the adipose angle. I noticed the same thing with EPA doing ADME and noting that these compounds accumulate in fat, and yet it wasn't discussed much as a potential impactor of toxicity. So I appreciate Dr. Apte's expertise.
Thank you. Dr. Zhao.
I don't have much comment. Dr. Wolf already mentioned, so I pointed out there are some inconsistency in the BMD analysis in the tables in the appendix, especially regarding the Robinson et al. 1991 data sets. But another thing is I want to point it out is that, well, if EPA take a close look at the results in those tables, they will soon very quickly find out that although they fit a lot of the models to the data, but actually a lot of the data, a lot of the model actually reduced to the simplest linear model. So that is something I recommend EPA to consider how reliable the BMD analysis are for those data sets. So that's my comments. Thank you.
Okay, thank you. Any other committee members want to add any comments? Dr. Cobb.
This is a, thank you, Dr. Gentry. This is a comment related to the adipose tissue. In our last meeting, this was a major point of discussion with the use of weight loss drugs now, the GLP-1s and others, causing rapid weight loss, and that would be rapid depletion of fat tissues, which would give you pulses of fat-soluble chemicals into the bloodstream. Probably beyond the scope of this particular evaluation, but something that the EPA does need to keep an eye on.
Okay, thank you. Anyone else? Okay, EPA, do you have any clarifying questions?
Hey, this is Karen Eisenreich, EPA. We do not have any clarifying questions for you.
All right, thank you. I guess we're ready to read charge question 4A into the record.
I'm Ann Huang from EPA. Charge question 4. As discussed in section 2.5 of the draft Human Health and the Environmental Hazard Assessment for HHCB and in section 2.4 of the draft Human Health and the Environmental Hazard Assessment for o-dichlorobenzene, EPA previously used the Rethinking Chronic Toxicity and the Carcinogenicity Assessment for Agrochemicals Project recap. Weight of evidence framework, Hilton, ETL 2022, OECD 2024 as an organizational tool to evaluate the extent to which the lack of carcinogenicity studies imparts significant uncertainty on the human health risk assessments for diisobutyl phthalate, DIBP, and the dicyclohexylphthalate, DCHP. The application of a recap to the DIBP and the DCHP human health risk assessments was reviewed by SACC in 2025. EPA has developed recap weight of evidence evaluations for HHCB and o-dicarbenzene, since there are no cancer bioassays reasonably available for each chemical. For A, in section 2.4 of the draft human health and environmental hazard assessment for o-dicarbenzene, EPA preliminarily concluded that the lack of cancer bioassays is not a significant source of remaining scientific uncertainty in the risk characterization for o-dicarbenzene, and that the non-cancer POD is health protective, including for potential cancer effects. Please comment on EPA's preliminary conclusion and the associated strengths and the uncertainties of the recap evaluation.
Thank you. And now I will turn it over to Ms. Jenkins, who's the lead discussant.
Yes. Okay. The recap analysis has been performed thoroughly and comprehensively. The agency did a great job in applying the recap integrated approaches for testing and assessment framework. The read-across approach is appropriate and adds value to the analysis. EPA uses the recap framework because it finds insufficient evidence to evaluate carcinogenicity using standard cancer assessment approaches. The most scientifically important issue for this charge question is whether EPA's conclusion is adequately supported by the non-cancer target organ evidence, especially the respiratory and liver data sets, and by EPA's comparison of transcriptomic points of departure, or TPODs, with apical pods. EPA states that the evidence supporting dose response analysis is strongest for respiratory system toxicity, liver toxicity, kidney toxicity, and body weight changes, and that the transcriptomic analysis is used to characterize gene expression changes plausibly associated with adverse outcomes and to derive organ-specific TPODs that are compared with apical pods to increase confidence in the values selected for risk estimation. From a weight of evidence perspective, the absence of direct bioassay results does not significantly undermine the preliminary cancer classification. In just a moment, let me find my mouse. I am sorry. Okay, let me start. From a weight of evidence perspective, the absence of direct bioassay results does not significantly undermine the preliminary cancer classification. Viewed from another angle, even if chronic cancer bioassay results were to become available in the future, it is highly unlikely that the fundamental cancer classification would change significantly, given the absence of corresponding signals in the epidemiological data and the broader body of supporting mechanistic evidence. Some of the strengths we identified, a major strength of EPA's evaluation is that it does not rely on the absence of cancer bioassays alone. Section 2.4 is organized around multiple evidence streams. EPA also stated that it updated the literature specifically for cancer information and performed a read-across analysis to address the absence of a chronic inhalation study. The transcriptomic study represents a particular strength because EPA states that the non-cancer database is supplemented by a new 5-day whole body inhalation toxicology and transcriptomic dose response study conducted with the National Institute of Environmental Health Sciences. EPA stated that it independently analyzed the transcriptomic data to characterize gene expression changes plausibly associated with adverse toxicological outcomes and derives TPODs for organ systems relevant to the hazard assessment. EPA further states that the resulting TPODs are compared with apical pods to increase confidence in the value selected for risk estimation and to promote use of the best available science. For the respiratory system, EPA stated that the derived TPOD for lung toxicity is an HEC of 0.45 parts per million with a total uncertainty factor of 30, and that this value is considered a robust and representative hazard threshold for respiratory toxicity. In Table S-1, EPA describes the respiratory evidence as coming from mice over a 4 to 90-day duration range with observed effects, including nasal olfactory tissue damage and mechanism-informed superset gene expression. The same table lists 0.45 parts per million as the leading co-critical value from the transcriptomic analysis and 2.0 parts per million and 4.3 parts per million as additional co-critical pod values from apical inhalation studies. This represents a strength because the report shows a direct comparison between transcriptomic and apical inhalation evidence in the same target organ system rather than relying on transcriptomics in isolation. For respiratory effects, EPA identifies Table 2-6 for candidate respiratory toxicity endpoints and Table 2-12 for non-neoplastic respiratory lesions in rats and mice following short-term, subchronic, and chronic exposures to o-dichlorobenzene and read-across analogs. Appendix A includes benchmark dose modeling. These entries indicate that the liver and respiratory evaluations are built from multiple endpoints, multiple studies, and multiple study durations, rather than from a single isolated observation. For the liver, EPA stated that the derived TPOD for liver toxicity is an HEC of 7.48 parts per million, extrapolated to a human equivalent dose, or HED, of 8.26 milligrams per kilogram day, with a total uncertainty factor of 30. EPA also states that the most appropriate oral dermal pod is an HED of 11 milligrams per kilogram day for liver toxicity, also with a total uncertainty factor of 30. In Table S1, EPA describes the liver evidence as coming from mice and rats over a 1 to 90-day duration range, with observed effects including increased liver weight, serum ALT, histopathology, and mechanism-informed superset gene expression. The same table lists 11 milligrams per kilogram day from Yumamura et al. 1996, 12 milligrams per kilogram day from Robinson et al. 1991, and 8.26 milligrams per kilogram day from the transcriptomic analysis as co-critical values. This represents a key strength because EPA explicitly demonstrates that the liver TPOD and the apical HEDs are in the same general range and are evaluated together when selecting health protective values. The report also includes additional technical depth behind the liver and respiratory evaluations. For liver effects, EPA identifies Table 2-7 for oral liver pod derivation, Table 2-8 for candidate oral dermal liver toxicity endpoints, and Table 2-11 for non-neoplastic liver lesions in rats and mice following subchronic and chronic exposure to o-dichlorobenzene and read-across analogs. Appendix A entries include benchmark dose modeling for serum ALT in male mice, absolute and relative liver weights in male rats, absolute and relative liver weight in female rats, and serum ALT, absolute liver weight, and relative liver weight in female mice from the inhalation transcriptomic study. We identified some uncertainties. 2, The remaining limitation is also explicit in the report. EPA describes the cancer evidence base as insufficient for standard cancer assessment approaches and uses read across to address the absence of a chronic inhalation study. That means that the conclusion is supported by a structured organ-specific weight of evidence, but it still depends in part on indirect evidence rather than direct chronic cancer bioassay data for o-dichlorobenzene itself. Another uncertainty, the majority of the mode of action analyses support the conclusion that o-dichlorobenzene may be not carcinogenic to humans. However, the evidence that o-dichlorobenzene is clastogenic in vitro assays, and there's some evidence of similar effects in humans is a concern. The agency seems to be discounting these data in their evaluation. In summary, EPA's overall conclusion is that quantitative cancer risk assessment is not warranted, that additional cancer bioassays are unlikely to provide evidence leading to a different conclusion, and that EPA therefore does not identify a cancer hazard or derive a cancer hazard value for o-dichlorobenzene. The technical support for that conclusion is strong for the respiratory and liver systems because EPA explicitly ties those organ systems to both T-pods and apical pods. The overall conclusion that additional studies or analysis will not add any value and is not a source of uncertainty is correct. The available data, including all the transcriptomics data, are sufficient to make the conclusion that o-dichlorobenzene is not likely to be carcinogenic. Using all the data, these chemicals are non-genotoxic and certainly not mutagenic. A pod can be selected where there is no biological response based on transcriptomic alterations as well as no ALs across studies. There would be no additional value in conducting a cancer bioassay as the doses to cause a tumorigenic response would not contribute to risk assessment. The secondary component of this conclusion relies on whether the selected non-cancer pod is sufficiently health protective, including for any potential unobserved carcinogenic effects. As detailed in responses to charge question 3, the derived non-cancer pods, particularly the T-pods, are robustly health protective. This protectiveness is grounded in two primary methodological choices. The first choice is the distribution selected using the 5th percentile of the distribution of the gene sets and supersets, rigorously quantifies statistical uncertainty and provides a highly protective estimate that is resistant to biological noise and outliers. And the second choice, duration response dynamics, the reliance on shorter exposure durations to derive the pod is fundamentally protective of the longer term or chronic exposures, owing to the inverse duration response relationship observed in the broader toxicological database for o-dichlorobenzene. Because the non-cancer T-pod represents a highly sensitive early stage biological response, quantified using conservative statistical thresholds, it effectively bounds the risk for more severe downstream apical outcomes. Therefore, the non-cancer pod is demonstratively health protective, adequately mitigating concerns regarding the lack of a long-term cancer bioassay. And that concludes my reading.
Okay, thank you. I'll go to your other discussants. Dr. Wolf.
Okay. Dr. Jenkins did an excellent job of bringing everything in. The only thing I would add is there was a comment made by a public commenter about the recap was developed for agrochemicals and isn't relevant for other chemicals. And having it has gone through an OECD IATA approach where it's an internationally accepted integrated approach to testing and assessment. And that committee pointed out that this is, that the framework, that actually the work was developed so that the framework was broadly applicable and not just for agrochemicals. And OECD, I had a committee wanted to make sure that that was the case. The goal has always been, can you develop a risk assessment to protect against chronic toxicity, including carcinogenicity for those chemicals that are not directly acting mutagens. And that's what this approach does. And I think Dr. Jenkins did a great job explaining why we all agreed that, yeah, the EPA did it right.
Okay, thank you. Dr. Apte?
Yeah, my comments were all captured. Thank you, Dr. Jenkins. I also want to reiterate what Dr. Wolf just said about recap and its use for other than agrochemicals. I think it's a very valid way to use it. And these tools that we are developing, they shouldn't be restricted to one set of chemicals. If they're useful, then we should use them across the broad range of chemicals. So I think I totally agree with that.
Okay, thank you. Dr. LaRocca?
I think Ms. Jenkins did a really nice job summarizing everything and just want to highlight that I agree this was a really great example of the application of recap.
Okay, thank you. Dr. Zhao?
Same here. No more comments. Very well summarized. Thank you.
Thank you. Any other committee members? Okay, any clarifying questions from EPA?
Hi, this is Karen Eisenreich, EPA. We do not have any clarifying questions. Thank you.
Okay, thank you. So I guess we'll read charge question 4B into the record.
I'm Ann Huang from EPA. Charge question 4B. In section 2.5 of the draft Human Health and the Environmental Hazard Assessment for HHCB, EPA preliminarily concluded that the lack of cancer bioassays is not a significant source of remaining scientific uncertainty in the risk characterization for HHCB, and that the non-cancer POD is health protective, including for potential cancer effects. Please comment on EPA's preliminary conclusion and the associated strengths and the uncertainties of the recap evaluation.
Thank you. Okay, back to Ms. Jenkins.
Okay. 4B. EPA uses elements of the recap framework in section 2.5 because no carcinogenicity bioassays are available for HHCB. EPA states that this framework is used to evaluate whether the lack of carcinogenicity studies create significant remaining scientific uncertainty in the human health risk assessment. EPA's overall conclusion is that the lack of carcinogenicity bioassays does not result in significant remaining scientific uncertainty, and that the non-cancer pod is health protective, including for potential cancer effects. This conclusion is supported by the breadth of evaluated evidence domains and the structured recap approach, but it still relies on integration of indirect evidence streams rather than direct carcinogenicity data for HHCB itself. Discussants agreed that the lack of cancer bioassays is not a significant source of remaining scientific uncertainty and that the non-cancer pod is health protective. In general, the agency did a good job in explaining why a chronic carcinogenicity study would not add appreciably to deriving health protection from exposure to HHCB, and the recap analysis was characterized as scientifically sound. This approach was supported by a previous SACC review. The basic argument is well organized to show that there's no general genotoxicity and specifically no direct mutagenicity from exposure to HHCB in any test system. Therefore, any potential carcinogenic response would be from long-term exposure of a sufficient dose to result in chronic toxicity. The strengths we identified, the available studies show that there is a lack of systemic toxicity even at fairly high exposure doses for up to 90 days. There is evidence that when no systemic toxicity is identified after 90 days, then there will likely be a lack of tumorigenic response after 2 years of exposure. And citations are provided for Bubis et al. 2009, Mystery et al. 2021, and Allen et al. 2004. While it is helpful to have analog chemicals for comparison, it is not necessary for making the determination for the need or lack of a chronic carcinogenicity bioassay. And the reference for that is Getz et al. 2024. A major strength of EPA's evaluation is the comprehensive and explicitly structured coverage of multiple evidence domains, which aligns closely with the RECAP framework approach. Section 2.5 clearly identifies that EPA evaluated physical and chemical properties, toxicokinetics, acute and subchronic toxicity, genotoxicity, hormone perturbation, immune system perturbation, mechanistic evidence, and read across to related chemicals. This structure reflects a deliberate effort to integrate multiple lines of evidence rather than rely on any single data set. Another strength of the approach is the explicit inclusion of multiple mechanistic and systems level endpoints relevant to carcinogenicity pathways. EPA evaluated genotoxicity, endocrine or hormone perturbation, and immune system perturbation, which together represent major biological processes that can contribute to carcinogenicity. The inclusion of these domains is technically important under RECAP because the framework emphasizes evaluating whether key carcinogenic mechanisms can be reasonably excluded or supported using available data. A distinguishing strength of the HHCB assessment relative to O-dichlorobenzene is the breadth of negative or low concern findings across these domains. EPA explicitly evaluated and integrated evidence across genotoxicity, endocrine effects, immune effects, and chronic toxicity, rather than focusing primarily on target organ toxicity. This broader mechanistic coverage strengthens the RECAP-based argument because it attempts to address multiple plausible cancer-relevant pathways rather than relying on a limited subset of endpoints. In addition, EPA incorporates read across to related chemicals as part of the evidence base for carcinogenicity evaluation. This is consistent with RECAP guidance, which emphasizes the use of analog data and structural similarity to supplement incomplete data sets. The report also indicates that EPA evaluates evidence of chronic toxicity and carcinogenicity from related chemicals as part of the weight of evidence assessment. We identified some uncertainties in that. One is the most statistically significant uncertainty for cancer hazard is HHCB's endocrine disrupting properties, hormone-mediated carcinogenesis. For example, estrogen-driven breast or uterine cancer, androgen-driven prostate cancer is a recognized non-genotoxic carcinogenic MOA. Given that HHCB is a confirmed androgen receptor agonist in vitro and in vivo, it has shown possible estrogenic and anti-estrogenic activity in reporter gene assays, is detected in human blood, fat, and breast milk at measurable concentrations, and endocrine effects of it and its transformation product, HHCB-LAC, have been confirmed by endocrine disruptome analysis. We have some specific recommendations, and the first one would be to reference what Dr. Wolf just talked about, which is the HHCD, IATA, and because it's more current, has international agreement through the review process, through its review process. There was the recent paper by Getz et al. 2024. Let's see, there's some statements in section 2.5.4 that EPA made in quotation marks that would potentially precede tumor formation. And the comment is that while the statement is not completely incorrect, it is not relevant, as these changes can happen without evolving onto tumors, and one can have tumor formation without hepatocyte necrosis and increased liver enzymes. The more important finding is alterations in the liver that suggest hepatocyte hyperplasia, either a mitogenic response or associated with regenerative proliferation. In section 2.5.9, a comment, while it may be more difficult to craft a convincing argument with a lack of appropriate analogs for read across, the fundamental question of whether a chronic carcinogenicity study is necessary can still be addressed. And that citation is from Getz et al. 2024. In line 2106, there's in quotation marks pre-neoplastic lesions. And the comment, one would wish to show a lack of tissue level histopathology, the point being that one does not have to either show the presence of pre-neoplastic lesions nor the absence of pre-neoplastic lesions to support the lack of a chronic, lack of need of a chronic study. And in line 2109 to 2110, a comment that this is an important point for endocrine activity. The available in vitro assays are useful to identify the potential of an endocrine response or lack of potential, and or describe a dose response for IVIV interpretation. But there is currently still value of the in vivo data which confirm or refute that an endocrine response results in an adverse outcome. And one more recommendation for EPA to provide a structured weight of evidence summary table aligned with recap domains. And I think that concludes these comments for 4B. Thank you.
Okay, thank you. I'll check with the rest of your discussants on your question. Dr. Wolf?
Too many clicking. No additional comments. Ms. Jenkins did a wonderful job.
Okay, thank you. Dr. Apte?
Yep, no more comments. Great job. Thank you.
Okay, Dr. LaRocca?
I think that was a great summary and no more comments from me. Thank you.
Okay. Dr. Zhao?
Same here.
Okay, thank you.
Great summary. Thank you.
Thank you. Any clarifying questions from EPA?
Hey, this is Karen Eisenreich from the EPA. We do not have any clarifying questions.
Okay. Well, we are approaching the time for adjournment today. I don't think we'll try to squeeze in another question, but we have a little time to see if there are any stray comments or if EPA has any answers to our questions. Anyone? Dr. Cobb?
Yeah, thank you, Dr. Gentry, and thanks everybody again for all this great discussion. I had 2 points. The first is there was a discussion at some point, I think it was in the HHCB discussions about POTWs and the fact that FDA regulates some of the uses of that compound, and so that wasn't assessed. In the TSCA context, it doesn't matter. It's an effluent, it's going into the environment, and these assessments are done by FDA, are done for human use and in their intended use is not for end of life. And so EPA cannot fail to make those evaluations for that reason. That's number one. And number two, I asked a question about the concentrations for the hazard value, the HED for HHCB in the atmosphere, and EPA couldn't provide a number. I found that number in an appendix to the section that they referenced. It was not where they said, it was in a separate appendix. I am pretty sure that the calculated value that they provide in parts per million is in error. Now, that does, I think that the milligram per cubic meter or microgram per cubic meter value is correct, but I think the calculation is incorrect to get to parts per million. I don't think we need to belabor that. I don't think I need an answer from EPA on that. I simply want to point that out and have them double check that calculation, because I think there's a 3 orders of magnitude unit problem with the ppm that's reported in that appendix. And those are the things I wanted to say.
Okay. EPA, any response or any other clarifying questions from today?
This is Karen Eisenreich, EPA. Thank you for that, Dr. Cobb. We will make sure to go back and check that calculation for accuracy. Thanks for pointing that out. We will get back to y'all tomorrow morning regarding the other questions that you had that we were going to provide answers for. So yeah, we look forward to reading that in tomorrow morning.
Okay.
Otherwise, that's it from us right now.
And Dr. Gentry, if you don't mind, I just to reemphasize, I don't think the underlying mass per volume number is incorrect. I think that the conversion of that to ppm is a problem, and that's why I've always said try not to use that if you can at all avoid using ppm for any concentration unit.
Right, thank you. We will note that and check the conversion to parts per million.
Okay, I guess if there's nothing else, we'll adjourn for today. I would ask that the committee members remain on the line for just a few minutes. And then I'll turn it over to Dr. Kamal.
Thank you, Dr. Gentry. So I'd like to thank everyone today for these discussions. Thank you for the EPA team for presenting the first part of the meeting and to responding to the questions of the SACC. And thank you for the SACC members who led these discussions for the charge questions today. And also thank you for the public comments in the morning. And that said, we will meet tomorrow, and the meeting is